We open up for general discussion. They take questions directly. So if there's something that the discussant mentioned you think is essential, please feel free to follow up on that. And the first paper, again, is Spatial Concentration of Innovation over the very long run, and Yuri Ma is going to be presenting. Thanks.
Thank you very much for having us. This is joint work with Martin, who's here, and Ezra, and our Argentine colleagues who are probably watching us on TV to pregame for their big day tomorrow. And our team can represent the views of people from Asia, Europe, North America, South America, but not the Federal Reserve Bank of Richmond. So of course, innovations are extremely important for understanding growth, but this dice is not moving. But for most of our lifetime, they've been very difficult to measure. As we know, patent data are available for a select set of countries. Mostly in recent decades, there's been great effort to push them back further in time, but they also, as we know, lean more manufacturing and are not necessarily the easiest to compare across countries. R&D data are available for even smaller set of countries and much more recent. And in this paper, we have a modest aspiration to set the record of time spent for the EFG program by measuring innovation throughout human history, and we can go back 5 million years to the beginning of human history. And we will use the data set to provide empirical facts and use a model to understand them, and including issues like where do the innovations emerge and how they ultimately translate into output around the world. So this data set builds on Wikipedia articles, which is a rich repository of human knowledge. And initially, you will see some facts for 2,000 years, but we can go back 5 million years if you're interested. So essentially, we curate Wikipedia articles by filtering them for those about technological innovations. We will use them to document how tremendously concentrated innovations have always been through human history, and how the intensity of innovation shifts around the world in level and in shares, and also how they connect with growth. And then we'll have a framework of innovation and diffusion to help us understand the empirical patterns and how innovation ultimately shapes prosperity around the world. We will take the model to the data for the last 500 years. That's already quite an accomplishment, and also use the quantification to help us do some counterfactual analysis. So this data set draws on the insight of folks in economics and in other fields that Wikipedia articles have curated a nice repository of information, and we can use that to build a long-standing, comprehensive, continuous, detailed catalog of innovation since the beginning of time. So if you start with the entire Wikipedia universe, our excellent R.A. Howard has the insight that you can use the STEM tags to first narrow them down to STEM topics, and then drop those about people, places, events, journals that are not innovation, and filter for those about innovation. In earlier work, we've entirely relied on LLM to screen for these Wikipedia articles that are more stringent, but the baseline results are basically identical however you screen them, so it's fairly robust. And also we can show you equal weighted results, which you will see today, the counts. You can also do importance weighted by length and so on, and you'll see very interesting consistent patterns. And then after we get the list of innovations, we will use LLM to extract background information about when and where they were invented, and additional background information if you're interested. So that leaves us right now with about 50,000 innovations through history. Of course, given the ongoing rivalry between France and the UK, sometimes we get comments from French colleagues that Wikipedia might have an English language bias. We've checked very carefully that the representation of countries in their innovation share in our data set aligns well with the representation in, for example, recent patent data set around the world, like PatStat. There's no detectable English language bias, so they're more represented here than in PatStat. Also, you will see historically there were many innovation centers like Greece, Rome, East Asia that were not English-speaking countries. So to give you an intuitive sense of what an innovation is like these are some notable innovations that we know from the past industrial revolutions. In the very early times, like an innovation would be hunting weapon, which is the first one, and then like hammer, torch, things like that. So a unit of innovation is a very intuitive one. So first, empirical facts. Throughout human history, innovation turns out to be always extremely geographically concentrated. This is our figure since 5 million years ago, and you can see the innovation center going from Africa to then later Mesopotamia, Egypt, Greece and Rome, East Asia, and then more recently Europe, and very recently the United States. And throughout history, you can kind of eyeball this, that almost always a single continent has accounted for over half of the world's innovations. So for this plot to the left of 0, the past 2,000 years is what we can compare with, for example, Madison dataset on population. And you can see that the population share of the world has been much more stable, whereas the innovation centers do shift around very substantially. At the country level, right now we're presenting results for the past 500 years because it will be more sparse going back further. But you see the same patterns that there's very substantial concentration of innovation and shift of innovation centers around the world, compared especially to population, but also to GDP. At the beginning of the sample, there were countries like Italy that featured prominently, and then it became UK, and then the US. Another way to visualize the very extreme concentration of innovation is you can also ask how many countries it takes to account for half of the world's innovation. And so it typically, for the past 500 years, it's only 1 or 2 countries. And their share in global population is very small. Their share in global GDP is not that large either. So a lot of countries then have derived output from the innovations of these countries. This is a final visualization through the coefficient of variation. And again, you see innovation per capita is much more heterogeneous. The level of CV is much higher compared to GDP per capita. There's some variation in the level of the coefficient variation for innovation, that some of the fluctuations relate to how an innovation leader is going to change the numerator, denominator, and so on. But on average, it's very robust. The level is much higher. For GDP per capita, the variation is actually slightly increasing over time, and we'll come back to this later about the issue of how growing amount of knowledge can contribute to the great divergence, more spread in output per capita. And so that's the global spread, and then in level terms, you will of course see a phenomenal takeoff in innovation per capita, and especially in some parts of the world. So initially in Europe, and most recently in the Americas because of the United States. At the country level, it's quite interesting. For example, US has always been going up in terms of innovations per capita, but you have countries that fluctuate. We see the Dutch Golden Age showing up initially. We see UK with due respect. It's barely as innovative in terms of innovation per capita as 200 years ago. So after the first industrial revolution, the UK had a substantial decline. And also with due respect to colleagues from Germany, and there was a substantial decline in innovation per capita since the Second World War, and Germany has not become more inventive on a per capita basis than 100 years ago. But some other parts of Europe have become more innovative than before in this sense. But for many parts of the Europe, the stagnation has happened for not only the recent past, but for almost a century. Then, as you have already sensed, given the extreme concentration of innovation, we know that output is not so concentrated. So growth has spread around the world, even in countries without a lot of homegrown innovation. Many advanced economies don't have a lot of homegrown innovation. This plot shows innovations per capita over time and GDP per capita. You have many advanced economies where innovation per capita is really low, but they have grown substantially. For example, Greece is an extreme example. 90% of Greek innovation or data set were more than 2,000 years ago, but Greece has, of course, grown over the past 2,000 years. This is another way to show that you can have growth episodes, which is measured on the y-axis in many places without necessarily homegrown innovation. Of course, you can also have growth episodes in places where innovations have grown. So finally, as another indication of diffusion, we have run these impulse responses of subsequent growth on innovation. So this is innovation over the past decade on the right-hand side and growth over the next 10 years on the left-hand side. And you see that innovations in one's own country, when that goes up, that leads to higher future growth by a modest amount. So the innovations that we capture are meaningful. But quite interestingly, when the innovation of the global leader, which is the country with the most innovation, when that goes up, that translates to output around the world by a very substantial amount. Also, when the leader becomes more innovative, that translates into output of the richer countries more than the poorer countries, which is another indication that the ability to adopt innovation from elsewhere has contributed to different levels of prosperity. So then we have a framework building on the insights of Eaton Kortum and Ezra and Paco's work to make sense of the patterns of innovation and diffusion. In this model, we have three types of activities: research, which generates new ideas, and adoption that creates varieties based on the new ideas from innovation, and production. So workers would choose the activity they're engaged in that's affected by the earnings prospects and taste shocks, and the taste shocks, will come back to this a little later. So first, for research, research produces ideas with productivity Q, and Q has two components, as in where overfilled, the original component, and the Q prime, which is inside, drawn from a source distribution that depends on ideas that are known in a given location. And ideas propagate around the world stochastically. So for an idea that was invented somewhere else, all tilt, that becomes known in another location each period with probability that's denoted by the phi, the var phi. And so cumulatively, after k periods, you see the expression of the probability of diffusion. And also, the quality of the original component depends on the productivity of research in the location, which we denote by ZR. And so ultimately, the frontier is going to be Frichet, which depends on the stock of ideas in the location, as well as theta, which is the spread and governs the dispersion of productivity. And beta earlier, it governs the strength of diffusion, how much existing ideas can generate productivity of new ideas. So, and ultimately, in a given location, the flow of ideas, which will ultimately map to innovation, which is the difference in the stock of ideas, is going to depend on the research productivity of that idea, the fraction of people in that location who will work in research, which is the S share, which will solve, and the insight pool that the location has access to, which is past ideas that were generated elsewhere and have ultimately arrived at that location. And the probability, of course, is between 0 and 1. A higher probability means faster diffusion. And adopters then use the ideas to create varieties, and these the ideas also can flow from other places for adoption in a given location. And this flow is governed by the probability psi phi A. So these phi R and phi A we will try to back out from the data. And in addition, the adopters can use their local ideas and pay rents for the local producers of those ideas. And ultimately, the output per capita in a location is going to depend on, of course, the production productivity and also the adoption productivity and the fraction of people who work in adoption. And very importantly, what we call the technology pool, which is the set of ideas that adopters in a given location can draw on, which depends on the local ideas and the ideas that flow in from other places. And after solving for those shares of people in different things and also translating innovations recorded in Wikipedia into ideas that are sufficiently better than the world frontier, we have these two equations we'll ultimately take to the data. And you see the very similar structure, research productivity matters, and also the IP protection preferences play a similar role. So we'll estimate in the end them in a bundle together, and then the insight pool that you can draw on, the set of ideas that people can draw on. And GDP per capita have this structure that was similar to what we saw on the previous slide. Using the model, we can already see some simple intuition for some of the stylized facts we presented. For example, you will have the dispersion in innovation per capita to be higher than dispersion in output per capita because output draws on ideas that come from many different places. You get access and you average over ideas from many parts of the world. And the persistence in research, in innovation in a place is going to be higher at the continent level than at the country level. And across countries, when innovations grow more quickly, that contribute to a lot of recent ideas which have yet to take the time to diffuse, and that can contribute to greater divergence in output. And finally, as we saw before, countries that are better at adopting can become richer than countries that are worse at that. So lastly, for the quantification, we take those two equations to the data and we infer the diffusion speed for using technology for adoption from how countries around the world, in terms of their output response to changes in the global technology pool, and we infer the diffusion speed of ideas from changes in the insight pool and how that affects innovations in different parts of the world. We used the past 500 years and countries with long enough GDP data over this time period. In fact, now the GDP data is the constraint, whereas innovation data is always available for the past 5 million years. And based on our estimate, the diffusion probability for knowledge, which is the y-axis, and the diffusion probability for using technology for output, which is the x-axis, are quite correlated, but not perfectly, and the knowledge diffusion speed tends to be lower. We also find that the rising dispersion in output per capita that we see over the past 500 years comes largely from a growing pool of ideas, making it matter more in terms of the impact of the heterogeneity in countries' ability to adopt. And that also shows, in terms of the structural variance decomposition, that axes, which we mean by access to the pools, contribute more to variations across countries over time as the stock grows more quickly. Finally, we do two counterfactuals. One is, what if you make access very easy all around the world? And what you see on the x-axis is how much countries' output by the end of our sample is going to increase relative to 0, which is that solid line. And the frontier countries, if you make access almost free, they move a little bit, but the laggards move much more. And if you cap access speed, then the frontier countries, especially the European countries, are going to suffer a lot. Whereas if we make knowledge diffusion faster, we're not going to compress the spread of output per capita, but we're going to make everybody better off by roughly the same amount. And so you see all countries shift to the right in terms of output per capita. If we make knowledge diffuse faster, if we do the reverse, then we get all countries almost worse off. Finally, the model can also help us understand the rise and fall of UK versus the US. For the UK, it seems, at least so far, we attribute most of that to variations in their research productivity. For the US, it's a combination. Initially, research productivity contributes a lot, and over time, as US becomes very large and large in scale, the pool gets very large and access takes over. For our European colleagues, we find that the stagnant innovation, again, depends on the declining research productivity, but of course, with the high ability to adopt, Europe has been able to sustain reasonable output. So in the end, with centuries of global data, we can see very clearly the extreme concentration of innovation and dispersed growth. And we have a model to help us understand these patterns. We have a movie which Ezra dreamed of last night, and with help of modern technology, it visualizes that. We also have some ongoing exploration. For example, you can ask, what if US seals off itself, and what's the consequence to other countries and to the US? But before these observations travel to the US administration, we really appreciate the opportunity to learn from insights from Michael. Thank you.
Looks like it's sharing.
Yeah. Oh, you're good. Sweet, thank you.
Perfect. Well, thank you. Thanks so much, Mark and Pete, for giving me the opportunity to discuss this paper. This is really fascinating. It also gives me a new appreciation about my own work. I always thought I was working in growth, but apparently I was working on fluctuations all the time, just the last 30 years, 100 years, little quibbles in the history of humankind. So, this paper is obviously exciting for everybody who's interested in the world, and in particular for everybody who's interested in long-run growth. And so the three facts that I think are really the pillars of this whole analysis, we've seen this from Iran, is first this concentration of innovation, right? The countries that account for 50% of innovations, they account for 10% of people, maybe 20% of GDP. Second, the origins of innovation change over time, right? We're not in a deterministic world, but there's big reversals, and I guess the most interesting one, maybe, in the last short period of the last 200 years, is obviously this extreme rise in the US, which according to the authors now account for 50-60% of all global innovations of the last 50 years. And then finally, I think is this appreciation about adoption, that this link between innovation and income per capita might be weak. And what really drives income differences is whether or not you can adopt technologies. And you see this example here, right, where there is basically a cloud between income growth and innovation. You have Switzerland, who's very, very innovative, but they don't grow much faster than any other European countries. So there's lots in this paper, and so I only have 20 minutes, and so I wanted to focus on three things that I think the paper could maybe benefit. And in particular, it's this link between how do we link about these facts to the theory and the quantitative analysis. And so what I want to do in my discussion, I want to talk about three things. First, I want to talk about the theory. The theory is beautiful, I have to say, like as a theory. And you can see, obviously it builds a lot on Paco's and Ezra's earlier work. So these adoption frictions for this set of authors is very low. But for normal mortals, maybe the adoption frictions are not as low. And so I want to push you a little bit in thinking about why do we have a theory which is as rich as intricate, where we have labor supply and royalties between researchers and innovators, if at the end of the day we have like 2 observations per country, right? Innovation and GDP per capita. So that's my first point. Second, I would love to get a little tighter link between the main motivating facts and the data. And in particular, I think the paper would really benefit from giving us some more insights about what really identifies this variation across countries. And it would be nice to see more, well, does the model actually replicate many of these main motivating facts or not? What's the crucial parts, why it replicates this concentration of innovation? And then finally, I really love these local projections, because I think these local projections are really maybe the most direct way of thinking about, look, if an innovation happens, who benefits, who doesn't. And so far, you created a movie between yesterday and today. So maybe in the paper right now you do have local projections, but at least in the draft that I got, there weren't anything. And I think these are really informative. And so what I want to do in the next 17-ish minutes, I want to have like a very simple kind of Romer model that leads to the exact same estimation equations, and I think might be maybe useful to kind of relate a little bit, what are these elasticities, how do they correspond to elasticity, as we might know better. then I downloaded the Madison data and took some of the numbers of their paper and calibrate this kind of simple model to maybe highlight some exercises on how this theory matched the data. And then I implement these impulse responses in this simple model, and there's going to be a surprise, which I thought was very informative. Okay, theory. So here's a kind of a simple-minded maybe theory that I would maybe start with from like a basic growth model, right? This is the data comes at the country level, and so the theory in the paper kind of comes from this location level, which then gets aggregated to different countries. So I just wanted to start with countries from the get-go because this is kind of where we measure stuff. So there's 3 agents: production, adoption, researchers. They come in like exogenous labor supply. You can maybe think about this differences in education, skills, these institutions. Adoption is like in Romer, right? The number of goods that you adopt depends on how many people work on adoption, omega times L, and their efficiency. And the efficiency to adopt has the usual Romer structure. There's like a country year fixed effect. Some countries are really good in adopting stuff. And there's this externality that the bigger this adoption or technology pool A, the higher the productivity adopt. Same for research, right? So how many products do you actually create? Well, it's the productivity of how many researchers there are. This productivity might again depend, this sigma ZTR, like, some countries are really good in innovation, some countries don't. And then there are obviously these 2 important externalities. If you have a high research pool, you might generate more with an elasticity lambda. And there's this congestion externality that is highlighted in the paper, that if you already adopted a lot in this country, maybe there's just, replication effort and sort of the new goods that you come up with, they're not going to be very profitable. And then you got the technology and insight pool. Yuran explained that that depends on how quickly do you adopt all these technologies that were created someplace else. And then production is in Romer. If you put this together, you get these equations, right, where innovation and income per capita are kind of power functions of the knowledge pool, of the insight pool. They depend on these region fixed effects, right? How many researchers do you have? How many adopters do you have? There's these efficiencies of local TFP. And these equations are basically the ones that Yuran highlighted from the paper, right? The structural interpretation of these elasticities is obviously different because the model is different. I'm going to have something to say about the mapping on the next slide. But as far as the mapping to the data is concerned, that's going to be isomorphic, right? So here is how these models map, right? And so these are some of these conditions, if you remember, that were important for proposition 1 and proposition 2 that generates this concentration. So in their model, 1 over theta, that gives you the thickness of this technology pool, how dispersed are these qualities. That translates 1-to-1 in sort of the plain vanilla, and call these the Romer gains, right? Like the var theta is kind of the scale elasticity, how quickly can we adopt in the denominator epsilon minus 1. This is the gains from variety. So that basically tells you something, well, we're going to get a lot of concentration of innovation relative to output if the link between innovation and output is kind of limited, right? If these Romer gains are not too big. Second, this idea beta, right? This was in the paper, this important parameter on if you come up with something new, how likely is it you get from this origin pool versus you build on the existing ideas which are out there. And so if beta is high, you put a lot of weight on this existing quality frontier that keeps traveling outwards. In kind of the Romer interpretation, this relates directly to this parameter lambda, which I highlighted here. That's just the usual scale elasticity, To what extent does knowledge give you more power or more efficiency to come with research? And then the last one, this congestion externality, this is kind of this labor supply margin, where in the theory of them, there is this idea of, well, if you have already a lot of adopted, then the royalties that you get paid as an innovator are low. How quickly does that drive innovators out of the research activities that's related to labor supply? And this may be more reduced form formulation. This is just this congestion externality as it shows up. And so when you think about the other parameters, there's obviously also a very clear connection between these kind of fundamentals in the simple theory, research TFP or adoption TFP, that's going to be the same as research efficiency in the theory. And then these labor supply shifters, how many people do you have in each of these pools, that's going to be related to these amenities of labor supply. So I'm not suggesting that you say, oh, let's go with this one, but I think for the reader it would be helpful to kind of lead the reader to why do we need to understand all this microstructure to learn something about the cross-country data, about innovation and output. Okay, how do we map this to the data? So the estimation is done in a very nice way. It's a structural maximum likelihood. But when you read it, I would have loved to get a little more into what moments are actually informative. And so, this is the draft that I get. This is the estimation strategy. And you can see it's kind of condensed, right? There's a linear Kalman filter that integrates out the state. We evaluate the innovation likelihood using a Poisson state space filter implemented with a Laplace approximation, and we assume that the reciprocal. You got to read this like a couple of times, right, to understand what's going on, and then you have to do a lot of, at least, a lot of legwork to kind of understand. Okay, so how do we, for example, identify whether there's a lot of concentration of innovation because some countries are really just very good at research and that's very persistent, or some countries are really good at tapping into these other ideas, right? And that seems to be at the heart of this paper and seems to be where this new data is really useful, and so I would have loved to learn a little more on how this would work. So to try to work through this is what I did. I took this kind of simple model, and then I said, okay, so suppose I wanted to recreate some of these figures in the paper. So I kind of downloaded the Madison data. I took their structural parameters directly from the paper. So luckily in Appendix Table 1, they report all these frictions for all these countries. Then I used the fact that this simple model is isomorphic for all these estimates on this elasticity. So I plugged those in Table 1. And then I did something very simple to do the rest, where I said, well, I'm going to put some structure on this underlying heterogeneity. There's a country fixed effect, and there is kind of a common time trend for all these countries. And I kind of calibrated the common time trend in GDP and innovation efficiency to match the time series variation in aggregate growth, aggregate innovation. And then for the country fixed effect, I exactly try to replicate, well, let's try to match as well as we can here, the distribution of income per capita in the first year. That's like 1,500 for the early countries in the Madison data, and whenever a country comes in, it would be 1,720 or so on, and the innovation per capita in 1900. So, I didn't recreate all the Wikipedia data, so I just eyeballed this from Figure 8, okay? And then you obviously need to take a stand on these initial conditions, and maybe this is in the draft which is now, but in the draft which I get, I wasn't exactly sure how do you pin down these initial conditions. I just did something very simple. I said, look, we know from the count that about 2,000 or 3,000 of these innovations were present starting in 1500, and so I just said, well, the adoption frictions, that gives you something about the share of ideas that you start out with. Turns out that this model kind of matches many of these patterns pretty well, and so the first thing which I was happy to see is okay, it's kind of consistent with this concentration facts, right? It kind of calibrated to this innovation GDP and the concentration of innovation. Obviously, it doesn't have any time series variation because for the estimation I switch off all these AR1 shocks. And then you can ask, okay, so what in the model determines these concentration facts, which I think is really the highlight and the title of the paper. And sort of one thing which I think was pretty interesting, so if you compute these statistics for these concentration effects for these counterfactuals that you guys run, in particular on the left I show you the case, the full diffusion case, where either, that's the red line, where you have full diffusion into this inside pool of research, or this greenish line, full diffusion into adoption. On the right side, you have the opposite. It's like autarky, right, where you can only build on your own ideas, either for adoption or for research. And one thing which I thought was very interesting is that actually this concentration fact for innovation, that's actually very informative about the frictions on this inside pool. When you look at the implications of GDP, and that's something that the paper really kind of highlights at the end, you get a sense that these frictions to research play sort of a secondary role because these adoption frictions are really important. But if you want to understand this concentration of innovation, I think these research frictions are really important. In particular, what I thought was interesting is this autarky case, right? I think what you see in the end is exactly something like the US, right? Like the US does most of the innovations. If there wasn't any diffusion for research, nobody's else inside pool would actually be growing, and you get this huge concentration where basically the US is doing everything. Vice versa, if there was diffusion of research, we would actually get more research in relatively poor countries because they could learn from the ideas of the US, not only to create new goods, but also to create new research. So, a question about this concentration is obviously, well, how much of this concentration is due to this innate heterogeneity in research efficiency or in the availability of researchers versus these kind of knowledge pools. And so in the simple model that I have here, that particularly stark because there is this fixed effect. So, in the estimation that I have, I can obviously look at this distribution of these fixed effects, and so there I find that, blue is this cross-sectional distribution of the innovation fixed effect, red is the distribution of the income per capita fixed effect. And so when I see that, I would say, well, the model is going to say, well, given the other structural parameters, well, a main reason why there is a lot of innovation a lot of concentration in innovation is, there's just much more concentration in the efficiency of research than in the GDP. So, that's not exactly the right comparison with the model, because the model doesn't have like a country fixed effect, but the estimation, the structural, the stochastic process that the paper estimates is very persistent, right? So there's on the innovation side, it's an AR1 with a coefficient of 0.99. And what you see here is that the standard deviation of this persistent shock is much higher in innovation than for TFP. And so I would love to get more intuitions from the paper. How much of that is just kind of innate efficiency in research and in TFP distribution relative to some of these other features. So one key aspect that Juran stressed, and that's very clear in the paper, is that the heart of convergence is really adoption. And so this is just basically the same data in kind of my simple model that Juran showed in a slightly different way, used in this barrow way, right? So this basically shows you actual GDP per capita on the x-axis, and on the left axis is this counterfactual about what would GDP be in the presence of free adoption in red or free insights flow in blue relative to the baseline, right? And so I thought that was kind of a helpful way to think about why do we get all these convergence, and you see this kind of very dramatic pattern that Juran also highlighted, right? That if there was free adoption, we would see massive growth in poor countries, not so much growth in rich countries. If we had free insight flows, everybody would benefit roughly at like one log point, right? And so when you want to think about these, the effect on the distribution of income, it seems really that adoption is key. There's actually one other way how you can see this in some sense directly from the data. So, these are basically the parameters that they estimate for the adoption speed and the research speed. Juran showed basically the joint distribution. You can also just project them on GDP per capita, and what you see is, yes, these are positively correlated. Rich countries have high adoption efficiency, high research efficiency, but you can already anticipate here that the correlation with GDP per capita is particularly tight. And then you can go back to the Madison data and just maybe run a regression, right? And look, if I try to predict income growth observed in the data from, I used here 1820 to 1990 because I wasn't like too careful on when these countries enter the Madison data and so on. But if you just ask statistically, if you want to explain the cross-sectional variation for the 180 years of income growth, and I have these variables to play with, research and adoption, the data very clearly speaks, the adoption part does all the work, right? It's a high R square, the research one, low R square. Once you put both, there's basically nothing left for this research one. And so, I would have loved to understand like slightly more when you estimate the model, kind of what is it in the data that really leads, that makes the model say, no, it has to be this adoption friction that generates this income convergence. Okay, finally, local projections. I thought these local projections were great. And then they somehow disappeared when you take the model to the data. So these are the local projections that were in the paper. Juran showed some of them. On the left, you have a local projection of own innovation. Right? It's basically a question if you have one more innovation, how much growth do you get? And in the paper, they split it up between like the early period, 1500 to 1900, in the last 100 years, and you see these interesting I thought, interesting facts that, in the beginning you have a big response, and then in the last 100 years the response is going to be slower. And then on the right side, you see the same local projection when you think about adoption, right? What happens for your country's GDP if the leader has an additional innovation, again, in the past and today. And I thought this discrepancy is pretty interesting. Like, it goes down for own innovation, it goes up for adoption, and I think the theory is kind of well equipped to ask, does that, is the theory consistent with that or not? What does this tell us about how adoption works? Okay, if you run this local projection in the simple model that I have, for own innovation, it works beautifully, right? You exactly get this kind of impulse response. And I think what's going on is it's kind of an ideas are getting harder to find, or as Chad would say, proportional increases in growth are getting harder to find from a single innovation, which is obviously a less of a good title than ideas are getting harder to find, right? But I think that's what the local projection is, right? Like, how much growth do you get from a single innovation? And yes, as we come closer to today, where the local knowledge pool is big, that kind of impulse response is going to be small. Now, you would think, shouldn't that be the same for adoption? I mean, it's this kind of the same mathematical equation, and that's true, right? When I run this impulse response in my model, yes, I get the same pattern. I do get that it's roughly of the same magnitude than for the own innovation, but it also goes down. And I think this discrepancy is something which I find is really interesting, because it kind of highlights that, well, maybe there is something in the last 100 years where this adoption technology actually changed. And one hypothesis, which I find particularly kind of interesting to think through at least, is, well, one thing which is really special in the last 120 years, that relative to the rest, that now basically all of the innovation and data are done from the US, right? And so is there something about the US just being a better spreader of ideas than other countries? Is there something about, do the frictions of every country from the US go down relative to what was in China hundreds of years ago and the UK 200 years ago? And it would be, I think, very interesting to think through with this machinery that you guys have, what that tells us about the last 100 years. I know it's only a sliver in human history relative to the first 4,999,000 and so on years. Anyway, I think this is a really fascinating paper. I loved thinking through it. These are my wish lists for the next version. Do we need as intricate a model? Is there a way to have a tighter link between these main motivating facts on concentration and the model? In particular, telling us more about, is this concentration due to persistent shocks, to persistent heterogeneity across countries, or through these knowledge frictions which generate these persistence across continents, country blocks, etc. I think there's a lot of information in the local projections. And then, one thing which I was thinking through, is there something to be learned about particular country experiences where this model fails, right? In particular, think about something like Korea, or the sort of the success stories of the 20th century. If you were to try to generate like the Korean experience in your model, how likely would that be, given your estimated parameters? Because I think it would highlight this possibility that maybe one reason how you get these growth miracles is that some countries really transition into being really good in adopting ideas from the frontier. Okay, let me conclude here. Thank you.
Thank you very much, and thank you for a great presentation. I had a question about measurement. So notwithstanding the point about English language bias, I think it's a reasonable hypothesis that historians' understanding of history is not evenly distributed across people and places, and a lot of past dependence, some archaeological things easier to find, but these captivate modern imaginations, etc. So my precise question is there anything you can measure on Wikipedia that actually replicates the Madison population and GDP series? And if not, and if, say, you look for famous leaders or famous people, or I saw in the paper, I was cheating a bit, seeing their stuff about arts and the literature, if you ended up replicating this level of concentration at the innovation series, would that not make you a little bit more worried that you're picking up a little bit more the concentration in our understanding of history, more than a genuine concentration in the kind of scientific advances that you're interested in?
I would say two things. We've looked at, for example, concentration measured other ways. You can measure concentration, say, Nobel Prizes. You get similar fact that one or two countries account for half of the world's Nobel Prizes, except for literature and peace. We have measured concentration, for example, in mathematical discoveries, and you find that, for example, France looms much larger in math than in technological innovation and so on. So I think they're pretty intuitive. And for example, like I think you see the close connection between innovation and growth, which we find in the data as well. And the other thing is, as of yesterday, we find that the estimates from using our data, for example, of the adoption frictions, align pretty well with, say, Coleman's estimate of adoption frictions based on his account of things. So we've done many cross-checks, as many as we can think of. If you have additional ideas, we would love to work on that as well.
Just let me add, one thing is something that's hard to check is whether the innovation is consistently measured over time, and I'm sure we're capturing more innovations now than from back then, and so it's something that it's hard to see directly, but it's something we try to deal with within the model of allowing what is the threshold for what counts as innovation to change over time, and try to estimate that along with everything else.
I wonder if you've tried thinking about TFP as well as GDP as an outcome variable, and I'm particularly thinking about the dual measure of TFP based on prices, where I think economic historians have kind of come to a consensus that if you go back more than a couple of hundred years, the price measure might be more reliable than direct quantity measures like GDP. And finally, if looking at TFP would give you a way to think about classes of innovations as being more important than one another. Thanks.
Yeah, I mean, so that might be a useful way to have a broader set of data than we have. We are like, as Veron said, we're kind of limited by what we do right now. I think TFP is kind of what we're after. We are measuring GDP per capita is the closest we get from that, and we do the best we can. But if there are better measures of wages, we'd be thrilled to maybe help us out a lot in terms of expanding our sample.
So, I mean, there are a lot of conceptual issues that arise when you do a data exercise like this. I was particularly, or wanted to know more about how you importance weight the innovations that I mean, the people that do research on this using patents, this is something that they struggle a lot with, and there are some ideas there about how to do it, but it seems like a first order thing that's hard to do in research.
Yes, so right now you're seeing the plots are equal weighted. Importance weights we can do several ways. One is you can count the length of the Wikipedia articles by words, by bytes, and so on. And so we've plotted a full set of all the graphs with word weighted and so on and so forth, and the key findings are the same. You can also see how many languages they're translated into, redirects and so on, and all of those weights have so far produced very similar results. If you have additional thoughts, we would love to try that as well.
I have a question which is a lot related to Michael's comment, and I don't want to question the very long run model of yours, but I think you can have something very, very interesting to say about going forward. In a sense, if you look at the much shorter run, with the last picture that Michael showed, which is like kind of the difference between adoption in what he's getting and the fast adoption that you're getting. Is it about the fact that more recently, he said in the past 100 years, diffusion has become a lot faster? I wonder whether AI and this kind of new wave of innovation had particularly made innovation a lot faster. So, I mean, focusing on the past 100 years, but going beyond 2020, maybe if you can show that this is really helpful, closer to Michael's simpler model, now it's a lot closer to your new model, that would be like really cool. And I think it would also be very interesting, as thinking on what you're doing, to think about the welfare impact of it. Like what Chad said is kind of relevant, which is like ideas are harder to find. Maybe the faster diffusion is being a replacement for ideas that are being harder to find to kind of get to the aggregate welfare. So I was wondering what you guys think.
That's a good question. So first, before I answer that, I just wanted to take time to just thank Michael for an awesome discussion. That was great. I think you were thinking along a lot of the same wavelengths as you, and I think it's very helpful. A lot of what you said. I think first, I think our view is along with Michael's and probably yours is that, and the literature is that frictions to adoption or barriers to adoption have kind of declined over time. I think that seems. Other people have found that the local projections seem to indicate that pretty strongly as well. The particular way we have, when we thought about implementing or trying to find that in the model, allowing for different to fall over time, it turned out the way we were looking at the data, it was underpowered to actually find that. So we get pretty large confidence intervals. It's not the only way we could look at the data, and so we're thinking about ways of maybe directly targeting the moments that are more relevant for seeing that in the data to try to learn about that. We think, I think you're absolutely right that all the developments that we see in the world that make communication easier, it's got to make these adoption frictions go down. And the question is, what does that imply going forward? Well, the model will have something to say about that. And there's another plug for one. I think you're also absolutely right that even if it is harder to find ideas. I think this is I just saw at the SED a nice paper by Michael thinking about how catch-up growth can sustain global growth even when the growth is pretty low. So I think that's an important point.
Great, so this is maybe more of a loose suggestion than a question, but something I really like about this project is that I have a prior that innovation over historical time periods is very delicate. Like history is full of great civilizations that collapsed because something went wrong, and this gives us a chance to sort of take this narrative view of the evidence. And so I'm wondering, A, if there are clear examples of innovation collapses in your data, and then if you can sort of loosely relate this to any observables. And so as an example, that would be hard to make systematic, but there's evidence that whenever there were volcanic eruptions that disrupted Nile flows, there was political instability in Egypt. So something, I mean, that's one example, but something to say sort of why did innovation collapse in location A at a point in time would be a great question.
Yes, so when I was in Athens for SED, I kept thinking about why 90% of Greek innovations were 2,000 years ago, and what happened to Greece, and maybe our Greek colleagues have some insights. So at the high level, yes, you see like the rise and fall of Greece, the rise and fall of Egypt, the rise and fall of the UK, and so on. Now, yes, we could try at the local level, like particular events, but I think it would be very cool to understand like the rise and fall of innovation powerhouse in history, and it's real and it's quite substantial.
So great paper. I mean, you may have this in the paper. There's this older tradition in innovation literature which also does what you do and tries to count actual innovations. There's this group called the Science Policy Research Unit in Sussex which did that over the course of the last 100 years or so. And I think one of the things which comes out of that, which would be useful to explore, is that if you think about the own effect, so the effect of a country which innovates on its productivity, that's relatively easier to identify than, of course, the adoption effect, which is looking at the impact of every other country. And obviously that's trickier to get at the data. One of the things I thought you could try is maybe using Wikipedia itself to look at not just the innovation itself, but is there information on the adopters, on the diffusion of that innovation through looking at entries in Wikipedia or otherwise. That was actually some of the earlier literature on firm level innovation also did, and that might help get more credibly at the kind of spillover effects, which are the hardest things to kind of identify in data. Thanks.
There has been a very creative and maybe heroic attempt, the paper that we cited, Harvard undergrad thesis, that tried to ask LM to tell it for each Wikipedia technology what is the year of widespread use, but it's kind of very hard to define that in the first place too, to know for every location what's the set of technology they're using. We would love to think about it. So right now what we can see is, for example, Diego Comian has tried to code the types of things that are being used and the adoption frictions implied by that. But we would love to think about how to measure the use.
I had a question that was maybe along similar lines. Have you had the chance to look into connections between articles? So for the importance of an innovation, if they get cited in another article, you could even trace the lineage of both innovations, and you can see the complexity or importance that they like end up giving birth to a lot of different innovations. Is that something you looked into?
I think for Wikipedia articles, if things are very similar, tend to build on the same article instead of like patterns where they are independent units and cite each other. But we've looked at, for example, the similarity by domain of application, which we have extracted around different places and how that might relate to people flow that people have constructed using Wikipedia data sets and things like that. They all make sense, but the paper is already very long and rich, and so we will think about what additional things to include. Thank you.
Let me just add one. So you can classify innovations into domains, and one of the things we found was that when you think about the spillovers from research in one place or an innovation in one place to innovation elsewhere, there are positive spillovers, and there are almost exclusively within domain spillovers, which tells you something about what exactly is spilling over. Like you might think it's technology spilling over, or culture spilling over, or something else. This makes us think that lean more toward it's the actual technology itself that's doing the spillovers.
Very cool. Yeah, I like the emphasis that you're putting on the diffusion. One question that comes up, if you think about this from the point of view, let's say a European policymaker, you might conclude, well, we don't really need to innovate, we're fine just imitating. So that leads me to the question, can you do something simple to say how similar are the environments that lead to innovation versus being good at imitation? Maybe it's not a coincidence that Europe is fairly good at following the US lead these days because it's not too far from the frontier and the setup is still fairly similar.
Yeah, so we have been thinking about, for example, if you invest 1 unit more in reducing adoption friction versus in innovation, how to compare them. We need to think a little bit more about the exact experiment. As of yesterday, we also find that if you seal off the US, Europe will lose a lot, and that a lot is supposed to be a very large number. So on the one hand, yes, like some of our teammates think that the data suggests that it's more efficient to adopt, but also the data suggests that it could be risky if the leader country decides to seal itself off for the countries that rely a lot on adoption.
Yeah, so one of the great insights of Michael Kramer's paper, which I guess only went back a million years, so not nearly as good, was that sort of you could use population to measure ideas. You only had one variable, and now you guys have 2 variables. It feels like this is a great opportunity to sort of see if the Malthusian force in the population dynamic is right. So I guess his insight was, yeah, people give you these new ideas, and they all get soaked up in higher population rather than higher income. And so you'd see innovations lead to population growth. And it feels like sort of, I didn't see Malthus come up in your presentation or Michael's. It feels like that, that seemed to me like something you really worth doing.
So we were just about to explore this. So when you look at innovation per capita, you get very similar patterns to when you look at GDP per capita. So it suggests that there's a similar Malthusian mechanism underlying this as well, but we want to pin this down more carefully, and we haven't found a clear conclusion yet.
I should say that's also another potential way to go back much further than when we don't have GDP data, is to start looking at populations. We'll see.
Yeah, so Taran had this very cool paper some years ago that was called "Why Can't We All Be More Like Scandinavians?" I believe. And so the point of that paper was that at every point in time, you only need kind of like one country to push the technological frontier, and we all get to like piggyback from it and have like more cuddly capitalism. And so I wonder if a lot of the evidence is kind of like consistent with that, like at every point in time you only have one country pushing the frontier and kind of just relaxing adopt. But interesting, like the rest of us are better off by not adopting like the cutthroat capitalism and just taking those ideas. I mean, it's also related to the comment about Europe. So is that something that you can study using this data? And the model is not about differences in primitives, it's just like all countries are equal, it's just that the equilibrium is a single country becomes the one pushing the frontier.
This is kind of an interesting question. So I think in some ways, yes, this kind of hints at that, and in some ways, no. So, I mean, clearly, like this model would say, like you need one person to do a lot of innovation, everyone's going to adopt it, it's fine. When one of the patterns I find kind of interesting is that leadership does change, and it changes in kind of the more local you go, the faster it changes, right? So if you look at over continents, that changes, leadership changes very slowly over the course of hundreds of years. If you look at individual countries, that's faster. So like within Europe, you had leadership moving around within Europe from like the, from Florence to the Netherlands to England. And so that was happening at a higher frequency. If you look within countries, it's happening even at a higher frequency. And so I think that it's true that one country is a leader, but I don't think you can count on that leadership happening. I think you need multiple countries to sort of like potentially be there to take up the mantle when things change. So it kind of goes in different ways.
All right, thanks very much. We'll take a break and resume at 10:15.
That was really, really good. Nice.
Take it away.
Great. So thank you very much for being here, and specifically to the organizers for including the paper in the program. The title, as well as the research question, is why do firms prefer the US over the European Union? And it's joint work with Ricardo Reis. And the motivation is that productivity growth in the European Union has been lagging behind that of the United States. And in an influential report, Draghi says that part of the reason is that the European Union is not a good environment to scale up a firm. And this report suggests many causes of this. For instance, that the workforce is not as skilled, the management practices are not on par with the US, the financing environment is worse, or the single market is not as integrated, agglomeration forces are not as favorable. What we do in this paper is use a revealed preference approach from firms' location choices to understand what it is that makes firms prefer the US over the European Union. And the answer that we provide to this question is threefold. First, that the financing environment is not as favorable in Europe as it is in the US. Second, that the single market is not as integrated in a specific way, and that the European Union is specifically not favorable for large or very profitable firms to headquarter in. So we operationalize this revealed preference approach in 3 steps, where we first compile a global database so that we actually observe the choices that we need to observe to infer the preferences. And then the second is to put together a model where firms are making these choices, where they are sourcing their inputs from all over the world, and that tells you how these choices that they make reveal regions' relative efficiencies across various dimensions. And then to develop an econometric strategy to combine the data in step 1 and the model in step 2 to understand why firms prefer the US over the European Union. A motivating example is UiPath, which is a robotic process automation company. It was founded in Romania in 2005, and they revealed a preference for having their headquarters in the United States as they moved 12 years after they were founded. Even though they moved their headquarters to the US, still most of their employment relative to the US is in Romania. However, 90% of their funding is coming from US investors. And so this example shows that a firm is making location choices across various dimensions, their headquarters, their employment, their financing, and that they make these choices in a very different way, depending on the activity, and that can tell you something about how they perceive the relative efficiency of regions across activities. How do we observe this data beyond this particular example of UiPath? We mostly use 2 data sources. The first one being LinkedIn, which contains hundreds of millions of worker profiles and the firms that they report to work for, and the location that they work in, and the type of job that they have, and the wages that they earn. And using this data, we put together a database by firm with the geographic breakdown of their employment by country and by type, in this case production and sales workers. And we combine that with Crunchbase data, which, particularly important for our purpose, contains information on the investors in firms and the location of those investors. And in this way, we construct a database on the firm level with a geographic breakdown of their investors. And the third source of data that we're going to use is on headquarter movers. And for that, we're going to use two vintages of Crunchbase, both the current one as well as one of 10 years before. And we can merge those databases and see which ones have changed their headquarters in between these two dates and in what way. And so that we're going to use to understand the revealed preference on the headquarter level. So now let me go into the model. In the model, firms make three choices, broadly speaking. They make a choice on the intensive margin, where they hold their extensive margin and headquarter choice as fixed, and that's what we're going to look at first, because we're going to solve it and estimate it in backward fashion. So we're going to index a firm by F, and a firm's headquarter is indicated by HF. And that is going to be chosen as one location out of the possible set of all locations. And on the extensive margin, which we are now still holding fixed, a firm is choosing a subset of locations in which to produce, subset of locations in which to sell or to manage, and a subset of locations in which to get finance. And on the extensive margin, we microfound these choices in a particular way. For instance, on the production side, firms are going to source tasks globally across location in the spirit of Eaton Cortum in ways to reduce cost. And on the sales side, firms are going to hire and manage their sales workers across locations to reach consumers. And on the finance side, firms are going to source funding from the various investors that they have a relationship with on the extensive margin. And so I'm not going to show you the exact microfoundations of this model, which is in the paper, but what is important is that for each of these three dimensions, we're getting on the intensive margin a revealed preference equation. So let's focus on production. The other two are quite analogous. So here on the left-hand side, you see for a firm F, how they allocate their wage bill in production between region I and region J depends on these ratios of the A tildes. And the A tildes are going to be the efficiency per unit cost of region I versus region J. For instance, the US versus Europe. And this efficiency per unit cost depends both on how productive, say, a worker is in that region, as well as the cost, the wage of that worker. And we're going to allow for these efficiencies per unit cost to depend on the headquarter and how it relates to the region. That, for instance, it's lower if you're operating outside of your headquarter region. And we're going to make that dependence somewhat restricted when you're operating outside of your headquarter region. So when your region I, the region that you're operating in, is not the headquarter, then your efficiency, we're going to assume that your efficiency depends on the efficiency of the inherent efficiency of the region, as well as whether that region is within the union of your headquarters. So for instance, for a French headquartered firm, whether it is in the European Union, could be Spain, for instance, or whether it is abroad altogether. So for instance, for a French firm to have an operation in Massachusetts. Now, this gives you a simple log linear equation that's coming directly from the revealed preference equation that I showed you before, where on the left-hand side we put the log of the wage bill that firm F puts in region I, and on the right-hand side we put some firm fixed effects, which is going to absorb differences in idiosyncratic productivity across firms. And we're going to put a region fixed effect, which is going to capture these efficiencies in a particular region I. as well as dummies that are going to capture the loss of efficiency from operating outside of your headquarter region, whether that is in within the union or outside. Now, one econometric threat is that we can only run this regression for region I that the firm has actually chosen to operate in on the extensive margin. And so a particular issue is that if the firm has already observed this idiosyncratic productivity for a particular region, when choosing that extensive margin, that can generate some selection. And the standard way to deal with this kind of issue is using control function approaches like Heckman and McFadden, where you control for the expectation of this error term conditional on including a particular region in the extensive margin. Now, the contribution that we make in this paper is that we essentially allow to generalize this method so that it works also for cases where you're not just choosing one alternative, but you're choosing a set of alternatives. So in this case, a set of production locations that are potentially complementary. So we think that's a contribution that can be useful even beyond the specific context of this research question. So what I'll show you here is the first result, which is showing the efficiency per unit cost in the European Union relative to the United States in each of the three activities: production, sales, and finance. The first two bars show you that the European Union is not at a disadvantage in terms of efficiency per unit cost relative to the US in production and sales. However, the third bar shows you that in finance, the European Union is clearly at a disadvantage. And these numbers are coming directly from the regression equation that I just showed you. So intuitively, the identification is coming from observing an Asian firm that operates a finance location both in the EU and the US. They tend to get more of their finance from the US than from the EU. But a similar firm that operates production and sales locations in both regions do not systematically bias their wage bill one way or the other. That's where these numbers are coming from. Now, similarly, we can look at the efficiencies of operating across borders, which are these ADA terms that I showed you in the regression equation, which is capturing how efficient it is to operate, for instance, when you're a Massachusetts firm, operate in the European Union. So focusing first on the outside union, when you're operating outside the union altogether, so outside the US or outside the EU, we see that there is not a big difference in the efficiency of operating abroad between the US and European headquartered firms. However, when we compare the efficiency of operating across borders within the union, so for instance a Massachusetts firm operating in California, we see that that is much more efficient in the United States than it is in the European Union. So here I should have said a higher number means that it's more efficient to operate across borders. Now that was the intensive margin. Going to the extensive margin now. From the model, the model implies that the operating profits of a firm, which we're going to indicate by pi, depend on the set of locations that they operate in across production, sales, and finance, on their headquarters, and on their idiosyncratic productivity. And generally speaking, the more locations you operate in, the higher are your operating profits. And the way you can see that is that if these sets are larger, then you're going to sum over more terms, and the terms within these parentheses are going to be higher. And the micro foundations are such that if you have more production locations, then your marginal cost of production is going to be lower in this Ethan Kortum sense. Similarly, if you have more sales locations, you're going to reach more consumers. If you have more finance locations on the extensive margin, you're going to get a better financing deal. The degree to which these operating profits are sensitive to the number of locations depend on these elasticities beta y, beta m, and beta v. And those are functions of the structural microparameters of the underlying model, but we're going to estimate them as part of our econometric strategy as well. Now that tells you what is the benefit of adding a location. Of course, there needs to be a cost of adding a location, and we're going to model those as some fixed entry cost that again can depend on the region I that the location is in and the HF, the headquarter of the firm. And we're going to assume that firms face some Gumbel shocks. And that's convenient because it gives you closed form logit choice probabilities that are easy to deal with econometrically. And these probabilities are quite intuitive, which is that a location set I here is going to be more likely to be chosen if the operating profits minus the fixed cost of that location set is higher. So that gives us our second dimensions of revealed preference. After the intensive margin, now on the extensive margin, we have another revealed preference, which is where firms decide to operate locations altogether is going to reveal these entry costs. Now we're going to make a similar assumption on what these entry costs look like and how they depend on the headquarters, which is that we're going to allow for them to be different depending on whether the region that you're operating in is within the union or outside of the union. So for a French firm, whether it's within the EU or outside of the EU. Now that gives you another regression, now a logit regression, where we need to control for the operating profits that this particular location will give you, and the number of locations that are both inside and outside of the union that is included in the particular set that you're considering. Now there is one implementation difficulty, which is that, as I said, these operating profits depend on the elasticity parameters beta. And so conditional on these parameters, we can construct the operating profits in any set of locations and estimate this with a simple logit regression. And that's what we're going to do. And then in an outer step, we're going to maximize the profile likelihood over these elasticity parameters. And that is efficient both from a computational perspective and from a statistical perspective. What do we get out of this extensive margin estimation? We first here show you the fixed cost of operating a location outside of the union. And here we again see that there is not a big difference between American and European firms when operating outside of the union. But again, when operating in another state within the union, the differences are very large, and it's much more costly for a European firm to open a location in another European state than it is for an American firm to operate in another American state. And this is again coming directly from revealed preference, from seeing that European firms just simply are not as likely to have locations outside of their state. Now the last choice that the firm makes is their headquarters. So when and where do they move their headquarters? Their headquarters HF matter because, as we saw in the intensive margin and the extensive margin, there are efficiency differences between the two, and there are fixed cost differences between the two. But we're going to allow also that the headquarter matters directly through some what we call wedges, and we're going to model that as some sort of taxes. We're going to allow for these taxes to have a proportional term, tau, as well as a progressivity parameter, kappa, which captures how much more the most profitable firms are hurt by this tax. And firms are going to choose their headquarters to maximize profits subject to similar Gumbel shocks, which gives us a last logit regression, where now the revealed preference is coming from the likelihood of firms moving from Europe to the US and vice versa. And what we find in the data is that European firms are much more likely to move to the US than the other way around, and specifically that the most productive European firms are more likely to move to the US. And that is going to feed directly into our estimates of tau and kappa. Now what we get in the end is this model implied probability of moving from the US to Europe relative to the other way around. The fact that this is below 1 for any level of productivity tells you that firms are generally more likely to move to the US than the other way around. The fact that this line goes down so much for the most productive ones tells you that for the most productive ones, the US is even better, and that's coming from the fact that, well, the data suggested that is the case, and that's going to be picked up by a progressivity parameter that we estimate to be higher in Europe than in the US. So with that in mind, let me conclude and say that what this paper does is to make concrete progress on the Draghi report on EU's lagging productivity growth. We use a revealed preference approach to understand why do firms prefer the US over the EU, and we conclude that the funding disadvantage is important, that the segmented internal market is important both in the intensive and the extensive margin, and that there are some scale-biased wedges in Europe that are particularly repellent for the most profitable firms, and that it's not so much about production or sales efficiency. Thank you very much.
Okay, perfect. Thank you very much, Mark and Pete, for inviting me to discuss this paper. I really enjoyed and learned from it. So it's extremely topical question following the Draghi reports and recent debates for those of you who have been following of why does Europe seem to lag behind the US, especially when measured through productivity statistics. And the more precise question that the paper asks in that context is, in which activities do firms seem to favor the US relative to Europe, and by how much? And their approach to this question is similar to the Bill preferences approach, in which they take a trade or location choice model that I will jointly call gravity models, combined with rich data on firms' multinational activity, on the hiring decision and finance and so on, and then they recover residuals for many different activities and they report the results to us, which I think is a great approach for this question. Okay, and what are the key findings? I think Hugo did a great job in describing them. So first of all, Europe seems to be on par as a location for multinationals affiliates to open there. So affiliates of third country multinationals don't seem to prefer the US relative to Europe. Europe seems to be much less attractive as a source of finance, and especially VC. The internal market seems to be highly segmented, which aligns with previous work, including this very nice paper on borders within Europe, on border effects in the trade literature. And in terms of the location of the headquarters, so Europe seems to be relatively less favorable to large firms. Okay, so what's the plan? So first of all, I'll just step out and talk a bit about gravity models versus solar residuals 101 as a method to think about cross-country differences in productivity. Then I'll talk about this paper relative to the standard gravity approach, and then some additional comments. So how important is the lack of geography in the framework, how they model the extensive margin choice and what are the implications. And then finally, I'll just encourage you a bit to, if you can, extend the analysis to what changed over time and to innovation, which is a key margin that came up in recent policy debates. Okay, so let's start. We all know solar residuals, so the structure that you need is an aggregate production function, and then through this lens, the difference in productivity between the EU and the US, for that you need the data on real output per workers across countries, and on a real capital stocks per worker. The standard framework that you need for a gravity-based approach, so you need an aggregate production function for each country, and then you need some demand systems for demand across countries. If you do that, you get the standard expression that many of you probably know for the expenditure share of some country I on goods that come from some country N that depend on the cost of production and on productivity in country N, on bilateral frictions between I and N, and on the trade elasticity relative to the same objects across all other countries. So once you rearrange the terms, you get that the productivity ratio between Europe and the US depends on the relative expenditure share of a third country on both of them to some power, on the bilateral frictions of the third country relative to both of them, on the wage difference between the EU and the US. I know these are not real wages, so this is just the wage relative to the joint global numeraire. And typically trade models abstract from capital, but if you add capital, so you have the same data requirement as the solo residual. Okay, so this seems like more terms, so why would you use it? So first of all, let me start with the downsides actually of using it. So first you need more structure. You need both the production structure and the demand system. Secondly, you need to somehow measure or put structure on the bilateral frictions tau. For example, a common approach would be to parameterize it as a function of distance. And you can do more fancy stuff. And then you need to have a value for the elasticity theta, which if you've been following the trade literature, we're still not really sure if it's like 2 or 10 or 5. And that, of course, really depends, really matters for what are the final numbers for this ratio. So why would you ever use this relative to just solar residuals? So first of all, and that's a big advantage, I think, it completely avoids the issue of measuring price indices across countries, which if you've been following the recent debate, that was one of the key issues of how should we deflate output and differentially and over time in Europe and in the US. And that allows you to sidestep it, because now here it's, again, output relative to GDP deflator, here it's just wages relative to the common global numeraire. The other key advantage is that it can be done in a much more granular level for many different activities. And for example, you can go down a very narrow HS codes and start to think about the productivity of Europe in semiconductors relative to the US and for other goods and activities as well. And actually a third benefit that's not very relevant in the case of Europe, but if you don't have GDP data, you can use trade data to get that. Or if you don't trust the statistics of the government, then you can use that as well. Okay, so of course note that both approaches, and that's true for the paper approach as well, it's about productivity or a residual output measurement, and not about welfare. And some of the debate in the context of the US versus EU was about working hours and about consumption price indices, so that's out of the scope of the discussion today. Okay, so, and let me also mention that what we just discussed in trade, but the same idea can be applied with multinational data or with firm location choices, and that gets us much closer to the paper. So if you take a firm that allocates a unit of tasks across locations, then you get that S is the share of production that a firm allocates across countries. Then the taus would be, for example, communication frictions between the headquarter and the affiliate. And the elasticity would be the elasticity of substitution across locations in the firm's production function. And this is widely applied in the multinationals literature. And then for firm location choices, let me give you one very simple example. If you take just local entrepreneurs and you add to them fresh shocks across locations and allow them to choose a location, that you get very similar mathematical structure, with S being the share of firms that relocate from some country to another country, tau being the relocation friction, and theta will be some combination of the dispersion of the productivity shocks and the decreasing returns to scale and production. Okay, so the paper basically takes some combination of this different structure in the decision of one firm, and then we do this recovery exercise that we've seen for the different margins. So where's the paper's benefit relative to these approaches? So before saying that, let me make the argument that you actually can get quite far with aggregate trade and multinational data. So to this end, let me just show you how, the measurement that you'd get from the Europe to US gap in terms of the similar object that they estimate, which is this efficiency per unit cost, which is productivity divided by wage to the elasticity, which in the context of a standard gravity equation would be the exporter fixed effects, or in the context of a standard multinational production regression would be the host fixed effects, right? So this is what you get from aggregate data. If you look at host fixed effects, so this is very similar to the regression that you ran. So the results are quite noisy, but indeed you find that you don't see much differences between the Europe and the US. So the confidence interval contains 0. If you do an exporter fixed effects using trade data, so you find that the Europe and the US are on par in terms of IT and professional services. Europe actually revealed to be better in manufacturing, so more countries source manufacturing goods from Europe relative to the US, and very similar to the finding of the paper, when the sourcing of financial services is much higher in the US relative to Europe. One caveat here that also applies to the paper and to this is that, of course, once you go from efficiency per unit cost to actually efficiency, Europe looks much worse because it has lower wages, right? So it's not that Europe, the wages are, say, in tech are around 30% lower. It means that through the lens of the results in the model, Europe is 30% lower productivity in tech. So that's not great news for Europe, right? Okay, so where's the value added of the paper? I think in a few things that they already do, and in some things that they can do. So first of all, you can recover wages using their data and approach that vary by firm size, which I think is great and very topical and very policy relevant. And that you cannot do with aggregate trade and multinational production data. And I'd urge you to maybe extend it from the headquarter location choice problem to other parts of the paper as well, because I think that in principle you have the data and the machinery to do it to all the different margins that you consider. So for example, is it easier for large firm to get finance in the US relative to Europe, or is it uniform across the firm size distribution? Secondly, in order to start to study the extensive margins, so where do firms operate, and relatedly to measure fixed costs, then you need actually firm level data and information on the inactivity of firms in different locations. So that's great, and that's something that you also cannot do with aggregate data. And finally, something that you don't do much, but I think your data and machinery allows you to do very easily, is to study the role of firm composition and sorting. So you control for firm fixed effect throughout, and then you show us how the residual differs, but how does the firm composition differs between the US and Europe, right? So how much of the aggregate difference between the US and Europe are due to the difference in the firm fixed effects relative to the residual location effects? And moreover, how much sorting do we see in the data? So is it the case that the larger firms tend to go to the higher productivity locations like the US? So that's very much exercises in the spirit of the AKM literature in labor, and you actually estimated already everything to do this type of exercises. So I think that you can do that easily and relate more to the aggregates that way. Okay. So second comment is, what about geography? So remember again this term for the productivity difference between EU and US, and you do it for a third country, so you need the third country bilateral frictions between the third country and both of these countries. And the paper basically sets that to 1. And I want to argue that that's very important. It shouldn't be 1. So if you look at the gravity equation for multinational production, so that's the log affiliate value added against the distance between the headquarter and the affiliates, and you get very strong decay with distance because communication frictions are a big deal, and communication frictions very strongly with distance. So working hour differences, for example, that's try to work between San Francisco and India, right, relative to working Europe and India. It's much easier to operate an office in Europe when you're headquartered in India. So of course, there's many ways to do it, but no matter how you do it, if you apply to the aggregate data that I showed you a minute ago, you get that systematically it raises the Europe-US gap by around between 0.5 and 0.5 log points. So Europe seems not as good once you control for geography, and that's basically because part of what you reveal as Europe's relative advantage is just the favorable location of Europe on the map, which is better than the US location. And again, that's a fix that is very easy to do, and I think that that's a part of the residual that is easy to separate and that you want to separate, because you really want to characterize on the unilateral characteristic. that gets a bit closer to policies and institutions and things that the European Union can actually control. Okay. Another implementation point is in how we model the extensive margin. So let me consider a very, very simplified version of the much more complex firm problem that they have in the paper. So consider a firm F that can get some payoff from operating in location I. So that's the profits, and suppose that it depends on the interaction between some firm characteristic Z and on the location productivity A, which appears in many standard models. So I think there are two common approaches to then do the firm location choices problem. One approach would be a multiplicative Frechet shock, which gives you very nice choice probabilities that are a power function of the location choice. And importantly, these choice probabilities are independent of the firm type. So you get the same choice probabilities for all the different firms. The main downside of this approach, and I think that's the reason that you don't do it, is that it's hard to introduce additive costs, right? You don't get nice closed form solutions, the integration is a mess. And you want to estimate the fixed costs, right? You want to add a negative fixed cost here. So the second approach, which is what the others take, is to add an additive gamble shock, but keep the payoff linear. And that gives you choice probabilities that depend on the exponent of the payoff divided by some parameter. And that means that the probabilities are scale sensitive, so you need to be very careful about that. So if you double profits everywhere, that will change the choice probabilities. And I think that you are careful about that, if I understood correctly the estimation, so that's fine. But the other thing that you get is that you wire in positive associative matching. So if you take the log and do the cross derivative, good. If you take the log and you do the cross derivative, then you get something positive. So you get basically log supermodularity in the location choices. Now, in principle, that's not necessarily a problem, because if you want to have a model that rationalizes sorting, positive sorting, then that's one way to do it, and that's fine. But my impression that in the measurement exercise that you want to do, then you want to understand how much the data tells us, what the data tells us about the existence or the inexistence of sorting. And I wasn't sure how wiring in this assumption would affect the results. So maybe it's fine and it doesn't affect anything in them, but it would worth to clear this thing out. Okay, and then finally, I just want to think about other things that you can do that I think gets you even a bit closer to the recent policy debates. So the first, of course, is the innovation gap between Europe and the US that is highly related to the first paper today. So this is just the log difference in total patents between the US and Europe, and you see that it was around 0 in the 90s and increased substantially since then to around 30% higher. And this is largely absent from the current analysis, with the exception that you can think about headquarter location as a proxy for innovation activity, because typically firms do innovation in their headquarters. But actually, your data is great to think about that, because you see where firms hire different inventors. So you can start to think about, well, what type of innovation activity do firms do in different locations, and which innovation do they do in the US relative to Europe, and so on. So I think that's a very exciting direction for this particular question with this data. And then the final point is just that some of the motivation, you're careful with it, but in that a lot of the discussion these days are about trends and about changes over time, and you have one cross-sectional snapshot. I couldn't understand why you just don't replicate your analysis for every year and see the changes over time. Is it a gap in the data, or are you hesitant, or is there another way that you're hesitant to do it? But if you can do it, that would be fantastic, right? Just to see how it compares to the aggregate trends. Okay, so to conclude, I think this is a great approach to a topical and important question. Some suggestions is one, just to push more on the unique value added from your data and approach, which I think is high. On the implementation side, just control for distance, it's very easy. and clear out this issue on the extensive margin modeling. And if you can analyze time trends in innovation, I think that would be high value added for you. Thanks very much.
Yeah, that was really interesting, thank you. So if you take your conclusions at face value that funding differences are driving these decisions. So firstly, there's a lot of anecdotal evidence that I've heard on both sides, both on the founder side and the finance side, that's consistent with that. And also a lot of anecdotal evidence that the same phenomenon is true in many other countries as well, not just the EU. I'm curious what your views are on appropriate policy responses, because it's something that I hear a lot, it's potentially extremely costly, and yeah, so that seems the natural step. I'm just curious what to advise policymakers.
So one by one, Pete, or? Yeah, okay. Great question. So I think the puzzle is actually even a little bit tougher, Greg, because ultimately, yes, we do find that, remember, it's really at the intensive margin that when you borrow or get funding from the US, you just really get most of it from there. So it's not really just about just a fixed cost figuring out how the US or Europe or Belgium works and so on. But secondly, there's of course the macro fact that all of this American funding that the European firms are coming here to get, and the Indian firms and others, is ultimately in part European money, because there's a big current account deficit of the US to Europe, so the money is actually flowing this way. So the European firms are coming here to get European savings in the American markets. And as you know, you look around in the financial sector, it's full of European graduates. It's not like the human capital, not like the French don't know how to do finance. They seem to be doing very well in Chicago and Palo Alto, wherever it is. So I think that pushes me to think that a lot of it has to do with why is it that giving a loan to a firm or funding a venture capital in the US works under better conditions, which to me would indicate, but this is speculative and beyond the paper, that it has more to do with the efficiency of writing contracts as well as with the corporate governance of firms once you're located here. And certainly we've explored, and even though that's for the next paper, talking to venture capitalists and banks, and that is what they tell you. They will tell you things like, even if my investors are Europeans and I'm investing in a European firm, when I do it in the US, I can write a contract where I'm much more confident of solving the problems of being able to get my money back if the firm misbehaves. I can write contracts where I can offer options and your taxes come along in terms of how exactly those options are remunerated. And so that some of the advantage of the US is very, really the institutions of how the finance operates, and that would go. That is beyond the paper, but that would suggest that in terms of policy options, on the other side of the Atlantic now there's a huge emphasis on the savings and investment union, which is much more focused on reducing costs. I have Belgian firms borrowing from the UK, say, or Spain. We're finding, one, that the fixed costs are not the main thing, it's really just the efficiency of scale, and two, that maybe it has a lot more to do with corporate governance of contracts and others, which, again, going towards some of the debate following the Draghi report, the 28th regime creating essentially taxes that are uniform and ability to write contracts is much more important than just pooling the money of pension funds in Holland or not.
All right, love the research questions, super important. This exercise is in spirit very similar to wedge accounting exercise, although it's more like productivity accounting. Now, the question that you always get when you run one of these exercises is about, it's about model error, right? And how do these productivity or wedges incorporate model error? Now, one thing that you want to do usually when you run this exercise is to do some validation. So, for example, like in the paper we presented on Tuesday, we model financial openness of countries, and we regress our wedges that capture financial openness on hard-coded measure of capital account openness, tax treaties, and so on. And so my question for you is, have you done something like that for your productivity measure? Can you regress it on some hard-coded measure of attractiveness? I don't know, for example, for the finance stuff, on some measure of funding, hard-coded measure of funding costs.
Fantastic. The validation was provided by Benny right now, and it gives me a chance to answer one. And I think that's the unique value added, as Benny put it, is that note that even though it was in the discussion you frame in terms of graft, malt, and trade, we do not use trade data. And that's really, I think, the big value added. We are using the I would call it the Ricardian insight from the big Ricardo, as much as gravity, which is that you are going to produce where things are more efficient. But of course, then the trade literature says, well, therefore, I will see exports from the place where things are more efficient than not. But we say, well, let's not look at the export data. Let's look at actually the location data. Use the same insight David Ricardo had, but to say, well, they're going to choose to produce or to sell or to get finance from where things are more efficient. And so our big value added is use the insights of trade and gravity without trade data. We have no trade data. It's entirely just on the location choices. Therefore, the big validation is exactly Benny's regressions, which is, but now if you look at trade data, completely different data in terms of where the exports imports come, not like where you put the workers, get the financing, you get similar results insofar as the Ricardian insight is working on these two validations. So it's validated by essentially by his regressions. And that's, I think, a part of the unique value added is that, yes, it is a gravity insight, but without trade data, which sounds weird, but hopefully makes clear because it is a Ricardian location insight.
This is really excellent. I thought your data would allow you to get at least some of what these wedges are. In particular, in terms of the within the union costs of having branches elsewhere in the European Union. You could look at whether countries that share the same language have the same kind of costs versus others. And if so, if the answer turns out to be it is language, then I'll look at this and say this is efficient and not really a bullshit problem. For the financing part, sovereigns often issue bonds where there's a clause that says, you know, in cases of dispute, New York courts have jurisdiction. You know, since this is possible, it's not exactly clear to me that it's the legal system in terms of what contracts are feasible that constrains us. But oftentimes, the main funder, in particular in cases of venture capital and things like that, once the management funder is found, right? And so you could look using your Lincoln data, who moves, right? Is it just the management that moves and becomes fireable under US law, where under French law it would be a huge hassle if the management was misbehaving? And that's really a policy question. And it seems like you already have the data to get at some of these things. Thank you.
Thank you. So on the first, thinking about that there may be essentially effectively the distance being not the same across all states of the European Union. For instance, it could be because of language, because of culture. Some countries are more close to each other than others. And I think it goes also to Benny's point that you can think of geographic distance similarly. And that's something that we are going to explore more. Specifically on the geographic distance, we have explored that bit, and across very broad regions we didn't find a very strong gradient. But that's something that we can easily look at. Now, in terms of the degree to which things like firing costs matter, that's obviously very important because the firm is going to take that into account when they're deciding whether to hire managers in Europe or the US. And so in some sense you can view that as a particular cost of hiring managers, and that's going to be certainly captured by this revealed preference approach, which costs generally a very wide net. I think one next step is to see whether we can kind of distinguish those things more granularly.
So great. So I think it's really fantastic to use firm level data and look at the location of production across countries and sales across countries for the reasons you're doing. The challenge in literature has always been that it's very hard to get hold of that data. So I think you use the Lincoln data as a good data innovation to what you're doing. But I think there is a couple of issues which I think is worth pulling out. So the location of the production workers is not necessarily the same as the amount of production. And in terms of thinking about sales, I think you're trying to proxy that again through managers or something, or maybe you can explain what that is. And of course, there's a big disjunction potentially between where the managers are and where the sales actually are. The third thing is that with LinkedIn, as you know, one of the problems is it's not got 100% coverage. So even in the US, it's like 60%, in other countries it's lower. So I worry, as you go back in time, it gets worse. So I worry a bit there's a disjunction between what you're trying to get and what you have in terms of raw data. One thing you could try and do would be to say, for particular countries, you can get this type of data, like VA in the US or in the UK, and you can do a validation to see how well or badly your proxies are doing compared to the actual data, or the way of figuring out whether the bias might be. But maybe if I misinterpreted that, what you're doing, tell me. But I think that is an issue you need to kind of confront a bit more.
Yeah, so on the coverage of LinkedIn globally, there are certainly differences in coverage across countries, and that's something that we worry about and deal with to at least as well as we can by using weights which are meant to capture the probability of a particular worker being included in LinkedIn, a particular worker having a LinkedIn profile. And so that's how we weight and correct for that as best as we can. One thing I should say is that if you think that there is a residual sense in which Europe is undercovered in this LinkedIn database, that would actually strengthen our result that in production and sales, Europe is not lagging behind the US, because that would increase the share of Europe in that front. As to your point regarding equating essentially workers with sales, effectively that's what we do, because we do not have the sales data broken down by region, and so that's simply a data limitation that we have, and yeah, I don't think there's very much we can do on that front.
Yeah, let me add a couple of points, which is that one, maybe it would be more accurate to say production workers versus non-production workers, because again, that's why we use sales /bar management ever, and sometimes maybe we get lazy and just say sales and forget the /bar or something. But really all we're saying is where you're placing workers that through their job description is not self-reported job description, is not associated with production entirely. So we're really looking is where you're doing the inputs. It's very much, again, where you locate inputs, not when sales, trade happen. That's the spirit of the exercise. That's the big innovation, if you want, from a kind of methodological perspective, which we're going to do location. We've done a little bit of validation, but we could certainly, there's always a lot more. And I didn't answer Rafet's second question, sorry, I forgot before, but absolutely Rafet, insofar as, I gave a story in answer to Greg of what it could have been, but what you said was instead meaning, I said maybe it's the contract, and you said maybe it's just that the funder has a geographical, strong desire to have the guy nearby. Incorporate that into my answer in terms of, sorry for the theory answer, contracts in general. Why is it that you need to be keeping an eye on the firm instead of zooming it or not? But again, I think your point is very well taken, and maybe in many ways a big part of it. Because on the second point there, we do geography. We do geography, just that we did it because of our question of within union, outside of union. That's exactly what those two parameters that Hugo showed you. The geography in terms of within Europe, Belgium versus Spain, as opposed to Belgium versus Greece. Sorry, I was thinking about which countries further away we don't do, and we could do a lot more. But to be clear, we do geography, and we think it's very important as part of the estimates. That's the within and outside union. It's just that we did it in a very coarse way, and we found a very big difference, a very big influence of geography in that sense. It's just that we did it at 2 points as opposed to across kilometers or language, as you suggested.
I want to give you a chance to talk a little bit more about identification and whether these wedges might be correlated. So an obvious one would be where I sell is related to where I produce because there's trade costs. I think a starker one, given your results, is where my headquarters is related to where I can get financing. And you sort of touched on this, Ricardo, in your answers to Greg and just wrote that. But the paper seems to think of these things as just very different. And I think a lot of the reason that firms choose to headquarter in the US is because they want access to venture capital and they want access to the bond market. And that's a lot easier when you have headquarters there. So I think that's an opportunity to talk about identification and correlation.
Yeah, thank you. So in the baseline model, there are no trade costs, and under that assumption, you can completely separately identify the production and the sales efficiency of regions. When you have trade costs, say in the extreme case where trade costs are infinite, then you have to produce in the same place as you sell, and so that would make it harder to separate production and sales efficiency, given that we don't find very big differences there anyway. It doesn't have a huge bearing on the result in the EU versus US case, but in general can make it harder to identify that specific difference in the two. As to finance and the fact that you may want to headquarter in the US specifically for finance, that's actually captured in the model as well. because it is cheaper to get finance from a place where you are headquartered, then the incentive to move your headquarters towards the US is also a function of the fact that the US is a better place to get finance. So in the model, that is also the case, and so that's why it's important to estimate these things conditional on headquarters.
Hi. There are lots of amazing facts in this talk. I think my favorite is the plot which had the odds ratio against productivity and sort of estimating. You said, look, we estimate that it's very sharply declining. And I'd love to hear you talk more about what you see as the reasons for why there be such stark differences by firm size, or I guess it's really firm productivity on the x-axis. Like the fact was very clear, and I can imagine 10 different explanations. And you've thought of this for a while. I'd love to hear you talk more about the firm size gradient, or productivity, sorry, for the gradient.
So in terms of what, I'll let it go, but in terms of what identifies it, just to see what in the data is screaming for such a large effect, is that we see firms moving their headquarters from the US to Europe and Europe to the US. If I just plot it for you, just a simple fact, the probability of you moving from US to Europe, it exists. Some firms move to US to Europe. It's essentially uncorrelated with size. The other way around is super strongly correlated with size. Really, the big firms move way more than not. So that's just what's identifying it in terms of the data, and that's why it's really so sharp. Why? I think it goes back, I'll repeat a little bit, not repeat, but I'll elaborate more on the answer to Greg and to Rafet and others, right? If what we see when these firms move, and consistent if you want with, let me bring you all the results together in just one narrative. You see these firms, they're growing, this robotics firm in Romania, it's growing well, and then it gets financing, it gets $1 million from a venture capitalist, gets 10 million from a bank, it starts growing, gets 100 employees, they're all in Romania where there's great engineers, everything is going fine. But then at some point, it really wants to scale up into a very big jump. Things have really gone very well now. It's at that point that we see that they move the headquarters to somewhere in the US, California. They get a 500 million funding round. And so we see this huge then shift towards that amount of funding. And curiously, they don't fire the Romanian engineers. They hire a few American guys, some managers, some production workers, a little bit more managers and production workers, but not much. And that's showing up in terms of exactly, it's when you have these really top right firms that are very, very productive, they feel like they need to move, and when they move, they expand massively in this finance difference, as opposed to the other ones. And when they move, they also then open operations in 7 regions in the US, even though the Romanian firm, they also had some stuff in Germany, Italy, but really nowhere else, and they do it in 20 firms. So that's the entire paper, like in one narrative, is the facts. What drives it, I think, well, there clearly has to be something where it's at that scaling, and because it's so abrupt, the financing, that I think it would have to do with the contracts of being able to come up with contracts broadly understood of being able to scale very quickly in the US. That seems to be driving it. But that brings all the facts together, which I think was what you were asking.
So just to clarify, is there anything in the model that makes the US better at financing large projects than small projects, or it's just overall financing?
So in the model, which is a nice thing about the model, and partly that's what Benny is, there's a complementarity between these things, right? So again, if you're more productive in something, that makes you more productive in the others. That was the things to the power of beta, they all multiply each other. And so as you get more productive in the Z, then that makes it, the part of your answer makes more. So there's a super modularity, I guess, if you want to call it, but it's even more simple than that across all the activities.
Very interesting paper and also very insightful discussion. My question is mainly about data. My understanding is that Europe has, there's a greater extent of public grant funding, especially for startups like European Innovation Council awards. I would be skeptical that this would account for the bulk of the financing efficiency difference, but I don't think that kind of information is in Crunchbase, and I'm wondering if you've done any imputations just to make sure that that's not accounting for a meaningful part of that difference in efficiency.
Okay, that's a very good question. I should check on the specific grant that you're mentioning, but I should say that Crunchbase does include a lot of grants as well. I don't know the specific grant that you are talking about, but it does include a lot of grants. So it does not only include venture capitalists, but it also includes grants, it includes some sorts of debt finance as well. But I will check the specific one you mentioned. Yeah.
I wonder if you can show more about heterogeneity among different European countries in terms of seriousness of this issue. They vary a lot in financial development, World Bank, and law and finance literature have tried to measure that. Also on the issue of scaling, based on my understanding from our data innovation, there are some small European countries that seem to do quite well, like Denmark and Switzerland, Sweden, and so on, much better than the larger countries. So knowing why some European countries seem to be
even better if that's the case, would also be useful for the policy discussions.
Let me answer that because it gives me an excuse to also answer the third bit. I think I've answered 1 and 2, so then I'll be able to answer 3 on that one too. Absolutely. When we ran the model has little I and H subscripts, and they could be countries, but we made them be the EU and regions within the EU versus the US. Likewise, it has little T subscripts, which we ran as a panel regression. We could run a sequence of cross-section regressions and therefore do that. In the model, the theory, the implementation, we could do that. Why didn't we do it? Because we're trying to, again, by both aggregating across space and over time, in the sense of a panel regression, we're just trying to get more power. I mean, we absolutely, and going back to John's question, this data has a lot of noise, especially on the year-to-year, and so we worried a little bit that there's a little bit of an abuse to try and get much on top of it, and importantly, LinkedIn, the data is good for the last 10, 15 years. Again, I'm old enough to remember the world before LinkedIn. Most of the young guys here don't, but there was a world before LinkedIn, and it wasn't that long ago. And so as a result, we can get time trends, we can run distributed cross sections for 10, 15 years. Maybe if we did the crunch based of finance, maybe 20, 25 years, but obviously we'd love to answer those questions, but it's only a little bit of the pooling. Likewise, we did with cross, we have run this like with each separate country. Naturally, things are noisier. The one thing that really strikes out there, and maybe you'll see why Ugo mentioned so much the selection correction, there it's really important selection correction. Like when we ran this across states, we ended up with Montana being unbelievably efficient. Why is Montana so efficient? Well, because the few firms that have their headquarters in Montana turn out to be super efficient. So it's really all about the selection and so forth. And so as a result, the selection correction then has to do a lot of the work. And again, I think we do a great job on selection correction, but you really worry just as you minimize that selection really becomes very important. And again, I think we do a good job, but as you get finer and finer, I get more worried about selection driving biases.
All right, I think we better stop. Let's resume at 11:30.
Good stuff. I like it. Yeah, I think you should shift the focus relative to your presentation of the Fed in the right direction. Also raises the thank you. No, it deepens the
Your answer about basically multiplicative production is a model-based answer. And so,
yes. And then if you want to use the pointer, just the red
what
dot.
do you think the algorithm should be as a function of production? Okay, but that seems to then it's like, not only do you see the moves in the data, that's exactly what the again, automation is on top of it. That's right. You're showing us why the no, but it's less than
It's They've got thresholds. I got to figure out what those thresholds are because my daughter is also expecting, but we've got to the third actually. But we got to figure out when
next paper is earnings instability and perceived Patterson's difference in particular.
Great. Well, thank you so much for including our paper on the program. This is joint work with Peter Ganong, Pascal Noel, Joe Vavra, and Alex Weinberg, all at the University of Chicago. So this paper is going to be about understanding kind of the nature of labor earnings volatility. Now, we know a lot about annual earnings volatility from administrative sources such as tax records. And this data is extremely useful, but sort of by construction, it tells us very little about what happens within the year. And this limitation is potentially important because some survey evidence, either the SIP or the US Financial Diaries, suggests that these within-year fluctuations are also quite substantial. But the limitation has been that these surveys are based on small samples with kind of imperfect respondent recall, and that's made it hard to pin down where this instability comes from, how widely it extends, and how it affects workers. So in this paper, we're going to document the broad prevalence, causes, and consequences of this high-frequency earnings volatility using paycheck-level administrative data on millions of workers and firms. And we're going to summarize the patterns that we have into 5 findings. So our first is that this monthly earnings are quite unstable for many workers, even those within continuing jobs. However, it's unequal, and it is concentrated among hourly workers who make up 60% of the US workforce and on average have lower incomes. And for them, it arises because hours are changing month to month. We then are going to show that this hours instability is driven in large part by unstable firm labor demands. And our last 2 facts are going to be to show that this monthly earnings instability is relevant to workers. We'll show you that this earnings instability leads to spending instability. And lastly, that workers respond to this volatility by leaving jobs more quickly that have more unstable earnings. And so our overall kind of high-level takeaway is going to be that this high-frequency earnings risk is an important feature of labor markets, and it's one that falls disproportionately on the workers who are already the most financially fragile. So with that overview, let me jump right in. We're going to explore these facts within 2 complementary data sources. So the first is the microdata from a US payroll processor. This data has 2 to 5 million employees and around 500,000 firms per month. We'll have data from 2010 to 2023. We're going to observe paycheck level data here, as well as its components. So this will be things like hours, base wages, bonuses, etc. We'll observe both gross pay and net pay, although within this data, we'll focus predominantly on gross pay. And despite the data being drawn from small firms, we find that it's broadly representative of wages, hours worked, and the share of workers paid hourly. We're going to supplement this with the microdata from the JP Morgan Chase checking accounts. Even though this data set doesn't have information on the components of pay, it is going to have expanded coverage. It's going to include workers who are at bigger firms and allow us to see multiple jobs within the household. It's also going to allow us to link income to spending and volatility and liquidity. Our measure of earnings here is going to be paycheck level, now net earnings, think your direct deposit. And our measure of spending here is going to be spending on non-durable goods and services constructed from checking accounts and credit card spending. We're going to focus throughout on monthly pay variation that occurs within continuing jobs, as this is where our data is strongest. And the baseline object we're going to be using here is the month-to-month percent change in average earnings per paycheck. So we use average earnings per paycheck to deal with this kind of time aggregation bias at these high frequencies. So think about a worker who gets paid the same every week. Some months they'll get 4 paychecks, some months they'll get 5 paychecks. That's going to make monthly pay look quite volatile, but average earnings per paycheck in that case would be stable. We're also going to exclude the first and last month of the job spell, as those may be incomplete, and we'll Winsorize extreme changes. So our first finding is that this measure I just described to you is going to tell us these within job earnings are quite volatile. So what I'm showing you here is the distribution of these monthly percent changes in earnings in our payroll data across worker months. On the left is the CDF, and on the right is the corresponding PDF. And you can see visually it looks like there's quite a lot of volatility here. So to put some numbers on this, we find that earnings change in 69% of worker months. So that means in over 2/3 of months, workers are taking home a pay that's different than what they took home in the previous month. The median size of that change is 5%, and the 75th percentile has a change of 17%. Now this is the payroll data here, but we find nearly identical patterns in the Chase data despite its difference in coverage. And so this isn't just a feature of workers at these small firms, but rather a characterization of the worker experience more broadly. Now there are 3 ways to see that these fluctuations are sort of economically large. The first is that they're large relative to the volatility of base wages. So what I'm showing you here in purple is that same distribution of earnings, and I'm comparing it to the distribution of month-to-month changes in base wages. And you can see here that these wages are much less volatile overall, and moreover, when they do change, they tend to go up, kind of unlike earnings. And so what this suggests is that the kind of well-documented stability of wages does not translate into a stability in earnings. A second way to see that this volatility is large is to compare it to the typical levels of liquidity that households are holding. So within the Chase data, we find that these month-to-month earnings changes exceed median checking balances in 1/4 of months. So a lot of households just don't have enough liquidity on hand to kind of very easily manage these fluctuations. We also find that it's not offset by kind of earnings at other jobs within the household, as we find that household earnings and job level earnings are kind of similarly volatile. And then the last way to see that these are large is that it's large relative to what's implied by existing income models. So the previous literature that specified a high-frequency income process has been forced to infer the parameters that govern this monthly income volatility from the annual data. And what we find is that inference tends to understate the extent of this monthly income volatility. And that's because we find these monthly changes are fairly transitory, and that means they're kind of washed out in the annual data. So overall volatility is large, and as I previewed, it's concentrated among hourly workers who, as I said, make up 60% of the US workforce and tend to have lower wages. So to get a sense of that here, these are the same moments of that distribution, but now separated for hourly and salaried workers. And you can see here, hourly workers have earnings that change almost every month, and the absolute size of those changes is pretty meaningful. So the median absolute value of the change is 9%, and the 75th percentile has a change of 21%. And this contrasts with salaried workers who have a 0 change in earnings in the median month. So this suggests that if you're interested in kind of understanding high-frequency earnings processes, thinking about heterogeneity between whether someone's paid hourly or salaried is going to kind of be a key dimension. Now, unsurprisingly, since I just showed you that base wages don't change very much, this volatility for hourly workers is driven by unstable hours month to month. And we also find that among these hourly workers, this volatility is pervasive. So it's not concentrated in a particular demographic group, and it remains high even when looking at kind of full-time workers, those who are prime age, subject to overtime, not subject to overtime. We find that it's not well described by as predictable annual kind of seasonality, and that it's not explained by reasonable amounts of unpaid leave. We also find that it's widespread across occupations and industries. So occupations and industries differ substantially in what fraction of their workers are paid hourly versus salary. But conditional on being hourly, those differences narrow a lot, and we find that there's a lot of volatility among hourly workers across an array of jobs. And we think one interpretation of this is that a firm decides to pay a worker hourly instead of salaried precisely when they plan or anticipate needing to vary their hours. So overall, we take these facts to suggest that monthly earnings instability is a kind of pervasive feature of hourly work. And I'll just mention one more time that these hourly workers tend to be those who have lower incomes on average and more limited financial resources. So that sort of tees up another question, which is why are hours then moving around so much month to month? And that leads us to finding 3, which is that these labor demand fluctuations are a key driver of this instability. So to get to this conclusion, we'll show you 2 related but kind of distinct pieces of evidence that show this. So the first is going to build on the object, which is the change in total hours worked at the firm. So what I'm plotting here is the month-to-month change in the total hours worked among continuing workers at a firm. And you can see here that this is actually also quite volatile. So the median month has a change in total hours worked among these workers of 3%, and the 75th percentile has a change of 7%. Now in this figure, we've restricted to firms that have at least 20 hourly workers, so idiosyncratic labor supply shocks should largely wash out, and thus we interpret this change in total hours at the firm as being driven by the firm. Now exactly what's causing the firm to move around these total hours month to month is sort of beyond the scope of our paper, but we've done several case studies that suggest that volatile product demand coming from unforeseen shocks like extreme weather or kind of project completion seem like a reasonable candidate. We can do a back of the envelope here that has to make some assumptions about how firms allocate hours changes across workers when they scale up and down. But it suggests that these firm-wide hours changes are large enough to account for around 60% of the worker level volatility. And moreover, if this movement in total hours is a key driver of worker volatility, then we should see that this volatility is highest precisely in the firms that are moving around their total labor demand the most. And that's indeed what we see. So this here is a bin scatter, where on the x-axis is the volatility of a firm's total hours among continuing workers. And on the y-axis is the corresponding worker level pay volatility of workers in that firm. And we see there's this positive relationship. Firms that are moving around total hours the most have the workers with more volatile pay. Now our second piece of evidence to suggest to us that firms are key drivers of this builds on a mover's design building on the AKM type framework. So the idea of the mover's design is to look at a worker who moves from a firm that on average has low volatility to a firm that on average has higher volatility and ask what happens to their volatility. If their volatility goes up when they make this move, then the AKM framework is going to infer that the firm had a large effect on that worker's volatility. If instead it doesn't go up, the AKM framework will instead interpret these differences across firms and their average volatility as reflecting the sorting of different types of workers to different types of firms. So this figure here is going to summarize the result of those regressions. So I'm starting here by just plotting the distribution of volatility across firms of average volatility ranked by the decile of average volatility of the firm. So this is increasing by construction, but the starting point is that there's a lot of heterogeneity. For workers in the top decile of firms have a median month where they're in the median month their earnings are changing by 25% compared to just 4% at the bottom decile of firms. Now the AKM type framework can speak only to differences across firms. So this blue part here, which is the volatility of pay in the lowest decile, is going to be common to all firms. And what we're going to try to do is to decompose the remainder into that which is explained by the firms and that which is explained by sorting. And the orange and the green bars do precisely this. So the orange bars show us what happens to a worker's volatility when they move from a firm in the lowest decile to one of the other deciles. And the green bars reflect the remaining selection, wherein these workers who themselves are high volatility are sorting into these high volatility firms. And you can see here the orange bars clearly dominate. To put some numbers on that, at the median firm, the firm effect is estimated to explain around 60% of the worker volatility. So that was a lot of moving pieces, but together we think they tell the story that this volatility in hours worked month to month seems to be driven in large part by the firm. And that's important because it suggests that the volatility we were looking at before is not just workers deciding that they want to work less in different months. Okay, so far we've shown you this volatility is large and that it seems to be driven in large part by the firms. And yet, there might still be kind of two theoretical reasons why you might still think this has limited consequence to the workers. The first is that I already told you these shocks are relatively transitory, and many theoretical models would suggest that transitory shocks have limited effects on real outcomes. And the second is maybe workers learn about these hours changes in advance, and thus they can blunt their impact. So the last two findings are going to be two pieces of direct evidence that suggest that this is really relevant to these workers. So the first here I'll start with is that earnings instability will show leads to spending instability. So we're going to look at this within the Chase data, where we're going to relate the income volatility to the spending volatility for hourly workers. And this here is just the simple OLS coefficient. It tells us that when there's an increase in income volatility of 10 percentage points over the length of a job spell, there's an increase in spending volatility within that checking account over the same spell of around 2.6 percentage points. Now our goal here is to show that it's this income volatility that's causing this spending volatility. And there might be lots of things, say reverse causality, maybe there's some shock to your desired spending that causes your income to change, or omitted variables like a health shock that could cause both a change in your spending and a change in your labor supply. And these could be producing this correlation in the absence of a causal link. So we're going to build to this here by, in column 2, instrumenting for an individual's earnings volatility with the average earnings volatility of workers at their firm. Essentially asking if firms that on average have high income volatility also have workers with high spending volatility. And we see that they do, the coefficient's basically the same. In column 3, we're going to add individual fixed effects, essentially asking if workers' spending volatility goes up when they move from a firm that has on average lower income volatility to a firm that has on average higher income volatility. And here we see that the estimate is somewhat attenuated, suggesting that there was some selection of different types of workers across firms in the previous estimates, but it remains positive and significant. And then in column 4, we're going to interact an individual's earnings instability with a measure of how much liquidity they have in their checking account. And we're going to see here that this pass-through of income volatility to spending volatility is highest for those households that have the least amount of liquidity. And this is exactly what you would expect if you thought this was coming from binding budget constraints. So now how big are these estimates? Well, under some strong assumptions, we can do a Lucas cost of business cycle type back of the envelope here that's going to give us what the consumer would be willing to pay to avoid this additional consumption volatility. And when we do that, we find that these estimates in the table suggest that workers would be willing to pay between 5 and 9% of their wages to eliminate this volatility. And so, given the strong assumptions, I wouldn't take this as a precise welfare estimate, but rather as an indication that these coefficients are kind of economically meaningful as well as statistically significant. And that leads us to our final finding here, which is another piece of evidence to suggest that this volatility is relevant, which is that workers leave these unstable jobs. So what I'm showing you here is the relationship in a hazard model between the volatility of an individual's earnings and the speed with which they separate from the job. And you can see here the coefficient is positive. Workers separate more quickly from jobs that have more volatile monthly earnings. This is true when we instrument for the individual earnings using this average volatility of other workers at the firm. It's true when we add a bunch of controls that we think might be correlated both with an individual's volatility and the speed with which they separate from their firm. And it's true when we look just at movers and we ask whether within individuals they separated more quickly from the jobs in which they had more income volatility. The magnitude of these estimates suggests that moving from a job with no volatility to the median job for the hourly worker is associated with about a 40% increase in the separation hazard. Now I'll note that this is a little bit different from the spending effects we just showed you, because it would include any distaste that these workers have for actually working volatile hours, regardless of whatever volatility in pay that might induce. And I'll also note that we think the identification assumptions here are a little bit stronger than they were in the spending case, and there may still be unobservable features of these firms that are kind of correlated with the spending in the earnings volatility and the separation hazard. And thus we interpret this evidence as suggesting that this high-frequency earnings volatility is part of a potentially broader set of attributes that characterize these low-quality hourly jobs. Okay, so with that, I'll wrap up and conclude. We think this paper presents several new facts that together highlight the importance of monthly earnings instability. We showed you that it was large and particularly concentrated among hourly workers who tend to be lower wage and more financially fragile. It's driven largely by very volatile firm labor demands month to month, and that it's costly to the workers who experience it. And before I end, I'll just leave you with the observation that we think these new facts also raise several questions for future work. Among them, first, is kind of why are firms changing around their labor demands so much month to month? Is this efficient? Or could this be something that could be smoothed out with better management? And the second, relatedly, is what could the implications be of policies that actually seek to regulate these hours fluctuations? On the one hand, workers seem to dislike them, but on the other hand, it would limit firms' ability to respond to these shocks, potentially lowering their profits, and maybe decreasing the overall supply of these hourly jobs on the market. And given that this is kind of an active area of policy debate, we think these are important next steps. So with that, I'll hand it over to our discussant.
Karina Bower is the discussant.
Okay, well, thank you so much for giving me the opportunity to discuss this paper. Let me start with a macro perspective. We've repeatedly learned over the past 3 decades of work in heterogeneous agents macro that the nature of labor income risk matters a lot. For example, Ayagari showed that when households are faced with uninsurable idiosyncratic labor income risk, they engage in precautionary saving, and that matters for the equilibrium interest rate, and it shapes the distribution of wealth. Storrs-Letton, Telmer, and Yaron showed that labor income risk is counter-cyclical, and because it is precisely high in recessions, this makes recessions come with higher welfare costs than we thought. More recently, Guven and Oskan and Song said that recession risk isn't just about the variance. In fact, the entire income distribution skews to the left, and you see much larger earnings losses than you see large earning gains. So by now, I think work that uses quantitative heterogeneous agents in complete markets models to think about aggregate dynamics, policy transmission, welfare, incorporates some of these features, and they do matter. This paper highlights a new dimension of labor income risk, namely month-to-month earnings fluctuations, and these are largely hidden in the annual data that this previous line of work relied on. More specifically, and to remind you, the paper documents 5 facts about high-frequency earnings risk. The first is that month-to-month earnings fluctuations are large. The second is that these fluctuations are concentrated among hourly workers. Salary employees have fairly flat pay, whereas volatility for hourly workers comes from volatility in hours. Third, this volatility in hours seems to be driven by fluctuations in firm labor demand. Fourth, earnings volatility shows up as consumption volatility. And fifth, workers are more likely to separate from these high volatility firms. The first three facts tell us quite a bit about the nature of high frequency earnings risk, whereas the last two provide some suggestive implications that this matters for workers' welfare. I do think that all in all, the paper does have the ingredients that are needed to become an impactful one. It brings to the table unique data, it has new insights, and these insights have some potential to matter for macro applications that we care about. I think that the paper also does an excellent job at highlighting the first two aspects, and it's a little thinner on the last point. And I think that's fine, as Mark Bills likes to say, it's a paper, not a literature, but this is the space where my discussion is going to live. So in particular, I'm going to ask three questions. First is whether high-frequency earnings risk change how we think about macro transmission, and here I have a very specific application in mind that I'll describe. The second is whether this firm-driven variation in hours is inefficient or not. And third, I'll take a step back and try to give you some perspective of how important is the type of income risk that they study in the total labor income risk that workers in the US face. So let me start with the first question, which is whether high-frequency earnings risk changes the macro transmission. As I mentioned, I have a very specific application in mind. So for this, I'll work within the confines of the two-asset framework of Kaplan and Violante, and here I'll parameterize an income process to match some of the effects on month-to-month earnings volatility, and I'll feed it into this model and I'll ask some questions like, what is the share of households that are hand-to-mouth? What is the marginal propensity to consume out of transfers? I'll show you how this compares with off-the-shelf parameterizations of this income process. So just to bring you all on the same page, it's going to be a life cycle model where during the working life, households supply labor inelastically but earn risky labor income. During retirement, they earn some risk-free pension. All throughout their life, households can save in two assets, a liquid asset with a low return, the illiquid asset with a high return, but subject to a fixed transaction cost. And all households have absence preferences. I have nothing interesting to say about this. So this is off the shelf, Kaplan Violante 2014. Here I'm going to start with from a conventional earnings process that postulates that log earnings is the sum of four components. A deterministic age component, a percent fixed effect drawn from a normal distribution, mean zero, standard deviation sigma alpha, a stochastic component, that Z, that follows a random walk, innovations eta, drawn from a normal distribution, mean zero, standard deviation sigma eta, and an IID transitory shock epsilon, also normally distributed, mean zero, standard deviation sigma epsilon. As far as this standard deviations go, for my baseline income process parameterization, I'll take off-the-shelf values from the literature. I'll take sigma alpha, sigma eta from Kaplan Violante, and I'll set sigma epsilon as estimated by Blundell, Pistafari, Preston. Now, when you look at this last component, you already see a familiar problem. It's a bit of a mystery whether this variance masks true transitory shocks or maybe measurement error in the survey data. And here I think is where their paper could help. But what I'll do with this is I'll convert it into a monthly counterpart. So at this point, I'm already making an important assumption because I'm saying monthly earnings follow the same stochastic process as annual earnings do. But if I do this, then I could easily adjust my sigma alpha and my sigma eta, and then I'll follow their lead closely and I'll interpret monthly earnings changes as representing true transitory shocks, which means I'll calibrate my monthly sigma epsilon to match either the median or the 75th percentile of the absolute monthly growth rate in earnings that they measure. Then I can convert this estimate back into an annual counterpart by just dividing it by 12. So this is what I'll feed into the model, but before I do that, let me show you how this calibration looks like. Just to give you some context, but you've seen this in Christina's presentations. In the first row, I'm just repeating what we see in the data. Looking at adjacent months, we see earnings change in 69% of the cases. The median change is 5%, the 75th percentile is 17%. Now, when you look at either of these two calibrations, several things stand out. First is that the process misses the mass at zero changes. This is mechanical, it's a continuous process. It could have never done it. The second thing that stands out is that the implied value for this annual sigma epsilon is lower than what BPP told us. So this maybe says something about the amount of measurement error that we have in the data, but it's also going to tell you that when I feed this into the model, I'm going to get less precautionary saving. The third thing that you see is that neither calibration perfectly replicates the entire distribution of the size of earnings changes. And you see this most clearly in this figure, where in black dashed, I'm just replicating the CDF of monthly earnings changes from the data, and the solid lines are these two calibrations. So I think this brings me to the first concrete question for the authors, which is whether the monthly earnings moments that they document aggregate up to the annual statistics that we're used to see. And I think it would be useful to take your rich monthly data, calculate annual earnings, and report some of the moments that we've seen time and time again, either from the PSID or from the administrative data. And I think that's useful because it'll tell us whether, I don't know, we're missing a component of income risk, do we have too much, too little income risk, or do we need a completely different earnings process that's consistent with both monthly and annual statistics. But even given this underwhelming calibration exercise, I think there are some conceptual points to be made for implications for macro transmission by feeding this into the consumption model. So let me do that. I'm going to feed this implied annual earnings process into the two-asset model that I just described, and I'm going to report in this table the share of households that are hand-to-mouth and the marginal propensity to consume out of a $1,000 transfer. I'm comparing it with the baseline parameterization that I mentioned before. So what you see here is that as I feed in the high frequency earnings risk process, I'm getting a lower wealth-to-income ratio. Not surprising, I'm feeding in a transitory process that's less volatile, less precautionary savings. Not surprisingly, a higher share of households is hand-to-mouth. The marginal propensity to consume is larger. You look at this, you might conclude, oh, high frequency earnings risk is consequential. But this misses the fact that I now no longer get the right wealth-to-income ratio. So when I recalibrate the discount factor in order to recover my original wealth-to-income ratio, you see the differences shrink. So the conceptual point, I guess, that I'm trying to make with this exercise is not that high-frequency earnings risk is irrelevant, but that we don't have sufficient information to conclude that it is relevant. And in general, one should do much more work to get to the bottom of how this matters for macro transmission. So with this in mind, I'm going to go to my second question, which is whether demand-driven variation in hours is inefficient. So just to remind you, what the paper finds is that for hourly workers, monthly earnings volatility comes from hours volatility. And a substantial share of this hours volatility is actually common to the firm. In the paper, they have a simple back-of-the-envelope exercise that leads them to conclude that firms account for 60% of the volatility that these workers experience. And so based on findings like this, the authors offer various interpretations. For example, they say that hourly contracts help firms elicit additional labor when demand is high, but this shifts the risk onto the worker. Or that these hours volatility simply reflect mistakes on the side of the firm, and the firm could easily correct these mistakes without sacrificing profits. And you've actually seen in Christina's conclusion, there were calls for policy or thinking about policy interventions to reduce hours volatility and whatnot. And so I think it's a little too soon to call the press and ask for policy intervention to think about those things. I think one should start from some sort of structure to ask, and this is what I'll do next, provide some theoretical framework to ask two questions. One is, having the firm control hours, does this actually imply that hours are inefficient? And second, what are the welfare costs of firm-driven hours fluctuations? So just a heads up, this is going to be very simple. So in this very simple framework, we have a firm that observes either demand or productivity, that is A over here, and chooses hours in order to maximize profits, taking the wage rate W as given. Optimal hours equate the marginal product of labor with the wage rate, so this gives rise to the firm's labor demand schedule, HD. What the worker does is it takes this as given, chooses consumption to maximize utility. In this particular case, it's just consuming all of the earnings. So with this, we can just compute worker welfare easily. Now, nothing prevents us from calculating what are the hours that the worker would choose if the worker could choose hours. A worker that chooses hours in order to maximize utility facing the same wage rate will set hours to equate the wage rate with the marginal rate of substitution between leisure and consumption. And this gives rise to H star, the worker's optimally chosen hours. The question is, are these the same? Or in other words, is the allocation that the firm chooses inefficient or not? So for this, you can solve for the first best. What would a planner who maximizes the worker's welfare subject to some participation constraint for the firm would do? A planner would set hours to equate the marginal product of labor with the worker's marginal rate of substitution. So the question is, are these equal at the firm's chosen hours? So what we know is that at the firm's chosen hours, the marginal product of labor is equal to the wage rate. So the condition for efficiency then is this wage rate also equal to the worker's marginal rate of substitution when evaluated at the firm's chosen hours? If they're equal, then the firm's chosen hours are efficient. If not, they're not. If the wage rate is smaller than the marginal rate of substitution, the worker is overworked. It is underworked the other way around. So what this shows you is that, the firm is going to face shocks to demand or productivity. They are going to change the demanded hours. Whether that is inefficient or not for the worker depends also on what happens to the wage and how is the wage determined. So one option of how the wage could be determined that is off the shelf from the literature is what is called the right to manage model. This is a model where the worker and the firm bargain over the wage, and after they've agreed on the wage, the firm chooses the hours worked according to this labor demand schedule HD that we already solved for. How is the wage determined? Nash bargaining, where the worker's surplus is utility net of some outside option, and the firm's surplus is just the firm's profits. And so here alpha, the worker's bargaining weight, determines the bargained wage rate. So you can see a world where if the worker has too little bargaining power, then he might end up being overworked, or the other way around. So the takeaways, I think, from looking at a framework like this are, one, that by just looking at the evidence that they showed us, I think it is sufficient information to conclude anything on the efficiency of the observed hours allocation. But second, it also tells us a little bit about, what kind of objects should we be measuring in order to conclude anything about efficiency. That being said, I think one could still use this framework to think of a simple calculation to get at how large could the welfare cost of these hours fluctuations be. So this is what I'll do next, and for that, I'll specialize the worker's utility to be logging consumption and some isoelastic disutility of labor. Eta here is the free elasticity of labor supply. I'm also extending this to an infinite horizon, but I'm assuming workers are hand to mouth, so this extension isn't that interesting. But with this framework, I'll do the following exercise. I'll fix the wage, and I'll compare two economies. One in which the worker chooses optimally how many hours to work. With this utility specification, this is constant, depends only on model parameters. The second world is one in which the worker takes hours as given, and I'm going to assume that hours just follow a stochastic process. I won't say where they come from. You can imagine in the background, there's a process for A that's consistent with observed fluctuations in HD. And I'll take this from their work. So with these two economies, I'll just ask how much wage compensation, or what's the consumption equivalent welfare, in this case they're the same, that would make the worker indifferent between choosing hours optimally and giving up that right, but facing whatever fluctuations the firm imposes on them. So before I show you the numbers, two things I want to say. There are some caveats to this exercise. One is, I'm assuming workers are hand to mouth, so no self-insurance via savings. Maybe these welfare costs are some upper bound. Second, I'm keeping the wage the same in these two worlds, partial equilibrium. So you could imagine how the wage rate might respond to hours fluctuations, compensating differentials, and all that. So before putting numbers here, I'll just tell you a little bit how I parameterize this. I normalize the wage rate to be 1, and I'm setting parameters such that the workers' optimally chosen hours are equal to 1. Then for the world in which firm hours are driven by the firm, I'm assuming that they're drawn from a normal distribution with mean mu h, standard deviation sigma h. And I'm calibrating sigma h to match the extent of firm-driven hours volatility that they estimate. So one of their exercises says that the median absolute change in hours falls from 9 to 3.9% once I remove firm hours fluctuations. So I'm going to calibrate sigma h so that the median absolute change in hours is 5.1%, the difference between the two. As far as mu h goes, I'll consider 3 cases that I think are interesting. Mu h equal to 0 implies that on average, the hours that the firm demands are equal to h star and equal to 1. So there I only measure welfare costs that come from fluctuation in hours. So these are second order. But I'm also going to consider values of mu h that imply that the firm chosen hours are either 5% above or 5% below the worker's own choice. So here my welfare calculations are also going to include first order losses from inefficient hours. So this figure shows you how results vary, how these welfare costs vary with the free elasticity of labor supply. The blue line is the case where the hours that the firm chooses are on average efficient. Welfare costs fall with the elasticity of labor supply. That's intuitive. One thing that I'm flagging here, this welfare numbers that I'm showing you, that my calibration implies, are very different than the welfare numbers that Christina put up before, so it'd be interesting to square these things up eventually. And then you see also that the welfare losses are much larger once we add in this first order losses from hours being on average inefficient, especially when workers are overworked. That's the red line. Okay, so this exercise doesn't say anything about where the firm hour fluctuations come from, but you can think that it matters even for these welfare calculations. So what they find in the paper is that they're able to isolate movements in hours that are common across workers within the firm. Now, common within the firm doesn't mean idiosyncratic to the firm, and they actually have in the paper some case studies that Christina briefly mentioned that suggest that you see volatility around local events, hurricanes, COVID-19, refinancing cycles. Those sound like aggregate shocks. And so you can imagine that the distinction matters for welfare. Truly idiosyncratic firm shocks could possibly be smoothed out much easier. The firm can borrow. The spouse of the worker can work. But if it's aggregate shocks, that's much harder to do. So it'd be interesting to get a better sense of what these fluctuations are. And I'll finish quickly by giving you some perspective of how important is this within job earnings risk in total labor income risk. So what's missing here is unemployment risk. That's a deliberate choice of theirs, so it's not a weakness, but it's important, I think, to have some perspective. So here I'm using data from SIP, and I'm decomposing fluctuations in the growth rate of quarterly earnings into what comes from the extensive margin, that is fluctuations in the number of months that a worker is employed within a quarter, and the intensive margin, that is fluctuations in either the wages or the hours that the worker makes per month. And so this decomposition tells you that the extensive margin accounts for about 2/3 of earnings fluctuation. The intensive margin that they carefully examine accounts for about 1/5, 1/3 if I add whatever approximation residual my decomposition has. And this is true not just on average, but it is also true along the distribution. Here I'm reporting the same decomposition by income quintile or wealth quintile. So you see that combining this with what Christina showed us, poor workers seem to be hit by a double whammy. Not only they have a harder time holding on to jobs, but even when they do hold on to jobs, they're subject to much higher earnings fluctuations. So with this, I will conclude by saying that I think this is an important empirical contribution to the measurement of earnings risk, and they've brought to the table very high quality execution with amazing data. My two favorite takeaways are the substantial monthly earnings volatility, and that this seems to be generated by the firm through hours fluctuations. I don't think these things get the mind going, and I think they open new questions for all of us to think about. So thank you.
Thanks. Very nice. I have a question about, I think the paper raises a very interesting question about self-selection, third-party sorting. So two comments about that. I've seen a few papers now trying to measure these AKM effects, the term level. Now yours are instability on hours, but you would imagine these are correlated with job instability. So we're going to, for me, I'm saying the double whammy may be actually correlated. People who don't hold to jobs are maybe less likely to show up in the morning, which is where the labor supply can, at this level, showing up for work is important. Now, we know that turnover is necessary to identify AKM fixed effects. And now you're trying to identify turnover rates, essentially with turnover. And it's not clear what the recommended. This has come up, basically, with a couple of papers about this. I don't know the identification how it works. Because this is no longer identifying the levels to turnover, which we know we need to use Georges and all the detail. Now you're trying to identify the stability types to the turnover itself. I think it's a little bit tricky there. Now, related to that, on the hazard rate, I think it's been known for a long time that unstable firms, which would be nice to know if they are your unstable firms, are unstable in terms of losing workers. They may also be unstable in terms of hours, because the demand is volatile. Also tend to be low-paying firms, which is counterintuitive, but certainly what's in the data, it's actually which posting model would tell you. So then these workers may be moving not because of instability, they may be moving because the wages are moving. So it'd be kind of nice to figure out both. So are these firms also not holding to the workers, and in which case I think identifying the AKM is hard, and also are they paying less?
Yeah, I mean, so at least on the second front, I think that's a little more straightforward to think about. I need to think harder about the identification questions. But on the AKM type things that we've done, we've done those exercises within a bunch of sort of, relatively fine observable type bins. So you can do all of these exercises kind of conditioning on the, wages of the firm that you're moving between, and you see all the patterns look pretty similar there. So this holds kind of within wage deciles. It also holds within industries. So this isn't like coming from people, switching from working in like IT, which is like a stable job, and some change to their preferences, and now they're like, working in a restaurant or being a bartender. You see these same patterns kind of across firms within those industries. I think the other thing that in my mind makes the like wage AKM a little bit different from the volatility AKM is that I think within these narrow industries, I think it's less obvious that the volatility of the job is something that you observe ex ante when you're thinking about these transitions. Whereas like you sort of, first, you know the wage of the job when you decide to take it. I think you often only observe whether the job is sort of, moving your hours a lot from one week to the next, once you actually start the job.
Somewhat relatedly, I'm wondering if you can say something with your data about what share of the volatility is surprising, because you might think that, of course, if you can predict it, that there's some seasonality. For some particular firms, you do know, there is going to be some seasonality to this or whatnot. Then you could adjust a little bit more, unless you're, rolling out savings, etc. And maybe you can even see that in the pass through to the volatility of spending. And so I'm wondering if you can say something about that.
Yeah, absolutely. I went through that quickly. I'll elaborate that a bit more. We did look to the extent to which this could be kind of predicted by our best seasonal model. So kind of to what extent is this kind of annually recurring variation? And what we find is that is for salaried workers, you can do a pretty good job of predicting when they're going to get their bonus. Through kind of your annual seasonal model. For hourly workers, that just explains very, very little of the volatility in the data. And one thing that sort of I think helps square our intuition is that we find that overall employment at these firms is much more seasonal. And so when you anticipate, one interpretation of that is when you anticipate that you're going to have a big surge in demand around the holidays or summer, you hire more people, and you're kind of using this intensive margin to respond to kind of much more kind of idiosyncratic shocks that the firm is facing, or even a worker calls out sick, and you call in somebody else to fill that role. So yeah.
Great, thank you for a terrific presentation and discussion. I'm going to follow up on something Karina said, namely on the comparison between the monthly volatility and sort of this standard annual estimates. I was wondering if you looked at the autocorrelation of your earnings at the month-to-month level to see if is it persistent, is it purely transitory, just to give us modelers a better sense of how to put it.
Yeah, we did. We have something in the paper that looks at something like the variance ratio of looking at the variance of changes over kind of K periods divided by K times the 1 month variance. And so if it was a random walk and they were kind of permanent, it would be 1. And what we find, if it's a white noise, it's going to decay quickly. And we find that especially for hourly workers, it really looks much closer to white noise. It's not actually white noise. We find if we try to fit an AR1 process to reproduce that variance ratio, it's about 0.4 to 0.5. And so that's some non-trivial persistence at the monthly level, but basically no persistence at the annual level. Yeah.
Really super interesting. I was wondering about something. So the firm might have incentives to insure the worker against this earnings volatility to the extent that it's disliked by the worker, and so clearly it's not doing it, and so the firm must be trading off the insurance motive against something else, and so incentive pay of course comes to mind immediately, and so I was wondering whether you had looked in the data whether the extent of hourly volatility correlates with things that we think might affect incentive pay, so we could look across industries or other dimensions.
I mean, I don't think we've looked at exactly trying to answer that specific question. I mean, we see like this holds kind of within firms that do and don't pay bonuses, like sort of course cuts like that, but there's probably more that we could do on that front. I think on like the broader question of kind of ability to ensure these kinds of fluctuations, I think one thing to bear in mind is that when you're thinking about there's potentially like more scope for ensuring earnings than there is for ensuring hours, depending on what the underlying technology is and kind of the nature of firms' demand. Like if you need to have enough hours of people working to like meet whatever fluctuations in product demand you have from month to month, there's not really any technology that kind of obviously ensures that away. There's insurance things if stuff is idiosyncratic, like some workers' schedules are such that like we're moving some workers' hours up at the same time we're moving other hours down. Like you could imagine technology fixing that. But I think thinking about how to deal with these more like aggregate firm-wide shocks is sort of less obvious. If fundamentally you need to move hours, like those hours kind of have to come from somewhere, I think.
Sorry, if I may just follow up quickly. Yeah. I mean, you could still let the hours fluctuate, but insure on the earnings.
Exactly, and that's what salaried contracts basically do, right?
Maybe one like direct answer to the question about performance pay is that for hourly workers, the total amount of all of their earnings that come from performance pay that is recorded in the data is 1% to 2%. So it's just not, the hourly workers get all the fluctuations and none of the performance pay.
Awesome paper and really great discussion. But I think one topic needs a good bit more discussion in future literature, which is the relationship between the measure of consumption and the sort of business cycle consequences. So I know the paper tries to subset only on non-durables and services consumption, but if I look in my refrigerator, there are vegetables that are more than one paycheck old. So the point is that almost everything is a durable good at the weekly frequency. And so to the extent that people have things in their cabinets and they have lots of stuff they have bought over the course of years, the degree to which expenditure fluctuations from one paycheck to another correspond to welfare fluctuations is very dubious at that high frequency. That doesn't mean that these results are not very important for business cycle purposes, though, because there's this distinction between the consequence for business cycle, which is about expenditure trend. I mean, if there is a multiplier thing going on, then it doesn't matter really whether the consumer is spending on a durable good or on a non-durable good. It still results in labor demand for other firms. And so I think when we get to these high frequency data, we really just have to do something about that durables question for welfare versus the expenditure question for macro.
Yeah, I mean, I totally agree broadly with the point. First is sort of like a narrow clarification thing, and then like a sort of more substantive answer. So on the narrow thing, when we're doing these spending stuff, I mean, our measures of spending are monthly spending fluctuations. It's not paycheck to paycheck fluctuations, so it's a little bit more time aggregated than that. I think on the like broader data answer to this thing and mapping to like business cycle kinds of consequences, I think the most substantive thing we have on that is like, there's nothing that's super special about the monthly analysis that we're doing in the paper. That was just sort of a convenient, unit of time analysis that we studied. Like all of our facts and patterns basically like look very similar if you extend this to quarterly patterns. So you can look at, quarterly instability on quarterly spending changes. That doesn't get around this durable, non-durable issue, but like, there's always going to be that issue, even at annual frequencies, some stuff is going to be durable at annual frequencies, but I think it at least like moves us closer to the time horizons that you're usually using in business cycle stuff.
I think that with very high frequencies, it's sort of unavoidable.
Yeah.
Maybe not so bad.
Yeah.
If your vegetables are more than 1 quarter old, we'll be glad to resupply you.
Lots of other things that
Just to drill down on that welfare point for a second. So obviously how we divide up time kind of matters for these statements. So I probably don't care much about consumption volatility at the minute-to-minute frequency. I probably care a lot at the annual frequency. So how much do we know about how much workers care about month-to-month variation? And how should we think about it?
Apparently not very much.
Yeah, so I mean, I think this is a related point, which, to put it in kind of the back of the envelope we did, what's the level of risk aversion over volatility in your spending over, a 1 day, 1 month, over that period. At the one hand, we don't really know exactly. And so we, I think one piece of evidence that suggests that it's at least somewhat relevant to these workers, that we find that the households that have enough liquidity in their checking account to not have this spending volatility don't. And so that's at least some evidence that, there is some adjustment here happening, and suggests that it is at least somewhat welfare relevant, and exactly the magnitude of that we don't have a way to pin down in this paper, and would be a very interesting scope for the future.
Just want to jump in with one more small point, which is that for the consumption willingness to pay estimates, you need to make an assumption about risk aversion, and it's hard for all the reasons that Chris and you talked about. You don't need to make any assumption about risk aversion for the willingness to pay estimates which come out of the quits regressions. So those are something that's in the paper but wasn't in the talk for time reasons. And there are lots of problems with the quits regressions, but one of the things that I really like about them is that you don't need to take a stance on the workers' risk aversion over consumption fluctuations, and they nevertheless deliver similar conclusions. And so we don't have to hang our hat on a specific risk aversion number. There's sort of 2 different routes which maybe by accident point to similar magnitudes.
Awesome paper. We were very much inspired by it and reproduced some of your results on Norwegian administrative data. And in Norway, army workers have much more protection than compared to the US, but still we found very similar patterns to you. So they have much more risk on a monthly frequency. We also found a lot of risk for salaried workers, and strangely we found that bonus payments and something else that is holiday pay, it's a weird Norwegian construct, add a lot to that risk. And I'm curious how did you look into this in your data set, and how important are these risks?
Yeah, I didn't talk a lot about the salaried workers, but to some extent, one thing I didn't put up there, but it's in the paper, is that the standard deviation of earnings for salaried workers is actually as high as the standard deviation for hourly workers. And so I think this accords with what you kind of found in the Norwegian data, that it looks like hourly workers are subject to this kind of pervasive risk, and salaried workers are subject to a risk that comes from, sometimes you get your bonus, sometimes you don't, you get a commission, sometimes you don't. And to us, that just, that's not that there's no risk there for sure, but it seems like a different nature of income risk that we didn't focus on as much in this paper, but I think you certainly see in the data as well.
All right, great. Let's have lunch and resume at 1:30.
Why do you want to get these policies? Is your objective to transform the U.S. into Europe so that then we can debate why the U.S. is so poor?
I don't think we're not trying. So there's a little hard for us to talk about this. There are a lot of city laws that are regulated. So we alluded to this whole
that one I had to buy in the store. Okay, so we'll do it. Okay, so we're gonna buy some and we're gonna bring it.
Let's see.
I'll start.
Okay, yeah, that's important. I love that first one. I'm talking about my family. Good. That's good. Knock them dead. We'll try to.
Okay, thank you so much. As Mark said, this is joint work with Marty and Jana, who's also in the room, who's a great student from Northwestern, so keep an eye out. Thanks so much for including our paper. This paper started with Ricardian non-equivalence. So naturally, we're going to be thinking about what are the economic implications of deficit finance fiscal policy. Okay? And in that literature, the benchmark is Ricardian equivalence, where we all know that if it holds, there's nothing really interesting to say because deficits have no impact on the economy. Naturally, we know that there's a number of ways to depart from that benchmark. If we include finite lives, liquidity constraints, distortionary taxation, so on, we know how to break it. This paper is going to focus on a slightly different mechanism, which is going to be people's failures of predicting those future taxes. And it goes actually all the way back to the origin. David Ricardo, in his seminal work, after describing Ricardian equivalence perfectly, says, but the people who pay taxes never so estimate them. So in a sense, we could say David Ricardo was somehow the first behavioral macroeconomist in history. Okay, so what are we going to do? So this paper is going to have a combination of empirics and model. So we'll have our new data coming from a survey that we ourselves designed and implemented, where we're going to be able to measure people's tax expectations and spending responses out of hypothetical transfer scenarios, varying the degree of area consequences of those. Our key findings are that expectations of taxes do not really respond to deficit finance transfers, and that their spending plans actually reflect that misperception. So it turns out that the way they plan to spend out of a universal transfer is pretty much the same way that they would spend out of a purely individual cash check. These results are not a figment of certain segments of the population. We can do it across highly educated or no, rich or poor, a lot of wealth, not a lot of wealth, measures of financial constraints, financial sophistication, so on. These results are really very robust in a cross-section. We're going to take those ideas and we're going to incorporate it into a canonical heterogeneous agent New Keynesian model with inattentive consumers. Okay? I'll tell you more about exactly how that works, but the key implication is going to be that people are inattentive to future taxes, generating this Ricardian non-equivalence. They're more prone to spend because they don't think about the future consequences of spending. At the same time, there'll be an opposing force coming from their inattention to the general equilibrium consequences of that stimulative policy, which is going to work in the opposite direction. As it turns out, for our main calibration, the first force is going to dominate, and the inattention is going to drive an increase in spending, rendering the model consistent with our empirical evidence. With that model in mind, we turn to policy applications, and we're going to show that this type of inattention that we're emphasizing is going to be a key amplifier of deficit finance fiscal transfers, but also spending. Okay? I want to emphasize that the idea is that this methodology really reinforces the core idea of heterogeneous agent of Keynesian models that fiscal policy can be quite powerful. So let me turn to the empirical evidence. So as I said, we designed an online survey. We surveyed 6,000 US adults. The population is broadly representative of the US population. All the results that I will show you today is going to be unweighted, but everything survives if we reweight the observations to better match the US population. Okay. Respondents receive monetary incentives, so we're quite confident on these answers being trustworthy. And our key experiments are really going to be to measure people's tax expectations and their planned spending out of two different hypothetical scenarios. So to be clear, there's going to be 6,000 respondents, and they'll be randomly assigned to one of the two experiments that are as follows. So the experiment number one is people know that they're going to get a purely individual cash transfer of $1,400, okay? The idea behind that experiment is that I'm going to be able to measure just their individual idiosyncratic marginal propensity to consume absent any changes to the macroeconomy. The second experiment, it was going to allow us to dig deeper into the nature of the failure of recurrent equivalence, because we say, consider now a universal cash transfer of $1,400 that goes out to everyone in the economy. And then we're going to be interested about how people will think, reason, and decide to plan out of that second experiment vis-a-vis the first. I said we're going to measure tax expectations. We're also going to measure their additional spending. To measure their additional spending, we use this methodology developed in a recent paper by Coglioretti, May, and Sencheva. So let me start with the tax expectations. So we measured their tax expectations both prior to the scenario, giving them the hypothetical scenario, and after. So you'll see that I'm writing a regression up there that has a control for what they expected before. So our coefficient of interest is going to be the gamma age that you see there in green, and that's going to measure how much does the announcement of a universal transfer policy change people's expectations of their future tax liabilities. And we're going to measure their expectation of future tax liabilities at multiple horizons, 1, 2, and 6 years. You see basically no effects. There's a small but not statistically significant positive coefficient in the first year that says that people seem to update a little bit, but not too much, of their tax expectations over the next year. But in the second and in the long run, they don't really adjust, and we get essentially zeros. So this lends credibility to the idea, David Ricardo said, that people don't really seem to incorporate this announcement into their future tax liabilities. So then we're going to ask, how does this shape spending behavior? And for that, we're going to ask, at multiple horizons, over the first year, how would they spend the $1,400 check? We measure over those 4 years, and now what I'm showing you is just the results for how much they would spend over the first year. So this is their annual marginal propensity to consume in red, that you see is about 0.33, so they would consume 33 cents on the dollar. And when compared to how they would spend out the universal transfer, you see that there's essentially no difference. That's the green line. You see that they're essentially the same. Okay? So on average, people would spend about $440 out of that $1,400 cash transfer. As I said, we show that these results are incredibly robust. So you can throw a battery of robustness checks. You can look across education groups, across income groups, age groups. We don't really find any group among which the results go in the direction that we'd expect, which is that people do update their expectations of future taxes at some horizon in the future, and that spending, because it incorporates those future expectations of taxes, should be lower for the universal cash transfer. We find essentially no differences across all of those. Okay, because this is a survey, there's also a number of more technical controls that we think about. So the survey also incorporates attention checks to make sure of the quality of responses. We also know how long people spend answering the survey, and we're able to look at people that didn't spend very little time or that spend way too long, which are respondents, which would worry about the quality of their responses, where we control for people that spend that spend some reasonable amount of time answering this, we find basically the same results. Okay, so the core facts that I've just showed you, tax expectations seem to not adjust to the universal tax, and the spending out of the aggregate transfer is essentially the same as the MPC, are quite robust to looking across all of these different subgroups. Okay, so I want to take a step back and just before I introduce the model, say what we found and what we don't know yet. So the idea of the survey is that it's going to be informative of a moment in a model, but I need to be clear about what that moment is I know the moment of how people would plan to spend out of an universal cash transfer vis-a-vis an individual one. Okay, that's not yet a macro moment. Why? Because it's in people's heads. So realizations may diverge from what people thought before they see the actual economy play out with these checks. So I need a model to think about how that works. It's also informative of a moment that is forward-looking, right? It's not the MPC is just a moment about how people would spend out of current income, and then in the future would spend out of past income. This is a moment about how people incorporate their expectations of future taxes into their current behavior. So it's informative about that forward-lookingness, that forward-looking component. And we're going to capture the ideas in the survey using a model of inattention in Hank, which will build on the work of Adrian, Matt, and Ludwig. And the idea is going to be that inattention will capture this Ricardian non-equivalence effect, and we're going to discipline that using our survey effects. Okay. So the model is quite standard. It's a quarterly heterogeneous age in New Keynesian economy. Households will face idiosyncratic income risk, borrowing constraints, they can save in risk-free bonds. We're going to incorporate nominal rigidities via sticky wages with a standard union trick that has adjustment costs. Policy here, monetary policy will follow a Taylor rule, and I'm going to be focusing on a particular fiscal shock, which is there's going to be a time zero transfer in the first quarter, and then the deficit will be financed with future distortionary income taxation. And we're going to compute impulse responses to that time zero transfer shock. Okay. Okay. So because I'm computing impulse response functions, I know I can just compute the perfect foresight transition of this model. We know that equivalence. So if you were working with full information rational expectations, the expectations that people have over a given variable age periods ahead would just be their true realization, right? The full information rational expectations agent in this model would know exactly at time zero how the full information, how the impulse response function behaves over the infinite future. Instead, the model with inattention, we're going to model it via cognitive discounting, which was the model Xavier introduced in his 2020 AER paper, which basically says that expectations at a rise in age are a muted coefficient over their true realization, and that parameter lambda will exactly control how inattentive people are. The closer it is to 0, the less expectations are going to adjust to the shock. The closer it is to 1, the more people are attentive. In the limit of 1, people are exactly full information rational expectations. Okay. I want to emphasize this is one model that you can choose. In the paper, we actually show a variety of models that will achieve the same overall conclusions. We go with this one for the quantitative analysis, both because we think we capture some other dimensions of behavior that are important, and we would be happy to discuss later, but also because it's quite tractable and easy to implement. Okay, so let me tell you what would happen if I was to run experiment 1 in my model. So this is average spending out of a transfer that is purely idiosyncratic. It would just be equal to people's MPC that I'm going to denote M0. I want to show you this because then I want to ask what would be the response to the universal transfer. So the universal transfer would also incorporate their intertemporal marginal propensities to consume out of getting less income in the future because there's distortionary income taxation. So those M's are going to capture the intertemporal marginal propensities to consume. And then similarly, for changes to their incomes in general equilibrium and changes to real interest rates because of monetary policy and inflation. One thing I want to emphasize is look at where inattention shows up in those formulas. It shows up exactly as dampening those intertemporal marginal propensities to consume. So the way inattention plays out is exactly in dampening things that are happening in the very far future, mitigating its influence in current consumption. Let me also emphasize that there's opposing forces here. Incomes are going up, so because people are inattentive to those, they'll consume less. But taxes are also going up because of inattention to that, they're consuming more. Which force wins turns out to be a quantitative question. And in the paper, we show that, as it turns out, for small levels of inattention, meaning if you're close to 1, just deviating a little bit creates a very sharp increase in planned spending behavior. And intuitively, the reason is that these tax liabilities are really coming in a very far future, where the model of cognitive discounting has a lot of bite. So a small degree of inattention can match our survey facts that the MPC is equal to the planned propensity to spend out of the model. And we find a lambda equals 0.22. That's still not enough to get our tax expectations facts. That tax expectations don't seem to change that much. In the paper, we additionally show that there's an alternative calibration that features an even lower level of lambda that actually does a good match, slightly overstates the propensity to spend, but does a good match of the tax expectations. And everything that I'm going to tell you will just be reinforced under that alternative calibration. So here I'm showing you why the model is successful at accounting for the data fact. So in blue, you see what the planned propensity to spend out of the transfer, meaning what people would answer at the moment that they're answering the survey. That's 0.33 as we found in the data. And that's because, and then we can, using the formula I showed you before, we can decompose that into each term, meaning the current MPC, propensity to spend out of future taxes, income, and real interest rates, and so on. And what I want to emphasize here is that the general equilibrium forces tend to be small in this model and go in opposite directions. Interest rates are going up, but people are inattentive to that, and incomes are going up, and people are inattentive to that. Those general equilibrium forces tend to be smaller and offset each other. The really big thing here in this model is the inattention to taxes. So in red, you see the negative influence that the expectations of future taxes are having on current consumption behavior. You see that it's dragging it down. But you also see in the dotted lines that if people were to have the correct expectations, the influence of taxes on their behavior will be 3 times as large. Thanks, Mark. So that really shows that the way the model is accomplishing matching the survey evidence is really through this Ricardian non-equivalence effect. So with the time I have left, I want to turn to macro implications. Okay, so I want to think about what would happen if I was to run deficit finance transfers or deficit finance fiscal spending and ask what are their multipliers. Okay, so here's a case of transfer multipliers. And I'm computing both for the full information rational attention model, rational expectations model, and then I'm computing for both our calibrations of inattention. And the message is that inattention does significantly increase transfer multipliers. You see that in our baseline case, our conservative case, it increases it by at least 20%. In the more aggressive case, it increases by almost 50%. In the paper, we show a decomposition of these multipliers, and we again show that this is really driven by the inattention to taxes, whereas the inattention to general equilibrium effects through income and interest rates goes in opposite direction and tends to net out in consumption behavior and multipliers. So as I said, the bottom line is really that this inattention seems to greatly amplify the consequences of these deficit finance transfers. We have an additional result in the paper that I don't have time to cover, but shows that Hank is actually crucial for this. There's a complementarity between having high intertemporal marginal propensities to consume and this Ricardian non-equivalence effect, because you need people to be consuming a lot out of this perceived income gain because they don't think about those future taxes. And the inattention. We can also do impulse response functions. Let me just show. I just want to emphasize that the way that the patterns of expectations behave in this model are quite similar to what you would find in a variety of papers in the survey that look at surveys of expectations. Let me just show you finally what would happen for government spending multipliers, where in our baseline model, because of the aggressive response of interest rates in the Taylor rule, the spending multiplier in full information rational expectation would actually be lower than 1, whereas instead with inattention in both of our calibrations, the multiplier would rise above 1, meaning that consumption behavior would actually rise instead of fall. in response to the announcement of government and the associated future taxes. In response to the announcement of government spending and the associated future tax liabilities that come from that deficit finance spending. Okay, so let me just conclude. So in this paper, we basically think about households' inability to map deficits into future tax liabilities. And it turns out that we find evidence that their spending behavior actually reflects that inability to think about future taxes. We incorporate this key idea into in an inattentive Hank model that is able to account for the micro facts, and we're able to develop new aggregate implications out of that. The key implication is that transfers and government spending multipliers tend to be much larger than we found before. And we have this additional result that heterogeneous agent models and inattention tend to be complements in the sense that they just magnify each other. Okay, so there's additional results in the paper that show that if you were to do the same exercise using simpler representative agent models or even two agent models that are sometimes thought to represent heterogeneous agent models well, you'd get very different results, and those models can't even be rendered consistent with our empirical evidence. So in sum, the point that we're trying to make is that this Ricardian non-equivalence effect, the failure to predict future taxes that David Ricardo had in mind, seems to reinforce the core Hank message that fiscal policy can have large stimulative effects in the economy. Thank you very much.
Thank you. The discussant is Adrian O'Clair.
Okay. This works? Okay. So thanks, Mark and Pete, for inviting me to discuss this really nice paper. Okay, so a central question in monetary economics is that of what the macro effects of deficit finance fiscal transfers are. And for that question, we've got this super nice benchmark of Ricardian equivalence in which the effects are zero. Okay? And this is a celebrated result that every single graduate student in macroeconomics has proved once in their life. It's one of these amazing results that works absolutely beautifully in theory and utterly fails in practice. And so a kind of natural sort of follow-up question that the literature has been asking is, why is it that Ricardian equivalence fails? Right? So that's actually really central to recent modeling efforts. Right? And the Hank literature has taken this particular stance on it, which is that households face liquidity constraints. And so they have high marginal propensities to consume because of that. This paper agrees with this statement, so it kind of reinforces that statement, but it also says that there is an additional reason for failure of Ricardian equivalence, which is that households do not even understand that when they get a deficit finance fiscal transfer, that's going to have to come with future increases in taxes. So what the paper does, more specifically, it brings to the table this new survey that has 3 hypothetical questions to households, following a nice kind of methodology put out by Kolarioty, May, and Stancheva. So there's this kind of classic question of the MPC, you know, what is the MPC out of a transfer to just you? That's a question that many other surveys have had. And then there is a more specific question to this paper, which is, what is the MPC out of a transfer if everybody gets it also? Right? So this is I'm going to call this MPC GE. This is not the general equilibrium MPC. This is what households think is going to be the general equilibrium MPC. In other words, they have to think through the general equilibrium, and this is the effect they report. And then finally, the third big question of the survey is, well, given that you know this, that everybody will have to pay for it, how much do you think your taxes will increase over the next 6 years? So I'm going to call this DT. And so the key 2 findings from the paper are that the MPC with general equilibrium effects, the GE think through MPC, is the same as just the individual. And for the most part, people don't think that if everybody gets a check, the taxes will rise at all. Okay? So they're going to think of these as new moments that can be used to calibrate a Hank model that features a departure from rational expectations here, which is going to be done via cognitive discounting à la Gabex. And then in the model, their main finding is going to be that fiscal policy is even more powerful than in the rational model, precisely because of this fact that households don't think about the future higher taxes that would dampen their spending. And so just before I go into the discussion, I just want to talk a note about this agenda. So I think behavioral Hank is the future of macroeconomics, or at least monetary economics. I've said this before. You know, for Hank, we needed micro moments such as the MPCs to discipline these Hank models, and we have made a lot of progress, but models with full information rational expectations tend to reach kind of some limits. There's things like the forward guidance puzzle and so on that they have a hard time to explain. And so this paper offers some new micro moments to discipline these behavioral frictions. So I think that's really great. And I also think that as a source of moments, these hypothetical survey questions are a supernatural source, right? Both because reported MPCs from these surveys have been shown to line up with natural experiments, right? So you might be concerned that people just don't really think about it and they would be doing something differently if they actually got the transfer. That doesn't appear to be the case. And also because the behavioral literature has actually been using these surveys for a really long time to discipline their models. And so you can kind of think, okay, where am I going to get my moments from when these hypothetical surveys are supernatural? And so they're one of the first papers I know who go ahead and conduct this kind of survey, and I think that's really great, okay? That said, I think it shouldn't preclude us from also using macro moments to get the GE right. So some of the older types of moments that, say, Marty and Larry had worked on. And I'll kind of talk about this towards the end to say, like, okay, how far can we go with just these survey questions? Right? So my discussion is going to center on what we learned from this survey data. Right? So first I'll ask, okay, well, so we find this DT equals 0 result. Is that really indicative of a departure from rational expectations? And also, I'll talk about this other moment, which I think is more informative, but there is kind of some subtleties. And so, you know, as I go, I'll sort of want to draw your attention to this question of what else would we need to really pin down fully this model. But overall, I thought it's a really great paper, super thought-provoking. I really enjoyed going through it. Okay, so what do we learn from the survey data? Okay, so the first thing we learn, actually this is in the appendix of the paper, is that confirming that intertemporal marginal propensities to consume are high. Okay, so this is intertemporal MPCs are the path of spending, not just the impact effects of the MPC, but the path of spending after people get a transfer, right? And we've shown in our JPE paper that this is a super important moment for these models. And so here you see in the data, if people get $100, they'll say the first quarter they'll spend 15, right? But then the next quarter they'll still spend 8, and the quarter after they'll still spend 7, and so on and so forth, right? So that is kind of important. Of course, the impact MPC, well, that's consistent with the large literature, so you could say that's a validation of the survey. This is consistent with what other people have found. Right, but the tail of spending, actually, you know, the Colarity paper, Colarity et al. Paper had that, but there's some controversy in the literature, right? And some papers I have listed over here, over how persistent these effects really are. Okay, so the fact that they're persistent over here is kind of in the literature. That's a validation of these Hank type of models over simpler, say, 2-agent type models. And you know, the paper actually kind of totally embraces that. It starts from a Hank model. As you can see, the Hank model fits the data really well. Okay, so I think that's really nice. You know, we learned that from the survey for sure. Right? And another thing that we learned from the survey that's also a little hidden in the appendix, it's just confirming that in the first place, these liquidity constraints matter. Okay, and some simple thing you can do as a survey question is you can ask people, what if I give you money and then I take it away in exactly a year? Okay, and the survey, and so here I've replicated the model intertemporal MPC. So this is just if I just give you money, and then the orange line here is an experiment in the model that says I give you money now, and then for sure in 1 year, you know, in quarter 8 here, you're going to have to pay it back. Right? And so that just captures the pure liquidity constraint effect. This is a present value 0 transfer that raises your spending. So it's a pure liquidity constraint effect. Now the model, the paper, the survey reports these intertemporal MPCs in appendix experiment 3 in the appendix. Now the thing I didn't understand is the question is framed in general equilibrium already. So this is actually saying in experiment 3 and also everybody gets it, which I think is a little bit less good than having the other one, which have been if just to you, that's no aggregate implication, because that would have just picked up the pure liquidity effect, right? But of course, for there to be any effect at all in a model, you need some kind of effect from the primitive thing. And so this is suggestive that their liquidity constraints matter. And also you can actually use this experiment 3, which is not really used in the paper very much, to kind of validate the model. So I then went through the general equilibrium in the model, and I said, in the model, in general equilibrium, what would be the reported MPCs that people would think through if you told them about this experiment? It's a little bit undershooting the experiment 3, but it's I think kind of quite nice and suggestive that these liquidity constraints matter and could be used as an additional moment. Okay, so the paper has these two results. I'm going to talk first about this taxes don't appear to respond result. Okay, so the paper measures the expectations of tax changes. So they say, how much do you think your taxes will rise at horizon 1 year, 2 years, 6 years, both before I tell you anything and then after I tell you that you get a transfer, right? And then it reports these regressions that are regressing the post on the pre and an indicator for whether it's the universal over the individual, right? And so I'll show you these results. So I want to say, well, does this mean that people are irrational about future taxes? And so the first thing I want to say here is, okay, this is a little bit complicated of a regression. It has a bunch of things, and really it's kind of a double difference, okay? So this is saying, how much do they revise over in the second experiment over and above the first experiment, okay? And so I think it is useful. Of course, there's no controls here, but the authors nicely provided their data. It is useful to just look at the levels, okay? So just think, on the left you have the individual transfer, on the right you have the universal transfer. The pre is what is collecting data before you tell them anything, and then the post is after they update, okay? And so what's interesting here is, well, first of all, I'm kind of curious about this, well, people do think their taxes will rise. Okay, and by kind of a non-trivial amount, right? So this is 8% after 6 years. Now this could be inflation. The question isn't specific, so this could just be what nominal taxes might rise. This could be that they're just naturally expecting their real income to increase. Okay, but at least that's kind of fine, right? And then the other thing to know is, in the individual transfer, actually after you tell them, hey, you're going to get money, they actually think their taxes will fall. Okay. And that could be, well, because perhaps, this is like, hey, great, I got a transfer, maybe I'll get more, right? And so this could be rational updates to, I just told you you're going to get a transfer. Now, in the universal transfer, also, they think that their taxes will fall. It's just that it falls by slightly less. It's kind of not statistically significant, the difference between the fall in the left and the right, right? But you might be thinking like, okay, well, there's a limit to how much the government can do this. So, a potential rational expectations explanation of this is, well, maybe households are not totally sure what the type of the government is. You're telling them they're getting money. They might start updating and thinking, okay, this is a government that's pretty profligate. It's going to give me more money in the future, right? And so I think it's a little bit underpowered to really kind of tell much more than this, and especially kind of to definitely rule out a rational model. Okay? There's also a question of the intertemporal budget constraint, right? So the tax expectations, remember, they're only measured out to 6 years, okay? But I was going to say, we live in a pretty special time, right? Where taxes do seem pretty unresponsive to deficits. So this is the post-war history of primary deficits to GDP on the left, right? And they used to go up and down and so on, right? And then after the Clinton years, there's basically been just giant primary deficits year after year, including 2 big things during COVID. And what's happened since the 1990s? Well, basically totally flat federal tax revenue, totally flat marginal tax rates. So, people have lived for 20 years with literally no change in taxation, right? And so if you ask them, well, in 6 years, do you think your taxes will rise? That's not that surprising, that they would say no. And so I think 6 years is maybe too short. You would be very interesting, though, to think about, hey, what do people think about the fiscal consolidation that's going to have to come at some point, because we cannot keep running these giant primary deficits forever. And also, in the paper, in the quantitative model, there's this fiscal rule that's very important. I think it'd be kind of nice to try to estimate the fiscal rule, and especially sort of in recent years, that's going to imply very, very persistent debt. Okay, so now I want to turn to the second moment in the paper, which is this MPC equals MPC sync through GE result, right? And so here I've plotted it. Again, the authors gave me the data because that's my favorite plot. It's these intertemporal MPCs, right? And so you see that it's really basically one on top of the other, okay? So you tell them, everybody gets it. They have to think through, oh, well, everybody gets it. Maybe, okay, income will be higher, so then maybe people spend more, or, well, also taxes will have to rise. They have to think through all this stuff. And in the end, they say the same thing. Right? And so let's say 2 things. To me, this does suggest people have a hard time thinking through general equilibrium. Okay? You tell them it's everybody, and then they have to think through, okay, what does that mean? So that's suggestive of that. But it's not a definitive proof of that, because if you're a very rational person, you might say it could also suggest offsetting general equilibrium effects. Okay, and in particular, there's a classic one. in our models, right? Which is there's a crowd-in effect from this consumption income feedback, right? So if you just thought, say, the Keynesian cross, everybody spends, then there's more income, there's more spending, right? But then there is offsetting effects from tightening monetary policy. So interest rates rise, and then in equilibrium, that's kind of bringing things down. It could be that those two lines are on top of each other, not because of a departure from rational expectations, okay? Right. Okay, so let me talk about, in this slide, the model identification procedure. So the paper sets up this quantitative Hank model with cognitive discounting friction and like X, right? So there's one parameter lambda. This cognitive friction is applied to everything households care about. So this is income, so not just taxes, but income, interest rates, and so on. And then they calibrate the model to data AMPCs plus typical parameter values, including for the monetary policy rule. And then they're going to find the lambda that solves this equation. So MPC equals the general equilibrium think through MPC. Now, in order to do this, you have to carefully think about what is the model analog of the thing you're measuring. Right? And like I said, it's not the general equilibrium MPC. It is what people think will be the effect via general equilibrium on their own spending, right? And the paper does this super nicely, so I actually kind of had to trouble replicating the results for a while until I kind of figured this out. So this is very, very nice. But it is very sensitive to the general equilibrium assumptions underlying the rational expectations model, right? So to illustrate this, let me show you after I kind of worked out the replication. This is the graph that Joao showed you, right? So this cognitive discount factor in the x-axis. So 1 means full information of rational expectations, and 0 means complete cognitive discounting of all general equilibrium. So 0 must mean that you have the same as the MPC by definition. Okay, so you're on top of MPC, and then remember the result is data general equilibrium MPC that they report is the same as the MPC. Now, what's nice here is there's just one parameter left, okay? And so you can kind of use the other intersection. I mean, unless you think everybody is completely irrational, right? The one point of intersection to pin down your lambda. And this is the procedure and the basic calibration, right? So this conservative calibration, okay? Now, on the right, you've got the full information rational expectations solution, right? And so what I want to say here is it's important that this thing lies below the MPC, right? And for instance, let me take another monetary policy rule, which I know I work with this model, which is the constant real interest rate rule, right? So this is going in the direction of the zero lower bound, where there's much less offset from monetary policy. Well, then this is like the Keynesian cross type of model, right? So the full information rational expectations aggregate equilibrium effect would be higher than the MPC, right? And if so, then you couldn't get any intersection at all, right? So it's important that you start from below. And so what this is telling us is it's not just lambda that's being identified here. Actually, it's a combination of lambda and the monetary policy rule, okay? And now the problem with that is it's kind of weak identification, because for instance, you could say, hey, let me do something else, which is let me figure out what's the monetary policy rule that would be consistent with the two being equal under rational expectations, right? And so this is this green line over here, right? And so my bottom line here is it's kind of a bit underpowered, like you're trying to identify many things at the same time, and so you kind of need to bring in moments from the macro data, right? So it's not enough. You need to know like what's the responsiveness of monetary policy to be able to even be able to know what the lambda is in the first place, okay? Okay. Now, so you kind of need a macro moment to identify. One natural moment that you could bring in if you had that, perhaps some other brilliant kind of economist empirical economist in the room can do this, is give me the macro transfer multiplier in this situation, right? Because the macro transfer multiplier does differ from the general equilibrium effect that households report, and that is more informative, actually. The difference between these two things would be more informative about how behavioral people are, right? It's like, well, how much do they know what the actual effect will actually be? That's going to be informative about how bad they are at processing through general equilibrium. Okay, so there's this main applied message in the paper, which is macro effects of cognitive discounting. Higher cognitive discounting makes fiscal policy more powerful, right? And that's kind of the main message of the paper. And that's because this RNE effect, which is people are not as concerned about future taxes, kind of dominates the offsetting general equilibrium effects, such as people are not as optimistic about future income. Now, when I read the abstract of the paper, I thought, oh, how can this be? Because I've already kind of looked at something like this in the model of mine, and it went the other way, right? So one concern I had immediately, and what you might be having a concern too, is, well, this might be highly sensitive to calibration. I mean, at the end of the day, there's a bunch of stuff going on, and this is a message, but it's clearly, there's two offsetting effects. How could you tell, right? And so in the constant R model, like I said, in interpropagation cross paper, we had the other thing. But what I think is very nice is actually you can combine it with the argument from the previous thing that even for identification, you actually need the full information rational expectations model to be below the marginal propensity to consume, then to argue that at least locally it has to go this direction. So it's not like a specific thing about every parameter in the model needing to be tied down. It's actually kind of a broader argument you can make that kind of it has to be that in general equilibrium the RNE effect has to dominate. Okay, so one parameter to rule them all. Okay, so in the simple one-period model, and Joe mentioned this too, there's in fact this beautiful appendix, C6 in the paper, that says, hey, lambda could come from many other models in cognitive discounting. It is not just necessarily this one. It could be dispersed information, sticky information, sparsity, K-level thinking, limited planning horizons. They all fit in the one-period model, this framework. But the problem is for the Hank model, these things totally extrapolate differently to dynamics, right? And so, they have very different macro implications, right? And so in particular, say sticky expectations would behave very differently from what Joe showed you, where here people, they see the taxes rise, but they keep thinking they're going to come back, right? And whereas in sticky expectations, they would say after a while, it's like, well, everybody now knows that the tax path is this higher one, and so the expectations for the future would be totally different, right? And I think, to pin that down, right, you do need something else. And so Joao sort of brought this up a little bit, but I think it would be nice to just say a bit more, hey, okay, it's one parameter model, but this is why we pick this one and not all these other ones in Appendix C6, okay? All right, so just to conclude, I think it's a super nice paper. It provides new moments from this behavioral Hank literature, and I think especially I really like this general equilibrium think through kind of MPC question. You can refine the identification argument, strengthen the quantitative applied message to say it applies more broadly than in your calibration, and potentially bring in other macro and expectations moments. And so I'm very excited for the next papers in this agenda.
Okay, let me abuse my privilege and work in a quick comment. On a follow-up on Adrian's comment and how you could address it, the comment about how stabilizations could take more than 6 years. So one thing you could do is take your model and assume that the government doesn't adjust the controlled fiscal deficit until 7 years out. Okay, but in your model with behavioral discounting, it still seems like you might have a strong effect of fiscal transfers. It's far in the future and you have behavioral discounting. You might be interested in seeing that.
No, thanks for the question. It also lets us thank the discussant for the great comments as well and address at least one. Actually, we have one appendix where we do exactly that type of experiment where we say, suppose there's no fiscal adjustment and we go all the way at 10 years out. To be concrete, we only do that for the full information rational expectations benchmark. And the point is to try to say that just the lack of fiscal response for at least 10 years is not enough to render the model consistent with the survey evidence. In a survey, it would be super interesting to think about going longer run, and I'm very sympathetic to that. Who knows when the US is exactly adjusting taxes to current deficits. We tried 6 years as a benchmark for how people perceive. One interesting thing about why do we do 6 years, because the survey was done in 2024, so 6 years meant 2030, and so the way we thought about it is that people perceived that as like the next decade. But it would be good to go longer run if we could increase the cognitive burden of answering all of this.
That survey, people think the government will ever consolidate.
That's a great question. There's a lot of people working on that question.
What they think.
Absolutely.
Yeah, so I was going to almost ask questions kind of upstream of Mark's questions, sort of the same thing. I was just really confused with the statements straight away that the government has to increase taxes. I mean, why not just, it's unfunded, it's paid for effectively by higher prices. And why we jump, I just don't understand why that was ruled out before we did anything else and jumped to something else. So can you say something about that? It's just super confusing to me why we jump away from that benchmark.
Relative to which benchmark, Rick?
that we're never going to raise taxes to pay for additional services.
Oh.
That's perfectly coherent, perfectly consistent, probably might be the most likely scenario that most people think.
Okay, so we have this exercise where we try to delay the adjustment. We haven't gone all the way to infinity as say Chris, Marius, and Chen do, but we've tried to delay. We haven't gone all the way to infinity. We have also exercises where, keeping to the basic fiscal rule that we adopt, we increase the persistence of the debt, and we try to take that all the way to very close to 1. I think our upper bound is like 0.999 persistence of debt over a quarter.
So the initial question was that people respond that they don't think that taxes are going to rise, and you interpret that as an irrationality. What's irrational about that belief?
It's still irrational that their behavior would exactly coincide with their partial equilibrium behavior, and we show that in the paper. It's a quantitative statement, but it would still be irrational in that world for people to not expect, and this is additional results that we have in the paper. We also have the expectations of interest rates, inflation, and income, and there's no change to those expectations. And in a model that you have in mind, those things would have to change. So even then, there would have to be some sort of inattention. And given that Adrian talked about it, there was a third experiment that we couldn't talk about, unfortunately, which is this third experiment where we tell people that the taxes are going to come in the future, but we don't tell them anything about their other macro consequences of that universal transfer. In that type of world that you had in mind, if I tell people that the payments are going to come exactly next year relative to the indefinite future, that should lead to a lot less response of inflation. It's actually interesting that people think it's more inflationary rather than less. That's a bit of a puzzle, but it goes against the type of model that you have in mind. I was just trying to think about it, yeah.
Perhaps you've done this version, not a suggestion for the next paper, but have you varied the size of the transfer you give to people? So now you tell them it's $1,400, and I'd like to know not so much 140, but I'd like to know if you tell them
14 million. How about 14 million?
Well, I was going to say 14,000 or 140,000, and I'm not trying to be funny, but I think this would be interesting in 2 dimensions. First, because while in Xavier's very elegant model or other models of time dependent attention, size doesn't matter. We would think that attention is somewhat state dependent, and as you give them a bigger fraction, a bigger amount, that should at least, I think it's a pretty robust prediction for an attention model, that you would have them paying more attention to this. So that would allow to distinguish a little bit along the lines of Adrian. Are they offsetting G effects, purely just attention or not? But secondly, and I guess I'll be the third after Mark and Greg to suggest an alternative, which is that if you made it, you're going to give me 14,000, or why not 140,000, I wonder whether that would trigger people to answer, well, there won't be transfers. Maybe there would say inflation. Maybe they would say you default. And I do wonder about, I'll put a third one on the table to Greg and Mark, which is, if you tell people I'm going to give you a lot of money now, I wonder if they say, well, the government's going to default on their social security payments on me, which you and I would interpret as they're cutting a transfer, but actually people will understand as a default beyond some of the others. And that comes up in public debate sometimes when you see governments behaving responsibly, but the first reaction will say, well, there goes social security, there goes a default on pensions, which would be a transfer, but they may not answer as a transfer. And I think only asking a very big number will get them to eventually say that.
Let me just say, I'm all in favor of big numbers. Well, no, because all these models are approximations, right? We know at some point they're going to break down. But in that particular case, if I gave them a big number, it's kind of interesting, because if it was just E1, if it was just the idiosyncratic thing, I don't know how these other scenarios about default kick in. As a complete aside, and this has nothing to do with our paper, if you look at what you'd have to do with inflation to fund the debt, forget it. The term structure of our bonds is just not long enough. So that's why I'm not particularly concerned that particular channel, we're gonna have to do something else. Inflation's not gonna be enough, but I'll stop with that.
If I could address one point, which is, it actually helps me address one of Adrian's comments, which is we also agree that we could have more macro moments also think about this. And actually in a recent paper with Diego, Joe, and Ed Manuel, we have exactly this. It was presented earlier in the week in the Impulse and Propagation group, actually, that Diego presented beautifully. So in that paper, we actually have evidence of transfer shocks for the United States, and we do find big multipliers. We also find some, not perfect, but some evidence for some nonlinearities in the size of the fiscal transfer. We think those are super interesting questions that we need to address, absolutely.
presentation.
Thank you.
Nice discussion. So thank you so much. There is a possibility that there's a group of people that wouldn't bother responding to surveys, but would actually internalize these. So think that the bottom 99% of the income distribution is okay, very good, and maybe taxes will go up, but not mine. You're gonna tax the rich people, and perhaps the rich people are maybe it's time that pick your favorite tax. The top marginal tax rate will go back to the 70s, the estate tax is going to go up, there's going to be a California style wealth tax, whatever, but everybody's going to get a transfer, and then I will end up paying for this. In the survey, you can't do this. I don't think there's a way of getting these people to answer these, but in the model you can, and it will be interesting to see if you have a group of people who behave this way, what would happen to these multipliers.
Great, yeah. Actually, we do have, so if you look at Appendix XYZ 37 or something like that, there is a big table that shows the representativeness of the survey, and we do capture quite a substantial, or quite a good fraction of people that are higher incomes, higher wealth, and that's why we did all of those robustness checks, because we were worried about those type of problems, which would be what about if the average person is not really being called to pay for tax, but it's really the upper medium to upper class that will be asked to pay for these transfers in taxes. We don't find any significant differences. And also, even if they were not expecting taxes, and in the 20 minutes that I had, I could only show you the evidence for the tax expectations. We'd have expectations for all these other things, interest rates, inflation, incomes, and we don't find any responses on that. So we think that the bulk of the evidence points to a model of inattention, but I only had time to show you a small subset of the evidence that we do have in favor of that model.
Great. I think it's a great paper, not just because of the model, but also because the work is very sensible. If you ask about anyone in the street, you think about Ricardo Equerens, they look at you like you have 3 heads and it's informed by a PhD. But let's operationalize that. So first, I like a lot, of course, we should have surveys, commercial, you ask what's inflation, we say it's 8%, kind of, we say the wrong things, good to know. But here you guys are using hypotheticals, which I think are much better surveys. If you received $100, what would you do? Yesterday at the asset pricing meeting, there were also some survey-ish things. If the equity premium went down by 1 percentage points, how would you rebalance the portfolio? Basically, people say not at all. So that's informative to some behavioral moments, etc. But I think the next generation, maybe you guys, it would be you do your surveys with hypotheticals, and then maybe for half of the people, with a reason. What was your reasoning? And some of the questions, like certain things, maybe they're thinking very hard with the G offsetting effects. I bet you they don't. Okay, just maybe in Argentina or countries like that will be traumatized by government's misbehavior, but in general countries where they haven't seen gross government mismanagement, too much, but they don't anticipate those things. So I think asking, you don't want to always ask the reason, because then you force people to be too smart. Okay, first you want to say, what do you think? And then they blurt out something. But half of them or a quarter of them asking, what was your reasoning? And maybe, did you think about the fact that there will be a boom, etc.? And they probably will look at you with blank stare and say, of course not. How could you think that? I think that would be a very, very healthy way to model things. And frankly, we go much faster to the truth.
Well, first, I agree with everything Xavier. Let me just say one thing. Having taught executive MBAs for a long time, I've concluded that introspection is the worst source of data for an economist. That is to say, we think differently, and so it's very useful to ask people what they think. And it's hard to do it exactly the right way, and I'm all for everything you say, but I just want to corroborate what Xavier said. If you talk to very smart people, right, and you explain the logic of Ricardian equivalence, they look at you like you just landed from Mars. Now, that's not science, and that's why we do this stuff, but I'll just say that.
Maybe you should add something. So, something I advise the students to do. For anything, first try to simulate how real people would think. Forget about all the economics you've been. Essentially, try to anticipate how regular people, smart dentists who doesn't or bonus per software, how they would think, and then only we try to do clever reasoning and homework exercise.
I also would like to agree with one thing that you said, and Ricardo also said the same thing, is like we also don't think of these attention parameters as being like truly structural parameters, and so we would expect that if regimes change substantially, the way people think about the economy or what they've learned from recent past experience would greatly change the way they behave. So we also think that would be a really interesting thing to do in the future.
Yes, so very nice. So related to Ricardo's question, I think if you were to solve the model non-linearly, you would probably get bigger gap between the behavioral model and the rational expectation model, because effectively, once you linearize your model, you're effectively assuming that those outputs that are constrained are going to remain constrained no matter how big are the transfers. Okay? So once you do it non-linearly, those outputs that are constrained are going to be responding to the transfer, but also to expectations about future fiscal policies as well as G effects. So this mechanism that you have is probably going to get stronger if you were to solve it fully non-linear.
Everything that goes in our favor, I don't have anything against. I do. Yeah, I think it'd be interesting to do. At a computational level, it's much more difficult to implement these types of models because you have to keep track of not only the differences in people's expectations relative to the truth, but also in terms of their entire probability distribution over a variety of scenarios, and that can get quite an unruly computational problem to solve. That being said, we do think that's interesting. We do think our message would survive. We could discuss exactly which direction we'll go. I think your prior is good for us. But I think it would be interesting, but we require some computational advances to fully solve it non-linearly, I would say.
Chris, I can't help pointing out that Adrian Alclair, who is one of the people that helped to invent the Hank model, found it difficult to figure out how to do the calculations that he thought would be required to give the right answer to the NPC GE question. And it turned out to depend on various things like the monetary policy response and the term of the fiscal prevent. So the extent to which making the model even more complicated by taking into account various nonlinearities and those sorts of things is directly on point to figuring out what the likely consequences of fiscal expansions are. Seems remote to me. It's a lot of work, and the extent to which your results are going to be more credible if you work out even more complicated models that even Adrian couldn't think of or work out seems unlikely. So figuring out how to perform your expectations, as Xavier was seems much more promising.
I think that's a valid comment. That's a good comment. Yeah. So in the paper, we explored a number of different ways of forming expectations. We kind of show that the forces that we're emphasizing would be robust to, and Adrian put up the list. Marty calls it the Joel appendix because he says I went crazy on that appendix. But I think there's 12 different models that would capture the same key idea. Quantitative implementations tend to vary. One thing I tried to emphasize that I think is quite interesting of this model is that it does extrapolate over the far future in a different way than, say, a model like Manque-Urey's would be, or a model of noisy information would do. And it does capture this pattern that the further into the future you're thinking about, the more you're going to dampen relative to the truth. That turns out to have particular quantitative bite for this question exactly because that's when the taxes are really coming in, is in the very far future. So the quantitative combination turned out to be quite interesting to think about, and we explore some of that in the paper. But the key qualitative forces would be there independently of which model of expectations we adapt. Of course, that does not preclude the idea that thinking about what's the right model or the best approximation of how people think is, of course, a very worthy pursuit.
Let me just say, I think, Mike Woodford has done brilliant work on finite horizons, but you got to be really smart to figure out what to do in a finite horizon, especially with the GE. And that's when I go back to Xavier's paper on complexity aversion. And, I think this is a very exciting thing that this generation of people will have to figure out. So that's exciting.
Yeah. it's good at this point so that we need better investigation, not of an infinite number of hypotheses about expectations, but data on how people actually form their expectations. That's the future.
And hopefully we have our moderate contribution to that.
Okay, one more question.
So Hamish Lowe and a bunch of UK-based co-authors have a hypothetical MPC paper where they ask two versions of the partial equilibrium question you ask. One version is, I think, what's your MPC, and the other is, if I give you an idiosyncratic transfer, would you spend it or save it? And then if you say spend, what's your MPC? So it's two versions that everyone in this room would answer in the same way. And people give very different answers, like wildly different magnitudes for MPCs. And then because they happen to be doing a survey panel, or they also have income and spending, they can also do BPP and estimate MPC out of BPP. And they get a third answer that's different from either of the two survey hypotheticals for the MPC. And so I'm curious, like, what would you say to someone who's coming from the perspective of that paper and has like a lot of ex-ante skepticism about the usefulness of hypothetical MPCs because the answers are sensitive to things that people in this room would think of as being irrelevant from the perspective of the MPC?
So in that dimension, in the elicitation of MPCs dimension, our paper is not innovating at all. We just follow the recent papers in the literature and how they do it. I think it's a super interesting question. We have a long comparison of our estimated MPCs and what the literature, even the observational literature, finds for MPCs, and we confirm that we are in the same magnitudes, and that builds confidence to our particular way of doing it. We have not explored with different alternatives. I think they'll be interesting. We have confidence in the one that we have implemented, both because the prior literature has found that it's quite informative, and because we have compared our own results to the literature as well.
Yeah, so just to reiterate, the fact that people have gone out with more traditional methods and come up with very similar answers says we probably didn't ask a completely stupid way to do it, but I do think it's a very important task for future research. Just like Mansky, for example, on inflation expectations, really smart people had to work on what's the right way to do this, and that's going to be a corollary or part of this forward-looking agenda of how to figure that out and do that properly and do the right controls. So, important concern. I don't think it bites in this context, but as we go forward with these issues, I think it's going to become very important.
Okay, great. Thanks a lot. We will reconvene in 15 minutes.
Have you guys considered going the other way? What happens with tax? I'm curious about what responses. I'm also curious so suppose we told that's the because it turns out the answer is just
Yeah, you were helping me?
Oh yeah, of course.
I'm the
Thank you. I want to stop. Oh. Did I touch something?
No, just I think. Yeah, if you just want to touch the screen and not the laptop.
Don't touch the laptop. Okay.
Okay, the next paper is how does monetary and fiscal policy affect the economy in the face of large shocks by Greg Kaplan and Ken Mehara and Greg Wolfson.
Great. So thanks very much to Mark and Pete for putting the paper on the program. This is joint work with Ken Miyahara, who is a graduate student at the University of Chicago, who you'll be hearing a lot more of. So between a pandemic, wars, politics, the first half of the 2020s were pretty wild. We saw a dramatic initial decline in economic activity, followed by some extraordinary policy interventions. There were large fluctuations in inflation, first deflation, then inflation peaked above 10%, now persistently above trend inflation, and depending which statistics you look at today, the price level is somewhere between 15 and 20% above its pre-pandemic trend. The fiscal response, much of which was direct transfers to households and firms, was larger, more targeted, and more explicitly financed by borrowing than in previous recessions. And the monetary response consisted of unusually large movements in nominal rates. So against this backdrop, what we want to do in this paper is ask three questions. First, how would the economy have looked without these fiscal and monetary interventions? Second, what if we had made different policy choices, specifically around the financing and design of fiscal stimulus and the timing and guidance of interest rate movements? And finally, was it all a good idea in the sense of what were the welfare implications of alternative policy choices? Now, these are all counterfactual questions about a unique episode, and so to answer them, we're going to need a model. And we're going to argue that modern quantitative macroeconomic models, New Keynesian DSG models, are actually quite well suited to the task, but that to study this episode, it's important to at least consider three key features that we're going to focus on. Now, the first of those features is incomplete markets and household heterogeneity. This is important both because of the targeted nature of the fiscal response and because redistribution will turn out to be an essential element of the welfare considerations. It's also important because a failure of Ricardian equivalence lies at the heart of comparing alternative fiscal responses. The second feature is a model of nominal rigidity that allows for state dependence in the frequency of price adjustment. During the inflation surge, the frequency of price adjustment roughly doubled. With large shocks, pricing dynamics matter for the degree of nominal non-neutrality and hence the implicit trade-offs involved with policy interventions, and we want to understand the extent to which these are important in studying this episode. And the third feature is a serious consideration of the way in which fiscal stimulus is funded, in terms of if, when, and by whom new debt is repaid, and in particular, allowing for the possibility that some or all, perhaps, of the borrowing is paid for with inflation rather than higher future surpluses. And so in this paper, we study a model with these features. We're going to use it to recover a series of shocks to match the data on output and inflation over this period and policy variables at the same time. And we're going to take seriously the information structure of both the shocks and the policies. And then what we'll do is use it to perform a series of counterfactual exercises to answer these questions. So let me explain the model, the way we do the exercise, and then I will answer these three questions in turn. So the model is a continuous time one asset Hank model. Households receive idiosyncratic productivity shocks. They choose how many hours to work, how much to consume, and how much to save in a risk-free nominal asset, and we don't allow borrowing. Production follows a standard New Keynesian structure. There's a competitive intermediate goods firm that produce with a constant returns to scale production function that uses labor and then final goods as materials as inputs, and we allow for trend productivity growth. Monopolistically competitive retailers then differentiate intermediate goods into varieties, and they set prices and sell to a competitive final goods firm that aggregates using a standard CES demand structure. Now, retailers in our model will face price adjustment costs, and I'm not going to go into detail about our model of pricing, and I'll refer those who are interested in those details to the paper. It's a model that allows for an endogenous frequency of price adjustment, and we design it so that it matches and calibrates to the data on both the frequency and distribution of price changes in the steady state, both in normal times and during the 2022 inflation surge. And we think that this model of pricing is of independent interest for those who are interested in thinking about models of price adjustment. Now, the steady state tax and transfer system consists of a proportional tax and lump sum transfer, and the government also spends on government consumption. The government issues long-term nominal debt with exponentially declining coupons, and we set these so that the duration is on average 5 years. We calibrate the model so that in steady state, the government runs a primary deficit of 2.2%, as in the pre-pandemic data. And this persistent deficit is sustained by a real rate that's below the growth rate of the economy. Monetary policy is conducted by movements in the nominal interest rate, and I'll explain the way in which we conduct that. The equilibrium of the model requires two market clearing conditions, the labor market and asset market. And in this economy, the only traded asset is government debt, which is directly held by domestic households. So it's a very simple model in that sense. Okay, let me describe our exercise. So starting in the second quarter of 2020, the economy is hit with a series of unexpected shocks. These are so-called MIT shocks, in the sense that in steady state, they are zero probability events. There are two types of shocks, one on the demand side and one on the supply side of the economy. We model the demand shocks as a common shock to households' utility of consumption, which we intend to capture difficulties that households and desire that households had to spend during the pandemic. And we model supply shocks as a productivity shock in the intermediate goods sector, which is intended to capture the effects of disruptions to supply chains and other supply side effects of the pandemic and war that would manifest this way in more richer models. Shocks will arrive at the beginning of each quarter, and we assume that they are expected to persist and do persist with a constant decay rate that we set so that's equivalent to a quarterly AR1 with a coefficient of 0.95. Okay, fiscal policy. So the fiscal response to the shock consists of multiple rounds of three types of stimulus. First, targeted transfers, which we model as uniform transfers to the bottom half of the wealth distribution. Second, government spending, which we assume is unvalued. And finally, firm subsidies, which we model as lump sum profit subsidies to firms, which then flow through to households according to our assumed dividend distribution rule. We choose the magnitude of each component to match exactly the path of government outlays in the data for each category, which you can see in this figure expressed as a fraction of GDP. Each round of stimulus is announced at the beginning of each quarter. It is unanticipated and is paid out uniformly through that quarter. Our baseline financing assumption is that households believe that the stimulus will be unfunded, in the sense that there is no commitment to repay the additional debt that's taken on by lowering future primary deficits or raising future primary surpluses. We model the monetary response by directly imposing the path of realized nominal rates in the data, shown by the black line in the figure in the right panel, together with an assumed path of future rates at each quarter, which we take to be the median forecasts from the FOMC's summary of economic projections, with one adjustment, which is that we adjust the long-run forecast so that it's consistent with the model's steady state. Okay, now conditional on these assumptions about the fiscal and monetary response, we then choose the realizations of those two shocks to match exactly the paths of output and inflation in the data. So this is effectively a non-linear inversion exercise, and so by construction, the model will reproduce the data over this period exactly. Now, the implied inflation forecasts within the model, and that's shown in the left panel, look quite similar to the inflation expectation series produced by the Cleveland Fed, that's in the right panel, which is in part why we're comfortable with our exogenous assumption of a quarterly persistence for the shocks of 0.95. In the paper, we provide versions of all the exercises under assumed faster and slower decay rates, and the analogous figures look a much worse fit than this one. Here are the estimated shock series and implied forecasts for those shock realizations. The model infers a very large demand shock early in the pandemic, which reflects lockdowns and isolations, which then recovered more quickly than initially forecasted. The model infers a productivity increase at the start of the pandemic. This is consistent with the behavior of measured productivity over this period in the data, although in reality this was due to composition effects in the labor market, which are absent in our model, so our model will interpret these through the lens as a direct effect on realized productivity. But then there's a steep decline in productivity in 2021, consistent with the time when supply chains became disrupted in the economy. Okay, question number one. How would the economy have evolved without the policy responses? So the red dashed line in these figures shows the counterfactual evolution of GDP in the left panel, inflation in the right panel, and the price level relative to trend if there had been no fiscal stimulus programs and if the Fed had held the Fed funds rate constant throughout the period. What you can see in the figures is that without the policy interventions, output and inflation would have been much more volatile. In this sense, the combined policy response was successful in terms of aggregate stabilization. In 2020 quarter two, GDP would have fallen by 15% rather than 10% and would have been slower to recover. The deflation at the height of the pandemic would have also been much more severe, and inflation would have peaked above 10% and come down more slowly than it did in reality. On the other hand, without the policy interventions, we would not have seen the lingering effects on prices that we do today. Inflation would have returned to target by 2024, and today the price level would be back at its pre-pandemic trend rather than 17% above trend. Okay, what were the roles of monetary and fiscal policy individually in contributing to these responses? So let's start with fiscal stimulus. The orange line shows the effect of the fiscal stimulus, assuming that the Fed had held the policy rate constant throughout, so only a fiscal response. What these figures reveal is that the fiscal stimulus packages were by far the dominant force in supporting output and preventing deflation early on. The costs of this stabilization were primarily a permanently higher price level that you can see in the right panel, but also implicit redistribution, which I'll come back to. You can't see here. Note that the fiscal stimulus packages brought forward the inflation surge by a few quarters, and they amplified it a little. But they did not cause it, in the sense that inflation would have peaked above 10% even without the fiscal response. So there is a sense in which both sides of the inflation debate were right. The inflation surge was due to real disturbances and not fiscal policy, but the unfunded stimulus is the reason why the price level is permanently higher today. Without it, the increases in prices would have been temporary. Okay, what role did monetary policy play? The initial cut in rates, in fact, did very little in supporting output, and it did contribute a small amount to preventing deflation in 2020. Rather, the main effects of the interest rate movements were in successfully smoothing out the dynamics of inflation over this period. This happened via the stepping on a rake mechanism. By lowering the value of government debt, the hike in rates reduced inflation by 4 to 5 percentage points in 2021, 2022, but at the cost of weaker recovery, 1 to 2 percentage points of persistently higher above target inflation, and a permanently higher price level. Question 2. What if we had made different policy choices? So let's start with fiscal stimulus. A natural counterfactual to consider is to ask how different things would have been if the Treasury had committed to pay for the stimulus packages by raising future primary surpluses. So to implement this, we assume that this repayment will begin in 2030, and it will happen through a reduction in lump sum transfers that slowly repays the additional debt according to a standard exponential rule. In the paper, we also consider alternative repayment policies, including using higher taxes to pay for the additional spending. To isolate the role of fiscal policy in this experiment, we assume that the interest rate and guidance remain as in the baseline, although I'm sure that different people will have different views about what the right or what the counterfactual monetary policy they would like to see in this scenario would be. There's no right way to do this, but if you have a very strong view, just send me an email and I'll run it. The counterfactual is shown in the green line. It reveals that the failure of Ricardian equivalence is strong. Recall that in an otherwise identical representative agent model, a funded stimulus package like this would have no effect on the economy at all. But instead, we find that a commitment to pay for the stimulus would have been almost as effective at aggregate stabilization as the unfunded stimulus, but with a stronger recovery, with lower inflation throughout, and no permanent effect on the price level. So where's the difference? The difference between the funded and the unfunded stimulus is primarily in terms of who bears the cost and how, and which I'll come to in a minute. Another commonly discussed counterfactual is what if we had not implemented the later Biden-era rounds of stimulus? And you can glance the results here. I refer those who are interested to read the paper. Moving to monetary policy, perhaps the most relevant counterfactual here is to ask what would have happened if the Fed had responded earlier to the interest rate surge and started hiking rates sooner. So we implement this by assuming that the full path of rate hikes and guidance is brought forward by a year and then held at their peak for a year longer than as in the data. The right panel shows, that's the one with inflation, that contrary to much speculation, an earlier rate hike would not have lowered the peak inflation and actually would have been worse at smoothing inflation. This is consistent with the stepping on a rate mechanism that underlies the smoothing of inflation in this model. In the absence of a promised fiscal contraction, all that interest rate policy can do is to smooth the effects of inflation. And since the mechanism acts by lowering the price of long-term debt, it pays to time the hike to coincide with inflation nearing its peak. Question 3. What were the welfare effects of these policy interventions? So we measure welfare as equivalent variation in terms of asset transfers. This answers the question, in the absence of the policy, how much would you have to give to each household at the start of the pandemic to make them indifferent about whether the policy was implemented, conditional on the realized paths of aggregate variables with and without the policy? The black line in this figure shows the average value of the policy intervention for households at each percentile in the pre-pandemic wealth distribution. The bottom 75% of households you can see benefited from the policy with an average asset equivalent variation of $20,000. The policies were costly for the top quarter of households, and thus they entailed a large amount of redistribution. This redistribution was due primarily to the unfunded fiscal stimulus, which was essentially a transfer to households in the bottom of the wealth distribution, paid for by high wealth households through lower real returns from the higher expected inflation that arises. A simple average across the distribution yields an average welfare gain of $9,000, and so on the face of it, it seems like the policy interventions were an overwhelming success. However, an important caveat is needed in this interpretation. So while the policy interventions did indeed play an important stabilization role, that's not where these welfare gains come from. Rather, the welfare gains arise from redistribution in the face of incomplete markets, and those welfare implications exist even in the absence of the large pandemic shocks. To illustrate this, this figure shows the welfare effect of the monetary intervention in red and in the fiscal intervention in blue in the baseline experiment and in an artificial experiment without the pandemic shocks. You see that they're almost identical. Thus, if one were in favor of these large interventions in response to the pandemic, one should perhaps also support them in normal times, but of course that would raise a whole host of issues that are not in the scope of this analysis. Finally, could we have done better? So we already saw that a commitment to pay for the stimulus programs with lower future transfers could have achieved very similar aggregate outcomes with aggregate dynamics. But the right panel shows that the welfare implications of such a policy would actually be very different. You would see slightly smaller welfare gains in the bottom half of the distribution, and now you would see welfare gains in the top part of the distribution as well. So relative to the unfunded stimulus, this is kind of close to a Pareto improvement. So to conclude, we've built a model that combines heterogeneous agents, state-dependent pricing, and unfunded fiscal stimulus, and we've used it to study the effect of counterfactual fiscal and monetary interventions over the COVID era. We found that monetary and fiscal interventions were very effective at stabilizing aggregate output and inflation, but that this stabilization came at the cost of persistently above trend inflation and permanently higher prices. While there were large average net welfare gains, those gains arise from completing markets and redistribution, not from the policy's aggregate effects on aggregate dynamics. Because departures from Ricardian equivalence are large, a commitment to repay the stimulus packages with lower future deficits could have achieved similar short-term effects on inflation and output, with much smaller long-term increase in the price level and more broadly shared welfare gains. And because monetary policy work through stepping on a rake effects, an earlier rate hike would not have prevented the surge in inflation. Finally, although our state-dependent pricing model matches well the increase in the frequency of price adjustments over this period, which is something that almost all existing models have struggled with, it turns out that none of our conclusions about the effect of policy in this period are sensitive to the model of pricing. In fact, similar counterfactuals obtain in a Calvo model. The reason is that given the shocks that we recover through our estimation process, real marginal costs move only by around 5%, which is not enough to hit the very non-linear parts of the Phillips curve. But of course, no one could have known that without doing the analysis. On the other hand, allowing for heterogeneous agents and incomplete markets and using nonlinear solution methods for the estimation process turns out to matter a lot for these findings. Thank you.
The discussion is limited stuff.
All right, great. Thank you very much for inviting me to discuss this wonderful paper. The title in this case is very representative of the list of results in the paper because both are very long. So I had to pick and choose what I want to focus on, and I'll tell you what I focused on. And that was, to me, the most important question that this paper tackles, and that is the question of what drove the COVID inflation. And there are as many stories as there are economists, and this paper mostly focuses on the role of fiscal and monetary policy. Now, this is not the first paper that has thought about the COVID inflation. There's lots of papers, even papers with Hank models, like early papers like Beyer, Byrne, Lüdecke, and Muller. 3 of my students in the room wrote a paper on this as well. So there's a lot of work in this space, but where I think this paper comes in and distinguishes itself from everything else, it is that it puts state-of-the-art tools on the table for both the demand and the supply side of the economy. So it gets all the nonlinearities right that I think other papers didn't really focus on. So on the demand side, we have a heterogeneous agent household side, and on the supply side, we have a rich menu cost price setting model. And on top of everything, we use the FTPL framework, okay? I think this is great. I think we need more papers that accumulate all the pieces that we have, all the machinery that we've developed to tackle big questions, to see where are we missing, what are we getting right, what are the actual sort of practical quantitative answers. And I think this paper is really great in that regard. Now, what is the punchline for this question? Sort of what drove the COVID inflation? Was fiscal policy to blame? Just going to give you a quick sketch. I didn't find like a super clean plot in the paper, so this is my sketch. This is what happened to the data. Inflation went up, and this paper says without fiscal stimulus, we would have seen stronger deflation, but the peak inflation wouldn't have been that different. Okay? Great. So here's what I'm going to do in my discussion. I'm going to start by just asking how important are these nonlinearities. Greg already mentioned that some maybe are more important than others. Then I'm going to discuss the role of FTPL and a broader question on determinacy. That second part will be very nerdy. And then I'll be jumping into sort of a broad interpretation of these results. Okay?
So role of nonlinearities first. And it turns out that the two sides, the demand, the supply side, they're kind of battling it out a little bit in the paper, okay? There's a concave demand side that kind of fights with a convex supply curve. And that wasn't kind of obvious to me exactly how that checks out. So let me just walk you through how this works in like the simplest possible setting, ASAD. Okay, you've all seen these plots, output, inflation, aggregate supply, aggregate demand. This is what it typically looks like. If I want to feed in fiscal policy, say a small shock or a large shock, I move out the aggregate demand curve. Now this is with an active Taylor rule, which means that AD curve is actually downward sloping because higher inflation means higher real rate means less demand. Something that Adrian and I like to do in our papers is we just like to start with the real interest rate, and this came up in the earlier talk as well. Then it would be vertical because then the real rate doesn't move when inflation moves. But with FDPL, it turns out it leans a little bit to the right. Why? Because higher inflation with a fixed nominal rate means lower real rates, and so stimulates more demand. So if I just took a standard sort of FDPL-like perspective on the world, everything linear, then I would be in this kind of an intersection after a large fiscal stimulus. Now, what if I have a convex supply curve? Then, well, this AS curve will bend up, so I will get more inflation. So the convex supply curve will mean more inflation. But if I, in addition, say, well, maybe the demand curve is concave, so the response to that second transfer, the larger transfer, is closer to that of the smaller transfer, I'm going to get lower inflation again. Okay, it's kind of move in opposite directions. Now, obviously the paper is not happy with an ASAD curve. Greg writes quantitatively serious papers, but it turns out even his paper roughly breaks down to an AS and an AD side block, and they're linked not by scalars like scalar inflation and scalar output, but by sequences of inflation and sequences of output. Let me just briefly show you what this model is. It's a very complicated model. I hope you realized that already during Greg's talk. Here you see it again. How does this work? On the demand side, we have that inflation moves real rates, affects how households spend. That spending has sort of a Keynesian cross feedback with output. And once you figure that output, you see that drives real rates. That drives nominal marginal cost, which feeds into prices. But then there's this feedback loop back into nominal marginal cost for any given real marginal cost, right? And then at the end of the day, the cycle on the left here determines the price level that determines inflation, and we're back, okay? This is how the economy works here. It's a more complicated version of ASAD in some sense. It uses state-of-the-art tools on both sides. It has a state-of-the-art menu cost model. I couldn't have come up with a better one. Smooth adjustment hazard, trend inflation, a nonlinear CS objective, and on the household side, state-of-the-art heterogeneous agents, match MPCs, government debt, distributional moments, all of the above. Okay? I tried to replicate this as best I could. I think I did a fairly good job, kind of matches the results. So I'm going to show you some simulations from the paper and some simulations from what I replicated. So the first thing the paper does, Greg didn't even talk about it. The paper is a book. This has tons of results. The first thing they talk about is, how does the size matter? Because it's a big nonlinear model. They feed in a 15% of steady state debt one-time lump sum transfer. Turns out if you kind of read, you can actually learn how nonlinear the model is by comparing across plots here. It's a little complicated, so I'm going to show you a simple plot in a second. Also, this is a huge shock. I'm going to throttle it down a little bit in a second. But if I stick with that 15% plot, this is what you get. Gray is the linear baseline, blue is the fully nonlinear model. Turns out the inflation response is somewhat similar, kind of exactly this idea of the nonlinearity that this paper brings to the table, kind of pushing in opposite directions. But it turns out that for real GDP, the nonlinear model gives you significantly less effect from fiscal stimulus than a linear one. If I added my pure convex supply curve, but linear demand curve side to it, you see that you would get additional inflation from that, just like in the sort of ASAD logic. But when you look at actually a more reasonably sized shock, it turns out that they're fairly close to the linear responses again. Okay? Now the paper does a whole COVID quantitative experiment that Greg spent almost his entire talk on. I thought that was very impressive, by the way, just the way they did it. It's not a Bayesian, estimation, but they actually go in, try to be serious about forecasts at every point in time, backing out what shocks were driving the economy. I tried to replicate all of that, but I just did it with linear inversion, and you see it kind of lines up. And non-linearly, when you switch on the non-linearity, it looks very similar. So that made me think, okay, maybe the non-linearity isn't that important for the results. Maybe you could have almost done it with a linear shock. And if you just look at the effect of fiscal policy during the COVID episode alone, you see that you do get a sizable response of inflation, but it's kind of similar between the nonlinear and the linear model. So all of this made me think that the nonlinearity is important for some things. You see on the right for real GDP, it turns out a little bit more important, but I think the paper could do a little more just explaining why do we go through all this work to do everything with large shocks in the truly nonlinear model relative to sort of a much sort of simpler exercise where you assume sort of linear linear demand side and a linear supply side. Okay, let me go and talk about FTPL and determinacy. So you hopefully got the idea that this paper is a bit of a beast, and I spent a lot of time over the last 48 hours with this paper, and when you're there, coding along at night, you have random associations. So one association I had while I was thinking about this paper was of a famous movie, this one. I don't know why nobody ever came up with this. It even says, I didn't change this on the poster, a monster science created but could not destroy. I obviously like Hank models, but okay. But so let me kind of poke a little bit in the model and just shed some light on the different pieces. It's very rich. There's a lot of things going on under the hood, and I want to just show you all the stuff or some of the stuff that is happening. So here's a fun thing you can do. So I recently came across a really nice paper that has some authors that are in the room, I think. Price level inflation dynamics in heterogeneous Asian economies. I look at it, and it has this nice plot that says, if you are in a world where real rates relative to growth rates are low, so this R is negative, then you need to make sure that you're in the right steady state in an FTPL world. I tried to do that here. Greg probably knows the answer. I tried to do that here. I ended up in the wrong point. I don't think really that's a problem deep down, but I think that'd be worth looking into. And then a super nerdy point that just kept bugging me about the supply side. So here's something that happens under the hood, which is that if you look at the pricing problem under the hood, which is a menu cost model that has firms that have price gaps, and there's a flow profit function that is coming from the CS demand that these firms face, and they want to kind of maximize it, but because of price rigidities, they can't always be at the maximum. But it turns out that this flow profit function is relatively curved towards the left, and it turns out something that can happen here, I did not know this, but I think it's very interesting. Something that can happen here is that these firms on the left, they become very nervous about price increases, marginal cost increases, because they worry that they're going to be in this region where they actually make losses, because they keep it's a random menu cost model, and if you don't get the lower menu cost, you don't have an easy time adjusting. And it turns out that makes them very forward-looking. And you can verify this by just feeding in one-time surprises in anticipated future marginal cost and see how they respond. They tend to increase prices much faster and much further in anticipation than if you, say, had a quadratic objective. Now, why is this relevant? I think that there's something interesting that can happen here in this world that wouldn't happen with a quadratic objective. So I kind of tried to come up with a simple analogy. So let me show you one. So if you all have seen this model, this is a Calvo model. Now assume we do the following thing. We assume that the discount factor in the Calvo model, assume it's bigger than 1, but lower than 1 over theta, which is the persistence of prices in that model. This is still well defined. This is the formulation for the reset price. This is still well defined. This is the how the price level depends on past reset prices. And you get the standard New Keynesian-Phillips curve, except that with beta bigger than 1, there's some degree of indeterminacy here, where now you can have sort of self-sustaining paths of inflation. And I checked a lot of things. I made sure that the pricing model that I wrote kind of matches the same moments, looks the same, and I came up with a conclusion that I think this pricing site also gives rise to some self-sustaining paths in inflation. And so for a given, I think, path of output or real marginal cost, I think there is a degree of indeterminacy here. Now, I don't think this is a problem for the paper because, so here's how this works. There's a cycle here, right, between prices and nominal marginal cost that can give you, for any given series of output, it can give you infinitely many solutions for inflation. But I don't think the paper itself, you know, does anything wrong, because I think the way the model would deal with this is it would say, well, it's the government that picks the, you know, ultimate price level and hence eliminates that degree of indeterminacy. Okay, so it's ultimately I think a different way FTPL comes in relative to sort of a more standard way that picks and kills that degree of indeterminacy. Okay, so I found that a little bit unconventional. I checked the overall determinacy of the model. I think that all checks out because of FTPL. I think it really helps there. But I would be interested in kind of the authors exploring some other calibration of the menu cost model, seeing if probably results, I mean, they all are very intuitive. Probably results go through even without this feature, but it's something that stuck out at me when I was thinking about it. Okay. On the interpretation of results, my third point. So I think there's somewhat, you know, a strange behavior of TFP. And Greg, I think, did a good job kind of explaining what could happen here. This is productivity. And you see what the productivity shocks do for inflation. You see initially, they cause deflation as productivity goes up, costs go down. And then they cause inflation. And fiscal policy is very front-loaded. And the way this works under the hood is that productivity shocks help you match the inflation response. And I think actually, I'm not sure that, you know, if you, it almost looks like to me as if these productivity shocks kind of, you know, help you with allocating the inflation that fiscal policy generates quickly towards a later period. It's almost like, you know, if you had inertia in the Phillips curve, it would almost be like that fiscal policy generates later inflation rather than it generating fast inflation that you then undo with productivity shocks only for them to reappear later. Okay, so I asked myself this question, is TFP simply pushing back the fiscal inflation surge? And if you ask me, I think that might be happening, and that'd be very interesting because that might change a little bit how we interpret, you know, how important fiscal policy was for inflation. I could even think that inflation accounts for a lot larger share, even for, at the peak of inflation. So I think that'd be very interesting. I mean, Greg showed this. I thought that was really striking, how much fiscal policy increased the overall price level at the end of the day. So cumulatively, inflation did rise a lot because of fiscal policy. It's just that the timing was a little bit off relative to what we saw in the data, and kind of productivity shocks in my reading were kind of bridging that gap. But I think maybe by, you know, adding some inertia or something like that to the Phillips curve, right, maybe we can make the timing line up a little better. And there's some ideas there. There's many ways to try to do it, but I thought that could be really cool because then you can almost, you know, explain maybe a much bigger share of inflation, not just overall in terms of price levels, but even in terms of the timing with fiscal policy. Okay, let me conclude. I think this paper tackles one of the most important questions that we face in macro today. And it does a lot more than that, by the way. I mean, you saw it in Greg's presentation. There's a whole host of things that you can do once you have that kind of a framework. I just zeroed in on one particular question the paper's asking, namely how responsible fiscal policy was for the COVID inflation surge. I think this paper is the first one I know that actually brings the state-of-the-art tools to the table to tackle this question. I think that makes it a very important paper. I would even go so far as saying that is the key reference paper on this question going forward. So I'm very bullish on the paper. I have 3 ideas for further improvement here. Better explain the role of nonlinearity, try alternative supply sides, and embrace this idea that fiscal policy maybe, if you account for the timing differences, actually was very, very important for cumulative inflation. And I think that's, and maybe pick a shorter title. All right, thank you so much.
Do we have any questions? Mark?
I'll start out with one. I agree with what Ludwig said. It really is amazing paper. But to clarify some of the issues he raised about what's driving inflation, it might be useful to see a plot of inflation and marginal cost.
Yeah.
See if we can make sense of that. And we might be able to see a nonlinearity there as well. The other observation is on the TFP shock in the intermediate goods sector. I think in terms of the data, where you might see it is in the price of intermediate goods.
Yeah.
That is, the period where you have this TFP shock, I think, is exactly the period where you see a big jump in the price of intermediate goods.
Yeah, so we've looked at the using wholesale price index data, and in earlier versions of it, we calibrated to that. In the end, we want to. We've looked at trying to match labor productivity data directly and bringing in a third shock. That's something that we're thinking about at the moment as well, which is another. Because even though that pattern of productivity matches the pattern of measured labor productivity, the increase that we get in those shocks is bigger than what you see in the data. Yeah.
So if I understood in terms of the welfare conclusions, Greg, you showed that if there's a funded fiscal policy, the really big difference is whether the price level reverts back versus if the price level has a persistent impact.
Yep.
So when we talk about welfare, let's actually forget about whether this is through the FTPL, through monetary policies, or through another mechanism, because ultimately what agents cares about the outcomes. Then you would say that in terms of whether it's a target I give to the monetary authority, the fiscal authority, again, I don't think that's really the important thing, is that we should be doing price level targeting instead of inflation targeting. That will lead to much higher welfare benefits. Even that Pareto optimality almost result that you have. Which then leads to the question of, or the puzzle of, for some reason, not just central banks, but everywhere, we do this inflation targeting. If Jay Powell or fiscal authority or not would have led to a period of deflation right now, you would have seen, oh, this is a big failure. You get all of these compliments on the fact that inflation is smoothing to 2% from above. So what do you think is it that in the model, I think I know the answer there, but in the model that we really like deflation after a big period of inflation, so persistent deflation, in terms of the welfare calculations. But in the world, there's a huge amount of resistance. It's usually the arguments have to do with zero war bounds and things, which are really not relevant here. So why is it that you want the price level to go back? For welfare, I'm asking you questions about the welfare.
Yeah. Okay, so let me address 2 parts of that question, because one I think is a precursor to other things. FTPL has nothing to do with these results, okay? That's just wrong, has nothing to do with it. The estimation process, you can choose whatever combination of monetary policy, fiscal policy you want. The numbers that pop out on my screen will be mathematically identical, okay? It's just completely irrelevant. There's observational equivalence. We are reading off the data and inferring we'd get exactly the same shocks, okay? The only thing it matters for, and I wouldn't even say it matters, is when you do the counterfactuals, what do the paths of nominal rates look like when you do a fiscal policy? It's even got nothing to do with rules. You tell me what path you want, the realized path you want, you can implement it however you want. Fiscal theory, Taylor rule, doesn't matter, you'll get the same. So that was my throwaway comment, is you tell me what you want. Okay. Conditional on that, I think what's going on is it really in the welfare really depends on what you mean by the word good. Okay, because it's really just about redistribution. The only difference between the 2 policies, well, in the welfare side, was ultimately how is the cost of that getting money to the bottom half of the distribution early on, how is that paid for? There's 2 different views on it. In the one case, it's paid for by lower real returns on the people who own assets, and the other case it's paid for by uniform lump sum transfers. Now, there is an important question there which I don't know the answer to, but we should look at, which is, well, given that the big difference is which group is paying for it, in the one case it's the only people with high wealth, in the other case it's everyone, you might ask, well, what about for the people with high wealth? What if you gave them the option is you can pay for it with higher inflation, or how about you guys just pay with higher taxes or lower transfers? And maybe that kind of gets at the answer. I don't know the answer to that. But the answer is it's a distributional question.
Let me give you a slightly different narrative what happened for the last 20 years, and maybe you can try to model should be easy. So we went through the financial crisis. I think it's fair to say it was more persistent than we expected. It was struggle to put a stimulus package of $100 billion. It went on and on. And then the pandemic came, and I was actually flabbergasted how quickly they came together with all this stuff, all this money there. I think in the background they had in mind, this happened before, we hesitated, and now we're going to go in very quick time. Then the vaccine came, and you show this thing came down, and you keep the 0.95. So I think you discipline that persistence through inflation expectation.
The persistence is on the demand and the supply shocks, right. not the policy variables.
Right, on the demand and supply shocks, right, that's what I'm saying. So you thought that the pandemic would last long, then it's stimulated because of that, and then actually it went away, okay, which we saw unemployment came down very quickly, so things normalized pretty quickly. Of course, it could be the stimulus, so it's not easy to decompose the two. The question is, naturally, after I see this going away, I would expect 0.95 to become lower.
But it's not 0.9. Sorry, to be clear,
like you could. There were two big episodes with uncertain persistence. The first one, the financial crisis, had higher persistence than expected, okay? And now we have one. I think it's fair to say had lower persistence than expected, at least in terms of shock. The pandemic went away, I think, faster than because of the vaccine. After that happened, you would expect the 0.95 to become lower, which is something you can easily do in a model. So after this comes down, let's say you change the 0.95 to something lower, okay, the shock itself, which will change the results. And then you ask what happened there.
Yeah.
Again, it's not easy to see from the data because partly it's a stimulus package. Now you did discipline things, I guess the persistence through the inflation, I think so, forecast. So I was actually surprised you got it right, because I thought the Fed was getting all this wrong. So maybe that path of inflation forecast was right for the wrong reasons, like different things. So maybe you can look at other forecasts to display what people expected the persistence of this to be. I would expect that there was a lot of expectation of persistence after the structure, and then it came down.
Yeah, I mean,
that's why I think we spent all this money. If we had known that this would last a year and a half, I think we would have not spent all this money.
Yeah.
That's going to be my narrative. And I think it's easy to track in your model if you change the 0.95 as a function of the level of the shock.
Yeah, we can do that. We can study that. Good.
So do you know the dynamics of wages in your model? I think that's useful for two purposes. One is it helps discipline the productivity shock a bit more, and also I think we can talk about like the wage price spiral and real wage in the inflation dynamics.
Yeah. Yes. We have labor productivity, real wages, real marginal costs. They all sort of move the same in a simple model like this. And it's kind of the answer to Mark's question. They follow something that looks not so different to the productivity data. The data looks kind of similar to that as well, to different degrees, give or take. And we could discipline it directly. I mean, one of the things that we are working on now is adding a third shock, which is some sort of shock to the pricing problem, which would play the role of, I guess, what people in the New Keynesian literature call a cost push shock, and put a third series in there to match that. Look, we can do. I suspect that for the big picture counterfactual claims I make, that ain't going to make a difference for that, because it's not driven by that. But I agree with you that is something where we're looking into. Maybe we should take it more seriously though.
So I'm with Ludwig. I think this is a really important, really beautiful paper. One observation, largely rhetorical, you want to say something about it, and the other, which will give you an opportunity to respond to Ludwig. So the rhetorical observation is, it's just obvious when you look at the data that the U.S. fiscal policy over the last 25 years has been very different from what it used to be. We have entered what I have called the age of irresponsibility. everybody can run whatever deficits they want, and nobody's going to do anything about fiscal policy in the future. And what your paper tells me is, what are the consequences of that kind of irresponsible behavior? We end up with the disastrous political consequences that we're all living with nowadays, because the price level went up so much. Quite apart from that, I was interested in how you want to think about the indeterminacy. I know you said that none of this fiscal period price level, none of that stuff matters, but it might matter in a different sense, that sometimes the solution method we use to solve for equilibria, for example, you take write down a model with indeterminacy, but if you restrict yourself to a certain class of Markov equilibria, you end up with a particular equilibrium outcome. So a different way of phrasing Ludwig's question is, do you know if there are other equilibria in your model, and if the particular solution method has pushed you towards a particular equilibrium, or you think that's all irrelevant once you get to fit everything, it only matters for counterfactuals and so on?
Okay, so thanks. So Ludwig raised some things a couple of things that I had not considered. So let me start with the easy one. Steady state, yeah, it is true. In steady state, you get to. I'm pretty sure that we're on the other one because I've checked, but I'll go check again. So I'm not worried about the steady state. The pricing thing that Ludwig mentioned, that's not something I'd ever thought about. So I'll go away and think about whether the pricing model generates some other form of indeterminacy. I suspect not. Again, like we've done everything Kelvo does, gives you the same sort of results roughly. So I'm not. You're more interested in the fiscal theory side of it, but I don't see any reason why there is any indeterminacy here. Remember, the exercise is I take inflation and interest rates and fiscal policy and output from the data, and then you're asking, are there more than one set of shocks that could recover that? I don't see any reason why, but I don't have a proof for the model, so yeah. It's not something that keeps me up at night, put it that way. I mean, but maybe it should, with the caveat to the thing that Ludwig pointed out about the pricing that I hadn't thought about. Christian.
I wanted to continue the discussion a little bit more, like I was shining through a bunch of the questions on the nature of the shocks, activity, what it looks like, and the persistence part. Because I think at least in the linear model, like an argument you can actually make precise is something you said in the reply before, that really it does not matter, conditional on you matching the forecasts, in which you've already kind of shown you do it. Like you're feeding in the forecast for the nominal rate, and then you're matching kind of at least one notion of forecasts for inflation and output. And you can kind of play around with those and see maybe there's heterogeneity in those forecasts in the data and how that's going to change your conclusions. But conditional on matching any of those, how exactly you generate those forecasts is not going to at least be a positive statement on what happened in a counterfactual fiscal monetary policy. It's not just not going to play a role.
Yeah, so let me just play that back, because if I had what I thought was reliable data on forecasts of output inflation at every point in time, we could recover not just a shock but a whole sequence at every point in time. Now that seems really hard, certainly in the non-linear case. Probably in the linear one you could do it. We've got one series on the Cleveland Fed. I feel pretty comfortable on their inflation expectations. I couldn't find stuff that I felt reliable on GDP, but maybe you can send me some forecasts on GDP. We can do that. And yeah, but then that's why we went with the 0.95, which is we did a little bit, let's say, informally. And I know on that previous comment you've given me is to try hump shape dynamics, and that's still on the to-do list. We haven't done that.
This looks like you need a very state-of-the-art paper, except perhaps for the welfare function.
Okay.
It seems you did just like a utilitarian welfare or something like that. It was not very clear.
No, I never aggregated. I just showed it to you for each individual person. I never controlled.
$9,000.
Yeah, I said if you do that's a simple average as a sort of That was just add them up.
Oh, it's the average.
It was just the average number across people. Yeah.
Oh, okay. But not weighting by anything.
No weighting by anything. Yeah, you get an even bigger number if you weighted toward more at the bottom. You'd get an even bigger number. I was trying to be conservative with that.
You said it's mostly about redistribution.
Yeah.
Can you clarify?
Yeah. So what happens is that you've got the bottom 75% of people have a positive welfare effect and the top 25% have a negative. For the bottom 50%, it's roughly constant. On average, within a wealth percentile is roughly $20,000. If I were to add up across everyone, just like the total amount of money that I would need to compensate everybody in the economy, it's like an average of $9,000 per household. But there's a lot of redistribution underlying that because it's a big negative number for people at the very top and a positive number for people at the bottom. If you were to put more weight on people on the bottom because they're the positive ones, you get a number that's bigger than $9,000. So then I'm saying, well, it sounds like that's a really good idea, but I'm saying if you were to do the same policies starting in steady state, so no COVID shocks, you would get the same thing. So I mean, there's a caveat here, which is probably, I'm surprised no one's pointed it out to me, which is this is not a state-of-the-art model in many, many reasons. In particular, aggregate shocks don't change the nature of idiosyncratic risk in this economy. So if you think that people would have been less likely to have bad individual outcomes if we didn't have the COVID, that would generate some interaction. We don't have that in the model, so that's one area where, but conditional on that, yeah, it's coming from the redistribution. Thank you.
Good theoretical reasons to weight it by the inverse of natural reflection.
Yeah, I mean, I'm aware. You did a very good job. So I'm trying to.
I know.
It'll be like already more than $100,000. It'll be a huge.
It'll be a huge.
But again, nothing to do with the setup.
No, that's exactly right. No, that's right. But can we weight it by inverse of natural reflection?
Can I just check that I send you the right one?
Yeah.
So I'm getting more weight.
give to those guys, and we're going to use it to pay for it, but you only pay for it. I think that when you've got a perfect engineering, now I'm going to go crazy with the world and adjust for this section and that. Now let the rich guys who are really equity go around the bus. So that's where like they also like the fact that you're recovering one and that's why no, what he's doing now, I'm jumping that. As a referee now I take a little bit more stuff. Obviously biased, no, but it's a different question. No, it's a different question. No, and that's why I explained it in my question. Do we want to
Well, I was very happy to be on the program, so thank you for fighting. It's been a very fun paper to write.
Maybe we should have for some time. We've been going forward. Maybe the reason why I want that's a fun next page. You see what that's kind of what the guys that's fine. Not this paper, not the next
Yeah, that piece skips on that. So yeah, just thank you so much.
Okay, last but not least, we have past automation and future AI, how weak links tame the growth explosion by Chad Jones and Chris Benetti. I guess Chris will present the paper.
Thanks. This is a paper with Chad about automation, which is the process of replacing humans in the production technology. Automation's been going on for a long time. You can imagine in the agriculture sector, humans with hoes moving to horses with plows, to tractors that can now drive themselves with GPS automation. You can think about AI perhaps as the latest form of automation, where it's writing software instead of software engineers. In this paper, we asked two questions. First, looking backwards, how much of historical TFP growth was due to automation? We do this in a growth accounting framework using a simple task-based production model where we emphasize weak links and an elasticity of substitution across tasks less than one, the complements case. We use off-the-shelf BEA, BLS industry production data, plus one extra variable that requires some heroic measurement, the automation rate. And we find that about 2% of not yet automated tasks get automated each year in a cost share sense that I'll be more precise about, and we do that measurement using ChatGPT and Claude. Then, looking towards the future, we try to say, what's the future of automation and growth? We're going to think about growth rates, output, and labor shares, and capital shares. We take a task-based endogenous growth model, we calibrate it to our historical facts, so the future-looking and backward-looking parts of the paper are connected through that calibration, and we'll consider two possible futures. One in which AI is just a continuation of our past automation trends, and another more aggressive forecast of the future where we consider Moore's law everywhere, the advances that occurred in the computer sector applied to the aggregate economy. Before I move to the full model, I think it's useful to spend a little bit of time in a simple model where you can get a lot of the intuition. And so imagine that production requires the successful completion of a bunch of tasks. And if you fail at any of the tasks, you can have major impacts on the aggregate outcome. We can all think of examples where this is true. An analogy that Chad and I like to use is that a chain is only as strong as its weakest link. And to illustrate that, think about an example motivated by the harmonic mean, where inverse output is equal to 1 over x hard plus 1 over x easy, where these are the two tasks that need to be produced to get output y. Now, two things immediately pop out. First, infinite values for some inputs leaves the aggregate output finite. Indeed, the aggregate output is less than the smallest input. And that's the sense in which this analogy that a chain is only as strong as its weakest link pulls through. If you look quantitatively at the output associated with different input vectors, you can see that if there's some scarce input, the value of adding more and more of an abundant input falls off quite quickly. Indeed, you can even have infinite amounts of the easy input, and you don't get that much more than when you have 10 quantity of the easy input. What you really want to do is have more of the scarce input to increase aggregate output. Now, we're going to be working in a CES production technology world, and we're going to say that the production technology has weak links when its elasticity of substitution is less than 1. And so you should be thinking like Baumol-Cost disease logic is going to apply, where the scarce resource gets the returns. That might be useful for thinking about the labor share of income going forward. So now let's be a little bit more concrete using the CES model. Think about a set of tasks, like the set of tasks done by software today. And let's say S is that task share of total cost. If you have infinite amount of that task, that set of tasks, how much does that increase aggregate output? Well, there's a very simple formula that gives that to you. And in that harmonic mean analogy, where sigma is 0.5, you can see that if the software share, which today is about 2% of income, becomes infinitely supplied, you get about a 2% increase in GDP. And that's infinite production. So in some sense, you can say the AI technologists think that we're going to have amazing AI. That could be true, but that doesn't necessarily mean we're going to have huge amounts of the aggregate output. Now, you might say if we had infinitely productive software, it'd be doing more tasks than the tasks that it's doing today. Of course, that's what the paper's about, sort of the expansion of automation into new tasks. Going a little bit further using this simple model, on the horizontal axis we have the spending share of the tasks waiting to be automated, and on the vertical axis we have the factor increase in output once that spending share has been automated. And you can see, even going out to something like automating 50% of the current costs that we spend to produce with infinite productivity only gives us a 19% increase in aggregate output. So the two things I want you to take away from this simple model: one, it's very important how much you're automating, and two, this sigma parameter is how binding weak links are. That really determines how the quantity of tasks that you've automated turns into an aggregate effect. And we're going to use that logic through the whole complicated model. Before we go to the full model, let me quickly stop and think a little bit about data and weak links. So in your mind, I want you to think about what's happened to the factor income share that we pay to computers of the IT sector. On one hand, we have more compute than we ever could have imagined back in 1980. On the other hand, the prices have fallen dramatically per unit of compute. Which one wins? Well, it turns out in the early 90s, as computers were diffusing through the economy, there was a slight increase in the factor share of income. But for the past few decades, there's been a steady decline. And so the price has dominated the quantity, and that's exactly what you would expect from a Baumol cost disease logic of weak links. Sort of the scarce resource gets the returns, and we've made compute less scarce because the productivity gains in compute are radical. So now I'm going to go to our measurement framework, our full model. It should look very familiar to Pasquale because it's basically an off-the-shelf task-based model. We've got YIT tasks that are going to be combined in a CES fashion using sigma as the elasticity of substitution, and then there's this ZT, which is a factor-neutral productivity term. How are the tasks produced? Perfect substitute technology where you can use capital or labor to produce each task, and these psi-KITs and psi-LITs are the productivity of producing that particular task with that particular factor of production. In the first part of the paper with growth accounting, we're going to take these as exogenous and try to measure these, and in the future part of the paper, we're going to make these endogenous. So how do you decide which tasks get capital and which tasks gets labor? Think about a representative firm in a perfectly competitive sector. You use capital to produce task I whenever it's cost effective to produce it with capital. That's when its productivity relative to its cost is higher than the productivity of labor relative to the wage. And you can collect the set of tasks that are used using capital into psi-KT, the tasks that are using labor into psi-LT, and beta T is the measure of tasks that are using capital. That's a set of tasks that are automated. And I'd say relative to the literature and this growth accounting part of the paper, we're going to be very general in how these psi-KITs and psi-LITs are distributed, both at any given point in time and how they change over time. The psi-KTs and the psi-LTs are going to be cost share weighted averages of this task level growth, and so it's going to be these psi-KITs, psi-LITs, and that factor neutral term ZT that are going to be changing over time. Now, skipping over a lot of the derivations, some assumptions, some alternative results, you eventually get to this equation, which is the classic definition of TFP growth, where hat denotes growth variables. And it turns out in our microfounded model to be the sum of a capital productivity contribution, a labor productivity growth contribution, and an other productivity growth contribution. Where the factor shares denote the relative importance of the growth in capital productivity and labor productivity. You can rearrange that, simple algebra, to get a useful intuitive relationship where TFP growth can be equal to the baseline TFP growth rate that you get from this factor neutral term and from humans getting better at doing what they do, plus an automation boost. If machines get better at a faster rate than humans get better at producing, then you're going to have an extra boost to TFP because of that. And the SKT term, the capital share term, is saying how important is that extra boost you get from machines getting better. So that leaves us two key objects that we want to measure: the baseline TFP growth rate and the automation boost from machines getting better. So how do we do that? We're going to go to BEA, BLS, industry data. That's going to give us TFP. It's going to be traditional output labor productivity, Y over L. It's going to give us the shares. And now if you remember back to that simple model I told you about, there's two things that matter. How much are we automating? And then how binding are the weak links, turning that automation into increases in aggregate output. So sigma is going to determine how binding are the weak links. Now if you took our model, it has a CES-like representation into a CES model where capital and labor are the inputs. And this sigma would exactly be the elasticity of substitution between capital and labor if we held fixed the set of tasks that are automated. But the set of tasks that are automated can change when relative price changes. So the sigma is actually less than the estimated elasticities of substitution between capital and labor. So what we do is we go to the literature, people trying to estimate this elasticity of substitution between capital and labor. There's time series methods, there's cross-sectional methods. We went to a meta-analysis by Guitrit et al. That says 0.3 is a median estimate, and we know our number has to be below that, so we pick 0.2. Some of our results are sensitive to this 0.2, some of them are less sensitive, but I think by and large the literature agrees we're in the complements case, and sort of just how binding are the weak links. Second, we have to measure the automation rate. We say that the automation rate, more formally, is the share of total labor costs that are accounted for by the newly automated tasks just before they were automated. So it's sort of how much labor costs are you saving because of this automation. The way we proceed is we measure this automation rate using an LLM narrative history approach by task category and year. And so in a 20-minute talk, it's going to seem a bit mysterious. I'm happy to talk more about how we do this later. But essentially, we split up this continuum of goods into some discrete tasks, and then we go and ask the LLMs how much of these tasks in this year were automated, and then what were their cost share in each period. You put all of this together, and given this XT and the other data that I showed you and our pick of sigma, you can do a TFP growth decomposition into those two terms that we cared about. So on one hand, I'll acknowledge that using this LLM narrative history approach brings about concerns about validation. On the other hand, we have this alien superintelligence that's read every book ever written by humans. It seems weird not to try to use its knowledge to answer important questions. So one slide to pull together all of our growth accounting results. Where did historical TFP growth come from? The takeaway I want you to have is that machines improve much faster than humans. This psi kt hat minus psi lt hat is something like 3.8 percentage points per year in the aggregate. So think about how much better am I, Chris, at inverting matrices than my predecessor 50 years ago? Not that much better. How much better is my computer relative to the computers that existed decades ago? Much, much better. And that's a simple analogy. It's an anecdote. It turns out to be true across many, many sectors of the economy, also when you weight by the importance of the tasks that have been automated. And in other sectors, like agriculture or computers, you get even larger numbers. We measure the automation rate to be about 2% in aggregate, a little higher in agriculture. Computers is one of the sectors with the fastest rate of automation. We also find a related result that baseline TFP growth is usually close to zero. Now, this was surprising to us, but it's relatively direct to see what is it in the raw data that generates this result. So I have the equation here for what that baseline growth rate. Y hat t is just traditional labor productivity growth. Think of that as something like 2%. SLT is the growth rate of the labor share. That's roughly 0. XT is our measured automation rate. That's around 2%, and sigma is small. Well, that leaves something close to 0, and that means that if that's not contributing to TFP growth, then it's got to be this automation boost. The final thing I'll say on the historical part is that it's not enough to have capital growing rapidly. It needs to be capital productivity growing rapidly on an expanding set of tasks. And to make that point really clear, we do an example where we freeze automation. So fix the set of tasks that are being done with capital at their initial level in 1950, let's say. And then let capital productivity and labor productivity and this factor neutral productivity at the task level grow as we really did see it grow in the data. How much TFP would be lost because you didn't allow the now much more productive capital to start to be used on the tasks where it's productive? Well, in the aggregate, you lose almost all of TFP growth that we measured historically. In agriculture, half, and in computers, 1/4. So rapid machine productivity growth plus an expanding set of tasks that machines are used on is where historical TFP growth has come from. Now moving to the future, what's going to happen? So we have a dynamic model where we include automation of the idea production function. The model that we've talked about so far continues to apply, but now we add dynamics via the production of new ideas. Ideas are going to be produced. That idea growth is going to be what generates the growth in the capital and labor productivities of doing different tasks. And it's a lab equipment setup, so as we automate goods, we also automate ideas. We're going to calibrate the model to match the historical facts we've documented, and then think about the future. So here's the model in one slide. I'm not going to go over every detail, but you have a traditional idea production function. Q dots, the new ideas that you're generating. R is the resources that you're putting into generating those ideas. Relative to the accounting model that we had before, we do make one restriction that's much less general than we allowed before, and that's that we have to parameterize the comparative advantage distribution of how different capital productivities relative to labor productivities vary across the task space. And that's what this FI function is. Then there's a classic resources rate, capital accumulation, an exogenous rate of growth of population, and fixed investment rates in research and in physical capital. We're going to consider three different possible views of the world. One is a view of the world where in finite time, all tasks are automated. Machines are doing everything, humans are doing nothing. We'll compare that to a world where for all time into the infinite future, humans are doing some positive share of tasks. And then there's an intermediate case, this blue line here, which says over time the share of tasks that humans are doing is getting smaller and smaller and smaller, but at any finite time humans are still doing something. And by playing around with that FI function's intercept at 1, we can select which of these three cases we're thinking about. We're going to do a calibration to historical values. In order to estimate the slope of comparative advantage between capital and labor, matching the historical capital share and automation cutoffs, the amounts of tasks that have been automated, is important. And then we're going to consider these two scenarios that I told you at the beginning. We're going to consider a scenario where AI is nothing special, it's just the next stage of the automation process we've been going on for decades and decades. The way we're going to do that is calibrate the psi k hat minus psi l hat to the historical private business sector values. And then we're going to consider a much more aggressive, maybe too aggressive scenario where the entire economy, including your haircutter and your gardener, has the productivity growth rate, once they're automated, of the computer sector from the past few decades. Here's what the future looks like under that first scenario, where AI is just a continuation of the past. You can get a scenario where you're converging to an AK model, where the capital share is 100%, that purple line, where you're converging to an AL model, where the labor income share is 100%, or something in between, where you converge to a constant labor share of income. And it really depends. Think about the Baumol cost disease. The scarce resource gets the reward. And so if there's some things that only humans can do, and they continue to do that forever, well, now think about that simple model I gave you. The difference between having 10 of an abundant factor and infinity of an abundant factor isn't that different. You have infinite amounts of the goods that are the tasks that are produced by capital, because the capital productivity growth rate is so much larger than the labor productivity growth rate, that what you're really bottlenecked by, the weak links, are the things that humans are still doing, and then they can get a lot of the returns. What does that mean for growth rates? Well, you can see that growth rates are accelerating in all the cases that we consider, but the growth rate is slow. You do get explosions, 100% infinite output and finite time in the AK model, but in all three scenarios, you get relatively slow acceleration of the growth rate. And you can say by 2070, we're only 15% higher output than a constant growth rate trend. And so weak links are leading to this slow acceleration of growth. Three very different long-run futures, but they're all indistinguishable over the next few decades, is another takeaway. If you go to the more aggressive scenario, Moore's law everywhere, well, now you get these same three outcomes, the AK world, the AL world, and the constant labor share world. But if you look at the horizontal axis, the time scale is dramatically reduced. And now you start to see much larger increases in output and changes in the capital share at a much faster rate. How does that turn into output and growth rates? Well, you can see we're instantly at a much higher growth rate because now we're applying Moore's law to the entire economy, but also the growth rate is going to accelerate much more rapidly. So by 2030, you can start to see growth rates of 7% per year of GDP per capita. What does that mean for output? Well, you can get infinite income before 2060 unless you're in the case where labor needs to be done on some tasks forever. And so takeaways from this part is that growth can explode, but even an explosion can be slow, even in this very aggressive scenario where we're doing Moore's law everywhere. It takes decades. In my last slide, I want to tell you sort of some intuition for why the explosions can be slow. And so a key measure of dynamic increasing returns is this phi parameter. When it's less than 1, semi-endogenous growth, where the growth rate in per capita income is just the population growth rate, 1 is the knife edge, and greater than 1 is explosive growth. In our calibrations, the historical private business sector puts us just below 1 at 0.98. What that means is we're converging to an economy that has 47% per year growth in GDP per capita. It's not infinity, but it's really big. But going from 2% to 47% growth rates takes a really, really long time. Whereas in this Moore's law everywhere calibration, we're way above the 1 into the explosive growth range, and that's why we get faster growth. Just mapping, finishing here, just mapping this back to the data, you can see sigma and x0 showing up in this phi. If you have stronger weak links are more binding, then you're going to have a longer time for the growth explosion to occur. And if you're automating more quickly, you're going to have the growth explosion happen faster. So let me conclude. Historically, switching from slowly improving humans to rapidly improving machines on an increasing share of tasks is where growth came from. And explosion growth is possible, but it's going to be slowed by weak links. Having AI do amazing things on a subset of tasks doesn't necessarily mean you're going to have humongous increases in the aggregate share of tasks. I'll finish here.
Thanks, Chris. Discussing this must go to step up.
All right, so let me start with a survey. Today we learned that surveys are very important. So the survey is, who thinks that AI is going to leave the labor share unchanged in the next 20 years? Raise your hands. Unchanged. Who think in the next 20 years? Who thinks that AI is going to reduce the labor share to 50%? 50. Raise your hands. Okay, who thinks that AI is going to reduce the labor share to 1/3? Okay, now we're getting extreme. Michael, maybe. Okay, that's good. I'll get back to why this is important in the end. Now,
have you recorded this?
Yes, this is reported live in YouTube. So now the world knows that economists do not believe AI is taking over.
You can watch it for years.
Anyway, so this is a super ambitious paper that is asking two important and related questions. So the first one is, what is the nature of technological progress over the last 60 years? And the second one is, given that nature of technological progress, when we project that into the future, are we on a path to explosive growth? And not only that, but how fast, if we are, is that explosive growth going to happen? So in my discussion, what I want to do is that I want to revisit the accounting just a little bit, and that's going to be the first part. I broadly agree with the accounting. I think that that makes a lot of sense. And then I'm going to focus especially on the explosions and when do we get explosions, how fast do they happen, and why do I think that the answer hinges critically on the question that I was asking you about what's going to happen to the labor share of the economy, and why I don't think their scenarios necessarily capture some of these things that you are reporting here. And so you could have some other scenarios where actually you explode way faster. Not immediately, as many people in Silicon Valley seem to believe, but still in 30, 45 years and so on. But I think the paper is providing the right framework for thinking about this, even though I don't think the scenarios that they have right now capture everything, which is fine. All right, so let's start by looking at the past. So when you work with these task models, what you realize very quickly is that they all aggregate essentially to a CES in capital and labor, where the only difference is that now the CES shares are kind of like endogenous, and they depend on the number of tasks that you've allocated to capital and the number of tasks that you've allocated to labor. And so here we're thinking of a world, here the sigma is the elasticity of substitution between tasks, because this is holding the task allocation constant, which is a point that Chris explained. And we're thinking of a world where there are three forms of technological progress. There's pure capital augmenting progress. Capital is getting better at the things that it's doing. Labor is getting better at the things that it's doing, that's the AL, but we also have automation. And the way to think about automation is a process that takes away from the share of labor and increases the share of capital. So it's rebalancing production towards capital. That's what it's doing. So the accounting is really about understanding the contribution of these three forms of progress. Now, of course, to do that, you need data. So we have data on TFP growth. That's kind of like one moment. That's going to tell us something about the sum of progress in AK and AL. We have data on factor shares, so that's useful. That's going to tell us something about the relative progress in AK and AL. So we need kind of like an extra piece of data, and that's where the rate of automation is helpful. So if you, and that's where they have to ask the LLM, they get this number of 2% of the share of value added produced by labor is automated every year. I think that that's plausible. And when you put these numbers in here, this is what you get. You get that the world can be described as follows. Capital improves very rapidly at a rate of 4% in the tasks that it is already producing. Labor doesn't improve essentially. It's kind of like we are the slow improving factor for the purposes of this discussion. I'm going to set it to 0. And the reason why we still get kind of like growth that doesn't decelerate is because we are automating tasks at a rate of 2% per year. And this is important because otherwise those advances in capital get bottlenecked. So let me make this point by looking at the capital share. So in this economy, growth is essentially going to be the capital share times 4%, because capital is the only thing that keeps improving. And in this economy, you can write the capital share in this way. So you're going to have the share of tasks allocated to capital, the AK term, and this third term is just capital deepening term, which doesn't really matter. It's not going to be moving around at all. So capital keeps improving in already automated tasks at a rate of 4% per year, because we have sigma less than 1 that is going to drag the capital share down by a significant amount. Actually, because we have sigma equals 0.2, that's going to reduce the capital share at a rate of 16% per year. So if we were not automating anything, the capital share would be decreasing at a rate of 16% per year. This is the weak links effect. But automation compensates for that almost exactly. So automation is increasing the capital share at a rate of 16% per year. So that comes from the 2% raised to the 1 over sigma, which is 4, and then you have to adjust for the fact that this is the capital share, not the labor share, so you get like this 16%. So that's why you get a constant capital share, and that is why growth is 4% times a third, and it's not going to 0 immediately. Okay? If we stop automation, growth would go to 0 almost immediately. So that's the accounting. I think the accounting makes a lot of sense. It's kind of like a nice view of what's happening in the world. So let's think about the future now. So the key question here is, are we in a world that is exploding, but in a good way, of course, in a way of generating lots of growth? So this is how they're tackling this question. So let's start with a generic production function. So forget about tasks for a second. So I want to think about a world where I'm producing output using capital and labor, and Q here indexes my level of technological sophistication. And this index of technology loads into the capital augmenting term with some loading or elasticity theta and some elasticity theta L for labor. And I want you to think of theta K as being way bigger than theta L, in line with the facts that we just saw from history, right? So as we improve technology, that disproportionately benefits capital above labor. Okay, so that is the production block. You can think of this H function as the induced production function that you would get by optimizing over the allocation of tasks, but you can think about this more generally as being any generic production function. Now, here comes the important part, lab equipment. So this is how new ideas are produced. So we are improving this Q, which is our level of technological sophistication, and we do so by investing resources. So when we invest a share of GDP into research, but we also get a drag from this term. You should think of this phi as being negative. This is the ideas are getting harder to find term, right? So it's a fight between how many resources we're investing and how fast ideas are getting harder to find. Now labor is going to be growing at a rate of n, and capital is going to accumulate a la solo. I'm going to make things very simple. I'm just going to assume that statically capital scales with output. That is what you get in the steady state of Solo, and I don't want to do transitional dynamics with Solo. They're boring anyway because it doesn't have almost any transitional dynamics. And so if I do that, I can substitute capital proportional to output, and I can solve for output per capita as a function of the level of technology. So that's this little function HQ. Now, let me plug that again in the idea equation. I get this very nice equation that tells me what is going to be the growth rate of ideas. So this equation tells me that the growth rate of ideas depends on the share of output per capita that I'm investing, which is given by the little function h. Ideas are getting harder to find, and population growth, as in any semi-endogenous growth model. Okay? Now, for intuition, let's study this equation in one simple case that even I can do with pen and paper, which is what happens when h is isoelastic. So essentially what happens when the production function is Cobb-Douglas. Okay, so let's imagine that h has a constant elasticity epsilon, and then you get this differential equation, and you can see this number popping up here, epsilon plus phi. So I'm going to call that big phi, and that is the dynamic degree of returns to scale in this economy. Okay, I settled with chat that that's kind of like a good number, but we are open to other suggestions. So we're going to have 3 cases for this economy depending on this dynamic degree of increasing returns. If that number is bigger than 1, you get a singularity in finite time. Okay, so what is the logic? You produce extra output, you produce extra knowledge. That extra knowledge expands the output that you can use to build labs and lab equipment more than ideas are getting harder to find. And so it more than offsets the ideas are getting harder to find effect, and that is why you get a singularity in finite time. Now, if this big phi is equal to 1, you get a double exponential. That's a knife edge, not super interesting. If this big phi is less than 1, you get semi-endogenous growth, and the growth rate of the economy converges to the spin down by the growth rate of population, which is essentially the reason why Elon Musk wants us to have more kids, right? Now, of course, the production function is not Cobb-Douglas. It can deviate from that, and I think that that's kind of like the crucial part of the paper, because when I think about weak links, automation, and all of that is about the shape of that production function. So we can now derive a more general, an equation for the general case in terms of m given by the inverse of the growth rate. So this is just like out of convenience. So it happens to be the case that if you work with the inverse of the growth rate, you can derive a differential equation for that object that depends on n and this increasing degree of dynamic increasing returns to scale at each point in time. So let me tell you how this works. So remember, m is inverse growth. So growth is going to be faster because of n, so that population growth makes sense because people come up with new ideas. But growth is also going to be faster if this measure of dynamic decreasing returns to scale is bigger than 1 at each point in time. Meaning the extra knowledge that I bring allows me to produce more than enough output to compensate for the fact that ideas are getting harder to find. Now, asymptotically, the behavior of this equation is also going to depend, well, locally this is what happens. Asymptotically, you're going to have the same 3 cases as before. It all depends on the limit of this the dynamic returns to scale and how they behave as q goes to infinity. So if you're above 1, you explode. If you're at 1, you get double exponential. If you're at less than 1, you get semi-endogenous. Now, the interesting thing is that this equation can also be used to understand how quickly do we get infinite output, right? So to make things concrete, let's put n equals to 0, so no population growth. And so you can see immediately, let's imagine that we start from m equals to 100, meaning that our current growth rate of ideas is 1% per year. Okay, so m is 100. Now, you can see immediately that what I need is this phi minus 1 to eat away this entire 100 that I had initially. So let's imagine that I have an economy that starts with a degree of dynamic returns to scale of 1.1. Right, so I'm eating at a 0.1 every year, so it's going to take me 1,000 years to get to infinite output. Okay, let's imagine that I start with an economy with a dynamic degree of returns of 2, then it's going to take me 100 years. Now 6, then it's going to take me 20 years. So this is showing that this object, not only in the limit, but also along the transition, the values that these dynamic returns to scale have along the transition are the key thing that is going to tell me how fast the economy is going to explode. Okay, another interesting thing that I learned, like before having worked with these models, I was thinking that every time that you cross the 1, like you immediately start feeling like weird. It's kind of like, oh no, like we are in the side of the singularity and everything accelerates and you feel that the world is feeling different. That's not the case. Like when you cross that boundary, everything is continuous. Everything just happens super far into the future, so you don't feel that anything is amiss. So it will be very hard from current data to know that you even crossed that boundary. Okay? So this begs the question then, what determines this phi? What determines this dynamic degree of returns to scale in this economy? Which brings me to the key takeaway of my discussion, which is when you think about this phi, remember that that's the elasticity of output with respect to knowledge, plus the ideas getting harder to find term. Well, I can express that. That's going to be a combination of the thetas, the loading on capital and the loading on labor. And crucially, this is going to depend on the share of capital in the economy. And the share of capital depends on my level of technological sophistication. Okay? Why is the share of capital important? For two reasons. Reason number one, capital improves faster than labor. So the higher my capital share, the more my economy is going to load on the fast improving capital. And the second is because capital is a reproducible input, so I get this extra loop. And this is why you have the 1 minus S here. So in particular, when S, the capital share, goes to 1, you're in an AK world, you explode almost always, or always explode, and that's what happens in an AK economy if you add a lab equipment component to it always, right? So you recover that. But you don't have to be there. But this equation makes it clear that if I want to understand what's going to happen with this dynamic increase in returns to scale, and therefore whether we're going to explode or not, and how fast it's going to happen, we need to understand what's going to happen to the capital share as a function of our degree of technological sophistication, which is the question that I was asking you all initially. So let's think about what I'm sorry, I forgot to mention something, that here you're also going to get a threshold above which, if the capital share goes above that level, we're in the region where we explode, right? And if the capital share is below that level, you're in the region where you don't explode and you're in the semi-endogenous growth regime, essentially. And that threshold is 37%, right? So if we are in 33%, we're kind of like in the semi-endogenous region. If we go up to a capital share of 50%, then we start being in the region where the economy explodes. And if we go there very quickly, then the explosion might be more rapid than what the paper has. Okay, so that's kind of like some of the points that I'm going to make now. So how to think about the capital share and how to think about how technology is going to affect the capital share in the future. So the first point that I want to make is that I think that history is not going to help us a lot here, because historically the capital share is constant, but AI is kind of like this new thing, so we're really trying to forecast how the capital share is going to behave in the future. We don't know. I mean, we don't know. It's all about introspection at this point. I think introspection is better than data if you're asking this question at this point. But let's think conceptually in the model what's going to happen. So Chris mentioned this function Fi. This Fi is the comparative advantage of capital relative to labor in each task. So the way that these models are going to work is that you're going to rank tasks according to that, and there's going to be a threshold that depends on Q, right? That is going to tell you the tasks to the left you're going to allocate to capital, and the tasks to the right you're going to allocate to labor. Okay? So now let's think about the capital share. This is the formula that I showed you before. The capital share depends on the mass of tasks that are automated and how productive capital is at the tasks that are already automated. What happens when Q increases? Well, you have two effects. Effect number one, which I'm going to call the intensive margin effect, is, well, capital is getting better at these tasks, but because we are in this weakling world, the capital share is going to go down because of that. Okay, so that's going to push the capital share down, and that's going to decelerate the growth explosion or backload the growth explosion. But then you get another effect. Well, capital is getting better, so if I'm a firm, what should I do? Well, I'm going to automate the marginal task, because before I was indifferent between capital and labor. Capital improves faster when technology goes up, and so I'm going to automate more tasks. And that's the extensive margin effect. So more tasks are automated. So every automated task has a smaller share of value added, but at the same time are automating more tasks. Now, what determines who wins? Automation versus weaklings? That's going to be the curvature of this Fi function. Now, in the past, we know that that function had certain curvature that we can estimate for the data, but my point is that we know very little about the curvature of that function going forward, especially because that curvature might have changed with the creation of AI. So let me show you some of the scenarios that they provide. So it turns out that with the specific functional form for Fi that they assume, you can show by pen and paper again that the induced production function aggregates to something that is essentially Cobb-Douglas. So we are having something where the capital share plotted here against our level of technology in their baseline, that's not changing at all. So those of you who answer like the labor share is going to remain at a third, that's kind of like a scenario that is going to represent what you were saying. Doesn't matter if we have 2 times our level of technology, 4 times, 8 times our level of technology, the labor share, the capital share, sorry, in this scenario is going to remain around this point. Now, they do have 2 other scenarios. One is scenario where the FI function has something different, but it's only different in the tails. So you only start to see that when you get far up in here at 4 times our level of technological sophistication. That's when the scenarios start diverging from each other. So this is a scenario where at 8 times our level of technological sophistication, the capital share plummets because there are some weak links that you can never automate. And here's a scenario where you go to full automation because the F function is such that that's what you're going to do. Okay. Now, these scenarios are fine, but my point again is we have no idea how this looks. So it might very well be the case that with AI, the right scenario to consider is something that looks like this. So maybe AI is something that allows us to increase the capital share in the economy to 60% when we have 2 times our level of technology. Actually, 2 times our level of technology is a lot. So imagine the amount of things that computers are going to be able to do when we are 2 times as technologically sophisticated as we are today. So this is not implausible. It might be the case that when we are at that level, the capital share goes to 60% immediately. And let me show you what happens with growth in this scenario. So if you've been following, what I said is, well, the capital share goes up more rapidly here, so I'm more quickly running into this region with a dynamic increasing returns to scale, and so I get faster growth, and voila, you get an explosion. The explosion, again, is not happening tomorrow, it's not happening in 5 days, it's happening in 50 years. So the bottom line is, I see this paper really as an invitation. This is a paper that is telling us we should study the question of how fast these weak links can be automated, which is precisely what this FI function has information on. We should be all studying that question. The relevant question is in research. So the weak links that matter here are not plumbing, roofing, because what matters is the idea production function. And that's interesting because there are many stories for weak links that are about people and how we care about people, where for research that's irrelevant, right? We don't care about people, we just care about knowledge. And so this is an invitation to do that and to start measuring what is happening to the capital share of R&D. Is that object going up? Is that object going down? What's happening to it? And I think chat can tell us the answer soon. Thank you.
Okay, questions?
Great, so in the theory, something that's very important is this elasticity of substitution parameter. As I understand it, in the theory, we should probably think of that as some kind of long-run aggregate elasticity of substitution. In lots of our frameworks, of course, we take this as a parameter and a convenient CES aggregator. But of course, there are other ways of thinking about this that I think might be relevant in the context of AI and these big changes in technology. So just as one jumping off point, for example, you think of, say, Koopman's activity analysis, where you think you have a range of technologies, and that set of technologies might be changing, and our abilities to adopt those technologies might be changing. We could think that sigma itself as a parameter might change, and I just wondered, have you thought about whether or not the empirical methods that we're using to benchmark reasonable values of the substitution elasticity might continue to be the relevant ones under the counterfactual scenarios you're considering?
Yeah, no, this is a great question. So I should thank Pascal first. He highlighted all the things I think that are important. I think this question of what is, so you're asking maybe sigma's not constant, maybe sigma's heterogeneous across sectors. How does it aggregate? How are we going to? I agree with all that. I think is sigma greater than 1 or less than 1? Is a question that at least people in this room or outside this room have debated. I will say part of what I liked about the computer example that Chris presented, in your pocket now, you have 100 million times the number of transistors of the computers of the 1970s. Put computers' factor share up there, 0.04, whatever. We're not 100 million to the 0.04 more productive. Maybe we're twice as productive or 3 times as productive. And that sort of tells you that's the weak link story, right? We have infinite compute, and now we're bottlenecked by everything else. The matrices get inverted quickly. I have to decide what data to put in the matrix. So I think this weak link view of the world, the computer factor share, here's another way to say it. If we had sigma greater than 1, the computer factor share should be exploding. So I think actually there's decent, compelling evidence along those lines that sigma's less than 1. But how much less than 1? If you make sigma 0.8, those explosions are going to be incredibly fast in our model. If you make sigma 0.2, you saw they're surprisingly slow. And so I think this question of what's the right value of sigma, even if you just start with homogeneous sigma, and then as you point out, maybe it changes, maybe it's heterogeneous. I think those are well beyond. I think we could first sort of say, sigma 0.2, 0.5, 0.7, that would be enormous progress already. But yeah, thanks.
If labor is the key bottleneck, and if you were allowed for training, is there a huge payoff to training?
Yeah, this is a good question too. In our setup, we're using the BEA, BLS, multi-factor productivity data, right? And so they've got all the different kinds of labor, all the different kinds of human capital are in there already, and we've taken them out when we're looking at TFP. And so the, get better educated labor is in some sense taken out. So when Chris says, yeah, how much better are we? It's literally how much better is the person with a PhD in economics, today versus 1970 at inverting matrices in their head, I think, with no pencil or computer. I do think, more broadly, the kind of thing you're saying is right. Everything is potentially a weak link. So in the paper with Ben and Philippe, we use the phrase bottlenecks. And there's a lot to like about bottlenecks. So you hear bottlenecks, Balmo's cost disease, weak links. They're all just sigma less than 1 in the relevant space. Once sigma's less than 1, the stuff that's improving slowly is the bottleneck. And yeah, find ways to improve that is exactly the right thing. So I think that's totally a fair point.
What if we are in the realm of adding more tasks, and all those tasks are going to be done with the capital, and then there might be more substitutes, aggregate sigma could be different than what we observed?
Do you want to take this, or do you want me to take it? Okay. So a couple of important things to realize. We don't have our slides. The task model has elasticity of substitution sigma less than 1. It also has, task I is produced with K plus L. So you've kind of got this nice setup where you have both complementarity and substitution. And the interplay between complementarity and substitution, I think, is why the task model is such a powerful framework for studying things versus, say, a CES where you just have one of those things. Now, in our setup, what about new tasks? Well, importantly, you can only add new tasks where the elasticity of substitution is bigger than 1, where it's love of variety like Romer. If it's sigma less than 1, it's hatred of variety. You don't want to add more weak links to your production function. You want to get rid of weak links. And kind of making the infinity is kind of like getting rid of a weak link. And so there are 2 ways you can do it. You could take our framework and put an extra CES on top. There are new varieties, and new varieties come with new tasks. We explored that a little bit. It kind of makes it more complicated without adding enough insight in our view. Or the clever idea that we thought of is down here. Here's another place where there's substitution, right here. And you can think about adding new ways to use capital or new ways to use labor to produce stuff. We call those new procedures. And you can see that our framework already nests that. So you could think of the increase in psi KIT as, no, you came up with the GPS-enabled tractor, and that's a new procedure for producing something. So our quick way of doing it is to say new procedures, but there are other ways. But you do have to be really careful about this sigma less than 1. You don't want to add new tasks there, because that's a bad, not a good.
So if my understanding is correct, so I think the final goods is used as input for the idea production. So basically automating tasks in the final goods is directly related to automating tasks for the research production. So have you thought about those maybe somewhat different, and then you can use your approach, but specifically for the idea production in terms of automation?
Yeah. Pascal got at this right at the very end, and we think that's exactly right. So we're making the model simple and buying us a lot by saying you use goods to produce ideas. And that way, when you automate the goods production function, you're also automating the idea production function, and we don't have 2 sets of tasks to carry around, so it just makes everything a lot easier. I think for For the first way of looking at things, I think that's a useful way. Of course, you know, for the second way of looking at things, I don't think so. So as Pascal noted, you know, in producing ideas, yeah, we don't care about, you know, humans and entertainment and things that humans do. We just want to get the idea. So probably the production functions are different and the automation process is different. You know, one of the things that's going on here, I think people probably appreciate this now, there's kind of a race in the model between this flywheel effect and weak links. And the flywheel effect is more ideas gives us more automation and AI, and that gives us more ideas, and that gives us more automation and more AI. That flywheel absolutely wants to explode. And it eventually does, unless you say they're just sub things that can never be done by machines. You always have to have humans, and then it's like the software example. And so, you know, it's really this race between the flywheel effect and weak links. And weak links, if you can automate everything, weak links only slow the process down. So I like Pascal's way of saying it. We need to know that f of I function, and does the f of I in the past look like the f of I in the future? You know, that's a really hard question, because if it's changing in the future, there's nothing in the past to tell us. We're kind of, you know, at a loss there. I will say, you know, the capital share has been remarkably stable in the aggregate in the past. That tells you something about the FI, so that constant elasticity form kind of matches that fact. I guess one thing related to this point while I'm talking, you don't need the capital share to rise for the explosion to occur. So constant capital share, you can get the explosion. So that was something that, you know, got a little bit lost in translation there. But so definitely if it keeps rising, then it makes it easier for growth to explode. But even with a constant, growth can explode. Yeah, Jörn.
So some of the weak links or bottlenecks in our lives seem to be organizational, like any of us who dealt with university administration. Do you anticipate that, like, we will automate the deans and the presidents, or when other people
Yes.
or we'll find some other mechanisms to get around, like bureaucracy, red tape, and things like that?
Yeah, no, I mean, so if you're an economist, like, you see weak links everywhere, and you think it's going to be a long time before growth explodes. And so I hope you looked at this paper and said, wow, Chad and Chris think there's a chance that growth's exploding in 100 years. They're insane. In Silicon Valley, they tell me, you know, I'm insane because I think it's going to take more than 10 years for growth to explode, and they think it's happening tomorrow. I think the answer is exactly what you said. You know, there are just a ton of bottlenecks in the economy. My favorite example actually is Waymo. So you come to San Francisco, you can ride in a Waymo, anyone can do it. I hope you've done it. You should definitely do it. You know, the self-driving car DARPA Grand Challenge was 2004. By 2012, we thought self-driving cars were around the corner. It is solved now. You can take them. The technology's there, and yet less than 1% of cars in San Francisco are kind of self-driving. How long is it going to be before, you know, half of new cars are self-driving? Maybe another decade. And so why is that? It's weak links, right? It's that there are all these edge cases you have to solve. There's all the weather issues. There's the fact that the sensors and the computers are really, really expensive. You have to wait for Moore's Law to drive down those prices. I think there are weak links everywhere. The AI people would say, hey, once we have this super intelligent AI, it's going to help us solve all the weak links. And yeah, Chari over here, you can't wait to have the university president be a computer. You know, yeah, we'll see. It's a good question. Gabe.
So in your production function, you have capital and labor, and you could have thought about raw materials and energy. And I don't think you have to be a total degrowther to think that if we're producing an infinite amount of stuff, maybe we'll run out of raw materials, or maybe we'll have some other problems that come from using a lot of energy. So that feels like it might be quantitatively important, but you haven't talked about it at all.
Yeah, no, I think it does matter. Like, obviously, literally infinite growth, you probably don't want to take that seriously, but growth rates accelerating to 20% per year, like, you know, that would be totally mind-blowing for all of us in this room. You know, so in this paper on optimal population with Pete and Maya Eden, we've been thinking a lot about natural resources. And so when do those constraints start binding? I'm not sure they start binding really, really soon. If you take 100 billion people and put them in cities the density of Paris, you use like 5% of the habitable land, right? So, land we're not running out of. You might say maybe there's some rare earth thing that we're running out of. You look at the prices of key natural resources, they're cheaper now than they were 100 years ago, right? So we keep finding stuff, we keep finding ways to substitute around them. So if you want to say, are we really going to reach infinity in 100 years, then that's going to be binding, I agree. But for the purposes of our discussion, I think that's not the binding constraint in the near term, but I totally agree. It binds eventually and is worth thinking about.
Yeah, I have a very related question. I mean, once we start talking about infinities, then like the number of atoms in the galaxy becomes a potential. Silly sounding, I know, but we're in this world now. So you could try to get some illustration of this to add some fixed factor, and just see how much do you need to strengthen that fixed factor, and what does it change? I mean, you won't be able to calibrate the number of atoms in the galaxy, but like some illustration of what that changes, I think would be interesting.
Yeah, no, I totally agree. That's an interesting thing to do, and I think I understand how to do it now, thanks to the paper with Pete and Maya, and it's totally cool how it works and interesting. But yeah, this paper, I don't know if you looked at it. It's also a bear like Greg's paper. It's just too long because we have all this empirical stuff to understand the past, and then want to go to the future. So it might have to be for the next paper. But I do agree it's an important and interesting thing.
1 minute for one last question.
Great, Basil.
So this automation function that has basically emphasized, if I understand correctly, you have this one-dimensional process where your AI is smart as a high school student, college student, that says it's a PhD and automate, it can do anything in the economy. Do you have thoughts on what, or if at all things would change qualitatively or just quantitatively if you had something like heterogeneity, some richer task structure there? Like, how do you think about that in your framework?
Yeah, it's a good question. I think for sure heterogeneity can matter, and I'll appeal to some work that you've been doing, the paper that you presented in the growth group yesterday. There are other ways to write down this structure that I think are interesting. So you could say, hey, the Frontier AI Labs, they've all stated publicly that they're trying to automate AI research. So they want Claude to build the next Claude or GPT to build the next GPT, and they've said they think in the next 2 years we might have this, right? For that, you might want to write down like an AI production function and think about automating that, and then you've got heterogeneity, across the sectors of the economy that totally can matter. And so I think what I would say, as I've thought about it, I think in some ways it totally matters. You get this, software explosion or AI explosion. Then there's also all the other weak links in the economy. So how soon does it change education and the government and the healthcare sector? That relies on all the other weak links. But I do agree that the model we wrote down and this richer model would probably give different answers in interesting ways, and that's definitely the next step, and we should all do it.
Okay, thanks.